In this video, we're going to add some floor elements to a building model here. So floor elements are just simply the horizontal planes in the building. They represent the actual floor slabs. And to create them, we go into a special mode called sketch mode. So let's go ahead and get started. On the architecture tab, we're going to use the floor button. Now you really only need to click the top half of this button, but if you prefer to use the drop down, just make sure you're choosing the floor architectural option. It's the same button as the one at the top there. That brings us into sketch mode. Now, what is sketch mode? Well, it's got some pretty noticeable characteristics. The first is that the drawing window grays out and becomes kind of halftone. Okay, so that's one clue that we're in sketch mode. The next is that the modify tab of the ribbon is now tinted in this greenish color. And then perhaps the most noticeable feature of sketch mode is the presence of the cancel and finish buttons right here. And those buttons are used to get you in and out of sketch mode. So the only way that we can leave this mode is to either cancel it with the red X or to finish it with the green checkbox. And we'll see those in just a few moments. But before we do that, let's talk about the other default settings that are in place here. Notice that this boundary line tool is already active. We're going to leave that. Notice that here in the draw toolbox, there's lots of shapes, but the pick walls tool is already active. We're going to keep that. Now, when Pick Walls is active, here on the options bar, you will also have this checkbox for Extend into Wall Core. We're going to leave that checked. Okay, so it should already be checked, but we're going to make sure that it is and leave it that way. Finally, the default type that we're using here in this file is generic 12-inch if you're working in imperial, or generic 300 if you're working in metric. So if any of those settings weren't in place, then go ahead and configure those now to match my screen. And then let's get started by selecting our first wall. So I get a little tooltip there that says pick walls to create lines. I'm going to pick this top wall here. And when I do, it's going to trace over it with this magenta colored line. Now, you'll see that there's this little flip control on that line. And if you zoom in a little bit more closely, you can kind of see what's going on here. Now, we're working in the L1 working plan in this file. So you can see down here. And I previously set this to medium level of detail. And with medium level of detail, you can see that the layers of the internal structure of the wall assembly are showing. And that magenta line is on the face of the inside of the core. Now, if you were to click the flip grip, it will move that magenta line out to the outside face of the core. But notice it doesn't go all the way out to the exterior of the wall. And that's because there's a small layer of drywall there that accounts for a little bit of additional thickness. So when you do extend into core, you're tracing either the inside or outside face of the core of the wall. Let's make sure it's the outermost face, and then I'm going to zoom back out and continue here. So just verify that all your settings are still in place, boundary line and pick walls, and then I'm going to continue around like so and stop right there. I'll do this short wall here and the horizontal here and there, and I'm skipping this one at the front. Notice that at the front, this is in two pieces here. Okay, so I'm not going to pick the long lateral one off to the right there. Now, in order for us to be able to click the finish checkbox, we must have a valid sketch. A valid sketch is an enclosed loop or an enclosed ring. If you tried to click finish, it will generate a warning down in the lower right-hand corner. Now, it will highlight the offending area in orange on screen. And of course, that's the area where we didn't draw a sketch line. And of course, you're seeing that the error is telling us that we must have a closed loop. Now, if you click quit sketching, it's going to cancel all the way out of the command. So don't do that. What we want to do is continue and just fix that problem. So there are two easy solutions. You can either touch this wall and add another sketch line. I don't personally like having two sketch lines touching endpoint to endpoint like that. So what I prefer to do instead is go to trim and extend to corner. And I'm going to take this small line here and trim it up to this one. And that will achieve the same result, but it will make this one continuous line across the front there. Honestly, you can do it either way, though. It really doesn't matter. And now you should be able to click the green finish checkbox to complete the sketch. Now, when you do, you'll get this message asking what you want to do with the overlapping walls. Now, we don't see those overlapping walls in this view. I'm going to show them to you a little bit later. But for now, what I'd like you to do is just say don't attach. And I'll come back and discuss that topic a little bit more later on. So in the meantime, you can see the floor shape has been created and it's still selected. And if you notice that there's something wrong with it and you want to make a correction, notice that there's an edit boundary button right here. You can click that and go right back into the sketch. You could select something that you want to change. You could modify it. And then as long as you still have a valid shape, you could click finish and complete that sketch and it would modify it based on your changes. If you change your mind and you want to go back to the original, that's when the cancel edit mode would come in. So if I click cancel, it will warn me, are you sure? I'm going to discard your edits. I'm going to say yes here. And it goes back to the original shape, which is what I wanted in this case. So that's the basic workflow for creating a floor. It's a pretty straightforward process. So let's repeat that process on the second floor. So I'm going to double click L2 working, and that opens up that floor plan. And now let's just go through the whole process again. So I'm going to go to the floor button. That puts me in sketch mode. I'm going to accept all the defaults again, and I'm going to pick the top edge, this one over here. I got the wrong one there, so let me do a Control Z to undo that and try again. This one over here, this one at the bottom, and this one right here. Now, in this case, I want a double volume space here next to the stairwell looking down over a balcony. So I don't want to continue around that opening. So what I'm going to do instead is go to my trim and extend to corner, pick the vertical line right here, and then it matters now which side you click on the horizontal line. Don't click this side because it will give you the wrong sketch. You want to click the side you want to keep. So I want to keep to the left, and that will enclose that shape there over on the left. Now, I'm going to click the modify tool to finish and zoom in here at the stairs. This is a valid sketch, and I could click finish edit mode. The trouble is, somebody coming up the stairs here wouldn't be able to get across to this landing. So we need to adjust the shape of this just a little bit more. So what I'm going to do for this is here in the toolbox, I'll scroll up and I'm going to just use the straight line tool. I'm going to trace right along the front edge of this stair, pull it laterally across in a horizontal direction here. And I'm going to go 1'6" if you're working in imperial or 450 millimeters if you're working in metric. And then I'm going to pull it down at a 45 degree and I'll just sort of stop right about there. I'm going to click the modify tool to finish, go to trim and extend to corner, take this horizontal line at the top and extend it to this vertical one that I drew here, take this diagonal line and trim it down to this vertical one here. Again, remembering to pick the lower portion because that's the piece that you want to keep. So now that floor shape makes a little bit more sense and allows folks to get up the stairs properly. So let's click finish. And this time we're going to get two questions. So we're getting that same question we saw earlier about the walls that go up to this floor. Now, last time we clicked don't attach. This time I want you to click attach. And again, I'm going to show you what that did in just a moment. That zooms us out and takes us to this message. This one is a little bit more visually confirming here because it's highlighting all of the exterior walls and asking us if we want to do a join geometry operation on those situations. And I'm going to answer yes here. Now, to really understand what both of those questions did and to understand why we didn't answer yes the first time, let's cut a section through the model and take a look. So to create a section is easy. You just come up here on the quick access toolbar and click the section tool. So I'm going to do that. And then I'm going to start just outside of this window, click and drag to the right a little bit, and then click again. And that creates a section. To open this section, just click away from it, select it, right click, and choose Go to View. And it's going to open that section view up. I'll zoom in on it. And now let's talk about what those questions actually did for us. So the first question said, would you like the walls that go up to this floor's level to attach to their bottom? Here's an example right here. This wall actually goes up to a top constraint of L2. L2 is there. So had we answered no to that question, it would look like this. I'm going to do detach top and base and click this wall. And you see how the wall would have gone right through the floor assembly. Instead, we answered yes. We said attach, and that's this button right here. And when we did, it attached to this floor. And so you could see it pulls that top of the wall down to the underside of the floor. Okay. So often that can be a nice relationship to establish. The second question said, would you like to join geometry? And that's what we're seeing here with the exterior wall and the floor. And when you select them, the shading kind of tells you what's going on there. Even though we did extend into core, when it pulls those two pieces of geometry together, the join is merging in that all and making a nice clean intersection. Had we said no, it would have looked more like this one, where these two, the wall and the floor, are just ignoring each other. Now, the reason that this one looks this way is these were the walls that were asking us in the first floor if we wanted to attach to the underside. Had I selected that and chose attach top and base, it would have looked like that. And you would have had this weird little notch here on the outside of the building. So this is why I chose not to attach. So I think here it makes more sense to use join geometry. So if I go to the Modify tab and choose Join Geometry, pick the exterior wall and the floor, you're going to see it looks like this. Now, if you don't want the floor to dominate over the wall, it turns out that the Join Geometry tool has some options. So you can join, you can of course unjoin, which would reverse what we just did, and you can do switch join order and select this, and then it will look like that instead. So feel free to use whichever one matches your preference, and feel free to explore the other connections in this model by cutting additional sections if you wish. In this video, we're going to add some roofs to our building model. Now, the tool that we're going to use is the footprint roof tool, and adding roofs with the footprint roof is very similar to adding floors. So if you watched the previous video on adding floors, then a lot of this is going to be essentially review. Now, I'm in a floor plan called high roof, and the trouble that we're going to have initially is that all we're really seeing here is the columns. Okay, so this is simply because we're cutting above the building and we don't really have any wall geometry here visible at this height. So to remedy that and to make it easier for us to build our sketch, what we're going to do is temporarily turn on an underlay for this floor plan. So make sure that nothing is selected on screen. And the properties palette here should say floor plan. And if it does, scroll down and you're looking for the underlay setting. There's an option here for range for the base level. I'm going to set that from none to level 2. And then when I do, you're going to see the geometry of level 2 ghost in as an underlay. And what's nice about that is that's the live model geometry in the building. And we can use that now as a reference to create the roof element. So having done that, we can now come over here to the roof by footprint tool. Now it's similar to the floor tool. You really only need to click the top half of the button, but if you prefer the drop down, it's roof by footprint. So just make sure you're choosing that roof by footprint tool, and that takes us to sketch mode. Now, if you watch the video on floors, then this sketch mode is very similar. So we're going to accept all of the defaults here, boundary line and pick walls, but we are going to change a few things on the options bar. Okay, so we don't want to extend into core this time, so leave that unchecked, but we do want to introduce an overhang. So if you're working in the imperial file, put in 2 feet here. And if you're working in the metric file, put in 600 millimeters. Now I'm going to do the generic 9-inch for imperial, and that should be generic 250 if you're working in metric. So the difference now is that if you come over here and hover on one of the exterior walls, notice that the line that's going to be created is set at whatever distance you set your overhang to instead of going right on top of the wall. So I'm going to click on this wall right here, this one here, this one down at the bottom, and then this one right here running vertically. Now there are some gaps. So as we saw in the video on creating floors, if you tried to click finish right now, it would generate a warning because you don't have a valid enclosed sketch. What I'm going to do is go to trim and extend to corner, and I'm going to trim this one to this one to close up that corner, and this one to this one to close up that corner. Now I'm going to click finish here. And before I do, I just want to point out the presence of these little triangles. Okay. So those are meaningful because that means that these are sloped edges. So let me show you what that looks like by clicking finish. You're going to see something occur here with the roof, and it's got these little chamfered corners, but it's not showing us the full roof object in this view because of something called view range. Now, we're going to discuss view range in a future video. So for now, we're just going to ignore that. And instead, let's look at this in 3D. So I'm going to come up here to the default 3D view icon, click that, and you can see if you zoom in here, and maybe hold the shift key and orbit slightly, you can see what that created. So with those triangles, it was indicating that the edges of the roof were going to be sloped. And so what we ended up with was a hip roof. Okay. Now, I don't think a hip roof is maybe the best choice for this building. So I'm going to select it, and then we can choose Edit Footprint to make modifications. So I'm going to modify that. And it turns out that you can click any of these sketch lines, and there's a few things you can do. You can edit the individual slopes of each sketch line, and you can also disable the slope of those sketch lines entirely. So what I'm going to do is select this sketch line out at the front here, this one right here at the back, and then I'm going to turn off Defines Slope. When I do, if I click Finish, you're going to see that we now have a gable roof. Now that's a little better, but it's a touch too steep right now. So in addition to being able to change the slope individually, sketch line by sketch line in the sketch, when you're outside the sketch, you can come over here to the properties palette and change the slope of the entire roof. So that will change the slope on both sides. So you won't have to do them one at a time. So here in the imperial file, I'm going to put in 3. Now this is rise over run in the imperial file. So it's 3 inches of rise for every 12 inches of run. And when I apply that, you're going to see that roof get significantly shallower. If you're working in the metric file, put in 18.5. Now that's in degrees in the metric file. So it'll be 18.5 degrees, and it should have a similar slope. Now that looks a little bit better, but I still want to make one more modification here. So I'm going to click Edit Footprint, and I want to chop off this corner of the roof here so that it matches more of the shape of the building. So here in the toolbox, I'm going to go back to Pick Walls. It should still have my overhang setting. I'm going to leave that, but I'm going to turn off Defines Slope. So before you create the sketch lines, you can decide whether or not they're sloped. And then I'm going to touch this exterior wall here and this one here. And if you're fortunate, it should do all the trimming for you. But if for some reason it did not do the trimming automatically, you can always use Trim and Extend to Corner to get a valid sketch. And when you're done, click Finish. And now you can see our completed roof form there, and it matches the shape of the building. So we're going to create a couple more quick roofs here because that's just one type of roof, right? We started with a hip and we turned it to a gable, but there's plenty of other shapes of roofs that you can create. So let me go back to the roof plan here, and I'm going to focus on this wing of the building now. And in that location, I want to do a completely flat roof. Okay. So I'm going to go to Architecture, Roof by Footprint. I'm still going to do Pick Walls. I don't want to extend into Core. And this time, I want to turn off the overhang. So I'm going to set that to 0. Now, Define Slope should already be off based on the sketches that we just did a moment ago. But if for some reason it's on, go ahead and uncheck that. And now you should be able to click and do the inside faces of these walls over here, and then this one right here. And that should make a nice closed rectangular shape. If for some reason it needs trimming, go ahead and use Trim and Extend. And then let's click Finish. Now, if we go back to 3D, there's one small problem. It is much too tall. Okay. So what we're going to do is keep that roof selected, and then on the properties palette here, instead of basing it on the high roof level, we can drop it down to a different level, like low roof. And when I do, you're going to see that roof drop down to a more appropriate location. So That's the second roof that we want. And then finally, we're going to create a third roof out in front of the building that will provide like a canopy for a walkway at the front entrance. So back to the roof plan and back to architecture and footprint roof. I'll start with pick walls without defining any slope. And I'm going to pick this exterior wall here and this one here. Now, those are really the only two that we can use pick walls on. So now what I want to do is just draw a straight line, and I'm going to start right at this endpoint here at the edge of the building and just kind of pull that straight down, and I'm going to either type in or snap to the distance I want, which is 9 feet in imperial or 2,700 millimeters if you're working in metric. Now, this edge, I want to define slope. So I'm going to pull it across and just sort of draw it like so, press escape 2 times to get all the way out. So I'm going to select this line, check the define slope box, and then for the slope in imperial, I want to do 2 in 12. And if you're working in metric, it's 9.5 degrees. Now I do need to clean up this sketch. So I'm going to do TR or click the tool right here and trim and extend each of these corners to create the rectangular form like so. And when we click finish, because it's only sloping along one edge there, when we go back to 3D, you'll see that it's a very subtle shed roof. But once again, it's too tall because it's set to the high roof. This one I'm going to move down to L2, and that brings it into a more appropriate location. So those are the 3 roof forms that we need for the basic form of our building. In this video, we're going to look at the attach top and base command in a little bit more detail than we have previously. So just to remind you of what this command does, we've got this gap here underneath the roof at the tops of the walls, and I'd like to fill that in. And so it's pretty easy to do. All you need to do is select the element that you want to attach, in this case, the wall, and I'll pick one of these exterior walls here. And then over here on the ribbon, you've got this attach top and base tool. Click that, and then it's going to prompt you either on screen or on the status bar to select the roofs, floors, ceilings, or topo solids that you want to attach this wall to. So I'm going to highlight the roof. Now, in order to make sure you're selecting the roof properly, make sure you're clicking near one of its edges. Okay, so I'm going to click right here along the ridge line, and you will see it attach that wall to the underside of the roof. Now I'm going to hold the shift key and drag the wheel to orbit around so you can get a much better look at that. Okay, so that's really all there is to this command. Okay, now let's look at a way to do that a little bit more efficiently, because I could certainly go around and do each wall one at a time, but there's going to be a faster way. So let me deselect it and undo. I'm going to start again here. And what I want to do instead is leverage chain selection. Now, you may recall that chain selection is where you highlight one wall, press the tab key, and it will go down endpoint to endpoint and select other walls that are connected end to end with that current wall. The trouble is, here in 3D, if I do that and click to make the selection, I get a selection of 4 walls. But what it did was it went around the corner and did 2 exterior walls. Then it went down to the foundation and came back again. Now, I'm not really sure why it did that. It's a little strange to me, but there's going to be a really easy solution to prevent it from doing that. I'm simply going to hide the foundation walls temporarily. So go ahead and select one of your foundation walls. And if you wish, also select one of the footings, right click, choose select all instances visible in the view. With those items selected, come down here to the little sunglasses icon and choose hide element. So that will temporarily hide all of that geometry in this view. And now if I highlight the exterior wall and press tab, you can see that I get a very different result. Now I'm going to click, and that selects all the walls on the perimeter of the building. Now that's close to what I want, but you can see that it missed this wall here on the second floor, and it included these 3 on this little east wing over here. I don't want those 3 selected, and I do want the other one that it missed. So how can we deal with that? Well, I'm going to actually click an empty white space, and we're going to try again with the chain selection, and I want to show you a cool feature of chain selection, but it does take a little practice. Okay, highlight the exterior wall. Press tab. Don't click yet. We're getting the same chain. Move your mouse very slightly to the inside face of the wall, and it should highlight the inner chain instead. So you can see it there highlighted. I'm going to go back to the outside face. There's the outer chain. Here's the, I lost it. There's the inner chain right there. Okay? So it is a little tricky. It does take some practice, but don't give up on it because this is a really powerful way to select elements. So I think it's worth your effort to practice it until you get comfortable with it. That's the chain I want. I'm going to click, and now it selects all of the walls that we need. I don't need to make any additional modifications. So once I've got those walls selected, I always like to check the properties palette just to do a gut check on the quantity. So notice over there it says walls 7. So I don't know that that's exactly the correct quantity, but it seems plausible. 7 seems like the correct number to me. So I feel confident to go forward. So that's all I'm asking you to do is just do a gut check. Does that seem like a reasonable number? And it does. So now I'm going to go to attach top and base, highlight the edge of the roof, click. And if I shift and drag the wheel to orbit, you can see that it's now attached all of those walls to the underside of the roof instead of doing them one at a time. So that's obviously a much nicer way to do that. So I'm going to deselect those, and I want to show you that in a different view, this section at lobby. I'm going to double click to open that up, and let me just zoom in a little here at the top. And I'm going to take this section and use this little grip here and just kind of stretch it up a little taller so we can see the entire roof. Okay, so notice that the walls that are attached to that roof have not only followed the shape in plan, but they're also cutting along the angle here of the slope of the roof. Okay, so that's a really nice feature of this attach tool. Now, if I select this wall and look at its properties, here's just a little anomaly that I want to point out to you. It still says it's going up to the high roof. Okay, high roof is right here. Okay, this line right here. Suppose I were to take this roof and use the base offset from level parameter and increase that. Let me go 2 feet in imperial, 600 millimeters in metric. Notice what happens to those exterior walls. It went and stayed attached to the roof. And if you select it, it still says it's only going up to the high roof. So it's pretty important that you understand that. Like what you see on the properties palette may not exactly match what's really going on. Now, if I want to remove this, I could do detach, select the roof again, and the wall drops back down. And in that case, it would go back down to the high roof where it says it was. But it's not necessarily an issue, but it's just something for you to be aware of, okay? That when you use the attach functionality, it's kind of overriding what otherwise is listed for the top constraint and height there, okay? Now I'm going to undo once and twice to get that roof back where it was. Okay, the last thing I want to show you here is architectural columns and actually structural columns as well, but columns in general can also use this attach functionality. So what I'm going to do here is right here in this section, I'm going to make a little crossing selection across the top there because I only want the columns on the second floor. I'm going to go to filter, check none, and it's columns you want, not structural. We'll choose columns here, check the box, click OK, but notice that it only found 3. Now I'm going to open up the level 2 floor plan to show you why, okay? We are standing here in that section looking up toward the plan. And so it only can select things you can actually see. And it missed all of these other columns here in the second floor plan. So what I'm going to do is hold down my control key, start maybe right about here, and make a window selection around the remainder of the second floor. Go back to filter, check none again, columns only, click OK. And now I have 10 columns. So that's a much more valid quantity. So you can see why checking that quantity is a good thing to get in the habit of doing. Because when I saw only 3, I said, that doesn't seem right. I know I have more columns on the second floor, and it forced me to go investigate. So this is what I was talking about when I said, do a gut check. And if it seems reasonable, continue. But if it doesn't, then investigate. So now that I have the correct selection, I'm going to complete the modification here in 3D. And to do this, I'm going to actually isolate this view even further. So I'm going to hold the control key down and add the roof here, and then come down to the sunglasses and choose isolate element. So I've got 11 elements selected, 10 columns, 1 roof, Now, those are the only things that are visible here in this 3D view. So I'm going to spin this slightly, zoom in. I'm going to hold the Shift key down and deselect the roof. The 10 columns are still selected. I'll do attach top and base, and I will pick the roof. And you're going to see them shoot up to the height of the roof, but notice that it's not terribly satisfying the way that it did it. So the top edges of those columns are just kind of flat there. Okay. Well, there's actually a setting that controls the way that they attach that you can do at the time of attachment, or you can fix them after the fact, which is what I'm going to do right now. So I'm going to scroll down here, and you're looking for the attachment justification at top. And there are 3 choices. Minimum is what we have. That's not so nice. Intersect at midline, I don't think is going to work either. Let's do maximum intersection, and that's going to be a lot nicer. Okay, so now I've attached those columns along the slope of the roof. That looks really good. I'll go to the sunglasses. I'll reset the temporary hide, and that completes all of the attachments that I wanted to make here in this model. So feel free to experiment further if you wish, and that is your attach top and base functionality. There are lots of different forms of roof that we can create in Revit, and the ones that we've built so far, we're just using the simple roof by footprint tool. But if you look at the drop-down menu on the roof tool, you can see that there are some other choices. So in this video, I'd like to do the roof by extrusion. Now, this is going to be a really simple sketch, which is going to define the profile shape of the roof, and then we're just going to give it a depth. Okay, and I'm actually going to do something very similar to what you see in that illustration right there. Now, I want to build this as a canopy out in front of this little exterior doorway right here. So I think the easiest way to draw that is going to be to work in an elevation that looks right at that wall. So I'm going to go to the east elevation here, east architectural, and I'm going to zoom in nice and close on this brick wall here. So now I'm going to go to the drop down, choose roof by extrusion, and that will prompt me to select a work plane. Now, a work plane is quite simply the plane on which you are drawing the sketch. Now, everything else that we've sketched so far, we've been working in a floor plan, so the work plane was obvious. But when you're working in an elevation, Revit needs you to kind of let it know what work plane you want to use for the sketch. There is a drop down here. We could sketch on any of the grid lines or reference planes. But in this case, I think pick a plane, which is already chosen, is the right option, because when I click OK, I can simply select the brick wall and use the surface of that brick wall as my work plane. So that's what I'm going to do, and click it. Now, even though we've set a work plane, the roof still needs to be associated to a level. All elements in Revit need to have a level association. So it almost doesn't matter what you choose here, but to me, it seems logical to choose the level that's closest to where I'm going to draw the roof, which is level 2 in this case. All right, and I will click OK. So that puts us in sketch mode. Okay, now I want to draw this as a curved form. So I'm going to choose the start and radius arc right here and use that as my sketch shape. And I want to start at about maybe 2.5 bricks away from the top corner of the door, and then about 5 bricks above that. And that's going to be the first point of my sketch. Then I'm going to move kind of diagonally up about 3 bricks and roughly at the middle of the doorway, and click again at the nearest brick intersection right there. And then you're drawing the amount of curvature. Now, you can make this as curved as you want. You don't have to do exactly what I'm doing, but I'm going to kind of make it so that it starts off flat and goes at a curve. And that grid intersection right there should probably give me what I'm looking for. Perhaps the one next to it, maybe that one there is a little bit nicer. And then I'm just simply going to click. Okay. Now I'm going to go horizontally this way to about 2.5 bricks to the right side of the door. Click again to make that an endpoint. And then finally, it should snap to a tangent of the existing curve if you just kind of move the mouse nearby there. And when I see that it says tangent, I will click to set the shape of the curve. So that's the shape that I'm looking for. I'm just going to click the modify tool to cancel out. And unlike a roof by footprint or a floor, you do not want an enclosed sketch here. The reason is the thickness of the roof is going to come from the type that you've designated. I've got generic 9-inch chosen, or if you're in metric, it'll be generic 250. So let's click finish, and you're going to see that thickness get applied, and there's our extruded roof. Now, the trouble with it is if you come over here to the 3D view, it's going to look a little odd because that extruded roof went inside the building instead of outside. Well, Revit assumes that we're trying to roof the building. So it took its best guess and said, well, here's the depth of the building. I'm just going to go back that far. It didn't know that we wanted to make a canopy in front of the door. So we can easily adjust the depths of this extrusion in a couple different ways. You can use these little grip controls and just sort of stretch it. So I can pull it away from the building there. And then I'm going to take the backside and pull that out in front of the building as well. And if I hold the shift key down in orbit, my canopy is now floating out away from the building. Let's zoom in a little bit closer there. Okay. But you can also adjust it here on the properties palette. So the smaller number is the extrusion end here. And what I want to actually do with that is zero it out. So when we do 0 and apply, you're going to see that roof is now flush to the brick wall. So it's attached right at that location. And then as far as the extrusion start, just set it to a rational size. So in this case, I'm going to say, let's make it 5 feet for the canopy in imperial, or if you're working in metric, that's going to be 1,500 millimeters. And that should do it. That is our little free-form canopy created from an extrusion roof. Now, if you want to try your hand at some additional shapes, feel free to experiment further.
In this video, we're going to focus on this flat roof right here, and we're going to add some subtle slope to it for drainage because, of course, when you have a flat roof, it's never completely flat. There's always some degree of slope to it, which is usually determined by a building code. Now, the first thing you want to know about the technique I'm going to show you is that the tools that we need to access are only available if you start with a completely flat slab. So let me demonstrate that. If we select this sloped roof right here, you will notice that on the ribbon, we have a single button called Edit Footprint. However, if we select this flat roof right here, you will notice that next to Edit Footprint, we have a number of additional tools in the shape editing grouping. So those are the tools that we're going to be looking at here in this video. So the easiest way I can explain what the shape editing tools do for us is to just do a quick demonstration. So I'm going to use this Add Point tool right here. And I'm just going to click a couple random points on the surface of that roof. Then next to that, there's this Modify Sub-Element tool. I'll click that next, and I'm going to click the first point that I placed, and then you'll notice a temporary dimension appears next to it, and I will click that. And what I want to do is just simply add a little bit to this number. So whatever the number is, just add a little bit. I'm just going to add a foot here in imperial. You can add maybe 300 millimeters in metric. And you'll see an adjustment and maybe an error. We're just going to ignore that. And then I'm going to click this one and do the same thing, but this time I'm just going to subtract a small value. And again, the values are not important. I just want to illustrate how the tool works. And what you'll see is we get this triangulation along the surface of the roof. And it's probably best to understand in a different view, like a section view. I'm going to deselect the roof there, come over here to this section at East Wing, double click and open that up, and then zoom in, and you can now see what the result of those modifications were. So my roof is kind of bent and kinked and shaped in these sort of weird ways there. All right, so that's essentially what is possible with the shape editing tools. Now, I did that all randomly, and I want to be maybe a little bit more systematic about it now. So let's take this roof, and we're going to click the Reset Shape here, and it will kind of reset us back to a nice flat slab. And now we're going to do something a little more practical. So with that roof still selected, I'm going to come over here to the type selector, and in the imperial file, it's currently a generic 9-inch roof. In the metric, it's generic 225. Let's change it to insulation on metal deck EPDM in both files. Now, here in my imperial file, this view is set to medium level of detail. If yours is not set to medium detail, please do that now. If it's set to coarse, you won't see any of the structure inside the roof. But if it's set to medium or fine, then you will. And you'll notice that it now has multiple layers of construction, just like our wall assemblies do. So roofs and wall assemblies use the same basic concept of being able to have layers of materials all sandwiched together. So that's the first step that I wanted to do. Now, the next thing I want to do is start laying out my roof in a little bit more systematic way. And I think it'll be easier to do that in the roof plan. So I'm going to go to the low roof floor plan right here, zoom in on the east wing. And what you'll notice is that I've added some reference planes here, here, and here. And I've got another one here down the middle. And then I used some dimensions that are just set to equality to make sure that those reference planes were marking off equal spaces. So we're just going to use those reference planes as guidelines to help us sculpt the roof. Now, there's one more dimension over here, which is 25 foot 4 inches in the imperial file and 7,600 millimeters in the metric file. So that's our total distance that we want to slope. So we want to pitch the roof down along that distance. So what we need to do is calculate how far we want this slope to be. Now, as I mentioned earlier, there's usually a building code that determines this. Most of the building codes that I'm familiar with have a minimum slope of 1/4 inch for every 12 inches of run. That would translate to about 6¼ millimeters for every 300 millimeters of run. And that's the value that I'm going to be using for my calculations. But if your jurisdiction calls for a different slope, then feel free to use different numbers. Now, if you want to learn a little bit more about calculating slopes in an architectural setting, I found this nice article here that you can look at. It talks about 3 different ways of calculating slope for architectural purposes. So I thought it was a good read. It's a pretty quick read. So go ahead and check that out if you're interested. Back to our roof here, I need to first select it. So the way I'm going to do that is to tab in. So I'm going to highlight one of the walls, press tab. That's going to do chain. Tab again is a different chain. One more time, that should give me the roof. And then I can click to select it. Another way to select it would be to go to the section view, select it there, then switch back over to the low roof. It's up to you. Okay. So once I've got that roof selected, we're now going to direct our attention to the shape editing tools that we looked at earlier. The first thing I want to do is go to the Modify Sub-Elements tool, and that will put us in an edit mode. It will put a green dashed line all the way around the outline of the roof, and you'll notice that there's also these little green dots at the corners. Now you could select any of these components, the dashed lines, the green dots, and then you could manipulate them with the values. So what I'm going to do is select this horizontal line down at the bottom, and I want to edit this value. However, notice that value for me is currently saying 13'3" and some change, right? I'd have to do the math in order to get the right value starting with that number. But it turns out that if you look up here at the ribbon on the Modify Sub-Elements panel, you've got an elevation base parameter. And what we can do is use this drop down and choose a different base point for the elevation calculation. So you can see there's 5 different choices there. Now, I'm not going to go through all of them, but I think the one that'll be most convenient for us is to use the top plane. Top plane will zero out the value because now everything's going to be measured from the top surface of the roof. So all we have to think about is how high do we want to raise above the lowest point on the roof? And I think that's much more convenient. So I'm going to click on this value and put in the value I want. Now, in my imperial file, again, I'm 25 foot plus. I'm going to round it up to 26 feet so that the calculation's a little bit easier. And if I divide my 26 feet by a 1/4 inch rise, I get about 6½ inches of rise that I need here. So that's what I'm going to put in is 6.5 inches. If you're working in the metric file, I did the same calculation and it came up with about 160 millimeters. I just rounded it up to the nearest 10. Okay, so try about 160 and you should get to the same place. So now the result of that is if I go to the section view again, you will see that we've got this really subtle slope now on the entire roof. It's kind of like a really subtle shed roof. Okay, so we could stop there, but what I want to do further is direct any drainage to 2 drain points. We're going to have, maybe we'll have scuppers on the side of the building. Okay, and those drain points are going to be here and here. So We could use that same add point tool that we did last time, but this time I'm going to use a different tool, add split line. I actually like this one a little bit better. Okay. Now I do want to make sure that I'm drawing along the surface, and I do want to make sure that the top plane is set, because again, it'll just be more convenient to work that way, but not in every scenario. In some cases, you might want to choose one of the other elevation base points. And I'm going to start right here at this midpoint on the left-hand side. And then I'm going to go diagonally over to that intersection. Now you say I'm having a little tough time finding the intersection. You can type the keyboard shortcut SI, and that should make it easier for you to snap right to the intersection of the reference plane and the green dashed line. Then I want to start again right at that same spot and go back to this intersection here. Start again right at that same spot and go back to this one. And again, I'll use SI to help me. And then finally from here to the midpoint. Then I need one more line from this location to the midpoint here. And then I will switch to the modify sub-elements tool. So we've got these split lines now, and notice that these points here are already half the distance of what we set here because of this reference plane being right in the middle. So all we need to do is select the points that we want to raise up to create these cricket forms. And it's going to be this point at the corner, hold the control key, this one, and this one. Now, because I have multiple points selected, I won't see a dimension on screen, but I can edit the elevation right here. And all I want to do is move this back to the original height, which in the imperial file was 6.5 inches, and in the metric file was 160 millimeters. So just simply type that in. And then if you switch back to your section, you can see the result there. Now, if you look carefully, you can see that we've still got this blue line here. So the slope is continuing down to those drain points off in the distance, kind of through the thickness of the roof there. We could stop here. This would be a valid roof. Sometimes folks do taper the actual structure of the roof. But if instead you want a flat underside of the roof and you just simply want to build up the roof with tapered rigid insulation, then there's one additional step. Come over here to the Edit Type button for the roof type that we're using. Here in the Edit Type dialog, you can duplicate it, and then I'm going to add a description, tapered insulation, to the name. And then I'll go to the Edit button here, and this should look familiar. This is similar to the wall type dialog that we looked at in an earlier video. And all we need to do is take our tapered rigid insulation layer right here and set it to variable. When you do that and you OK again, you'll see that the bottom of the roof flattens out, and now all of the variation occurs just within the insulation layer. I'll click the Modify tool to deselect everything, switch back to 3D, and zoom in, and you can see the final result here. One last thing you can do to check things out is you can go to the section, zoom in a little bit, and on the Annotate tab here, there's a Spot Slope tool, and you can use this to just sort of check that your slope is in fact correct based on your calculation. So it's always a good idea to check that if you can, and that completes our flat roof with drainage sloping.
In this video, we're going to look at an alternative way to apply slope to elements like roofs and floors called slope arrows. So we've already looked at slope defining edges and shape editing tools, and both of those are perfectly effective ways to slope a roof. But in this video, we're going to see that there is an alternative called slope arrows, which has some unique properties. Now, let me first demonstrate what the differences are. So I'm going to select this roof over here and go to Edit Footprint, select one of its edges, and turn on Define Slope, which is a method we've already looked at in an earlier video. When I click Finish, I get this shed form here, and it's sloping in a single direction. But the important thing that I want you to notice about it is the slope runs perpendicular to the edge that we turned on Define Slope. In other words, if you visualize that edge as a hinge, like a door hinge, then it's sloping up and away from the building along that defined edge. Now, the slope must follow perpendicular to the existing edge. But what if your building design called for the slope to run in a different direction? Then what would you do? Well, if I go back to Edit Footprint, select this edge, turn off the define slope, the alternative I want to consider is using a slope arrow. So with the slope arrow, you have a sketch-based solution. And what you do is you just sort of click somewhere and then you draw this arrow in any direction you like. See how I can draw it in any angle. So I'm just going to kind of go off at this angle like so to create this slope arrow. Now, if I try to finish this, it is going to generate a warning because there's another rule that you want to be aware of when it comes to slope arrows. The tails, the start point of the slope arrow, must lie on the roof boundary. Okay, so that's a rule. So I'm going to cancel this, select this slope arrow, go to the move command. Here's the tail right here. It's that start point. And then I'll just move that somewhere on the roof boundary. So it doesn't matter where on the roof boundary it is, just somewhere on the boundary is fine. And now when I click finish, you're going to see that it will allow me to apply that slope arrow. And look at how interesting that slope is now. So we sort of did that one completely random, right? So why don't we do it maybe a little bit more carefully on this one over here? So I'm going to select that roof, go to edit footprint, go to slope arrow. And this time what I'm going to do is start at this endpoint here, and I'm going to go across to the opposite endpoint right there. When I click finish, you will see that it's now sloping along the diagonal of the building with a low point down here and a high point up here, and it kind of slopes in that direction. I'm just accepting the defaults, but if we go to edit footprint, you can select the slope arrow and you can change how much slope is applied to that arrow. You can do that in one of two ways. You can specify the height at tail, or you can use the slope. Slope is just rise over run or degrees. So just like we were doing when we did slope defining edges, right? So you could just put in the value that you want there. Or if you do height at tail, what this allows you to do is specify two heights: the height at the start point of the slope arrow, the tail, and the height at the other end of the arrow where the arrowhead is here. So let me just double that. Okay, so it was currently going to 10 feet here in the imperial file, or 3,000 millimeters in the metric file. Let me just go ahead and double that value and click finish. And now you can see that this slope is much steeper. Okay, you have complete control over how much slope is applied. You just do that to the slope arrow itself. Now I'm going to edit it one more time. And I'm going to take this slope arrow here and I'm just going to delete that, and I'm going to draw it over again. And I'm going to start right at this point, but I want to stop in the middle of the square this time. So I'm going to right click and go to the snap overrides and choose snap between two midpoints. Keyboard shortcut for that is S2. And I'm going to go from this corner to the opposite corner here. And notice that that finds the midpoint right in the middle of the square. So I've drawn that slope arrow now half as long as what I had previously. Now I'm going to draw a second one from this point and snap right to here. So you can actually create as many slope arrows as you like in this sketch to create a more complex form. So when I click finish, now what I end up with is a ridge across the middle, and it slopes down to two low points on those opposite corners. If you wanted to do that one more time, you could honestly create slope arrows going in from all four corners and create something like this. So there's a lot of really interesting forms that are possible once you start building an intuition for how the slope arrow tool works. And that's really what it takes. It takes a little bit of practice to build up that intuition. Now, I want to leave you with these two objects over here. This is a floor element. This is a topo solid. I'm going to select the floor element, edit its boundary, and notice that it also supports slope arrows. Now, actually, it supports slope defining edges as well, but it also supports slope arrows. So I'm going to put a slope arrow in here, draw it out at some angle, click finish. Go ahead and select this, maybe set the height to 3 feet or 900 millimeters, and I'll click finish here. And now you can see that I'm sloping that floor slab. However, one thing that's important to understand about floors with respect to slope arrows is you can only have one. So notice that it's now grayed out. We couldn't add a second one like I did over here. So that's the only limitation when it comes to floors. And I put this one here for you to experiment with on your own. Topo solids also support slope arrows. So feel free to experiment further in this file, trying to build up that intuition on how these slope arrows work. But if you want to see a more advanced example, then I welcome you to go to my weekly series, Revit Tips, Tricks, and Troubleshooting. And one of the very first videos in the series from several years back was using slope arrows to create this complex roof form. And so if you're interested in this topic and you want to learn more, then I think this video will provide a really good resource. In this video, we're going to add ceiling elements to our model. So to get started, I'm going to go to the Architecture tab and locate the ceiling button right here. So I'm going to click that. And the first thing we want to check is what kind of ceiling you are creating. So if you're working in the Imperial file, choose the 2x4 acoustical ceiling tile system. If you're working in the metric file, that's going to be 600 by 1200 millimeters. Now, there's two ways to create a ceiling. There's automatic ceiling and sketch ceiling. Now, automatic is already chosen, so why don't we start with that for this first example. Now, if I move my mouse into the floor plan, the way the automatic ceiling works is you need to put your mouse inside an enclosed space, and then it will sense the boundaries of that enclosed space. So let's try that right here. Trouble is, you can see that it's sensing the boundary of the entire floor plan. Okay, so the other thing that you want to consider when using the automatic ceiling is the height at which you are about to place the ceiling element. The template file that we use to start this project established the default height of the ceiling, and it was at 9 feet in the Imperial file and 2,700 millimeters in the metric file. That's a little bit too tall for this building. So we need to drop our ceiling down to 8 feet or 2,400 millimeters. So what I want to do is come over here and use the height offset from level on the properties palette. I'm going to put in 8 feet. If you're working in metric, do 2,400 millimeters. And now notice the difference. Now it will properly sense the individual enclosed spaces. Okay. So now that we've done that, I'm going to go ahead and click in this upper left-hand corner here, and that generates a warning. And it says none of the created elements are visible in the floor plan. Now, I wanted to do it this way because it's a common mistake. Okay, so what happened was we are working in a floor plan view here. I'm going to click the modify tool to cancel out and then just click anywhere to dismiss that warning. We're working in a floor plan which is cut at about waist height and looking down. The ceiling we just created is at 8 feet. We just set that number. And that's up above our head. So it's well outside of the view range of this floor plan. So where we should have been before starting was in a reflected ceiling plan instead. So I kind of wanted to go through that exercise because, again, it's a very common mistake and it can be frustrating because you're sitting there scratching your head wondering why the ceilings aren't appearing. And it's as simple as not being in the correct view. So here are the ceiling plans on the project browser. I'm going to double click the L1 architectural ceiling plan, and there's our ceiling right there. So it did in fact create the object. It just wasn't visible in the view that we started in. Okay, so now that we've gotten past that issue, let's go back to the ceiling tool and continue. So I'm going to create ceilings like this one in each of the offices. So here, 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 and here, and then these two over on the right-hand side of the plan. So now we had some other ceiling types here on the type selector. So I'm going to switch to a 2x2 acoustical ceiling tile for the next example right there. And that would be 600 by 600 if you're working in the metric file. And I'm going to place one of those here in this break room. Now, when I move over here to the toilet room, I get a similar problem that we've already seen, because now instead of just highlighting one toilet room, it is doing both of them. So the issue here is similar to what we encountered before, but not exactly the same. So notice that the height offset from level is still 8 feet or 2,400 millimeters. So that's not the issue this time. The issue this time is this wall that separates the two restrooms. So I'm going to click the modify tool to cancel out of here. And I'm going to select this wall and notice that its height is only 8 feet. So that means that that wall just goes up to the height where we're trying to place the ceiling, and that allows the ceiling to pass right above it. Now, in the case where you want an underpin ceiling, that may be exactly what you want. But in this case, that's probably not what we want at the restrooms. So I'm going to raise the height of the wall. You could do that by typing in a new number here, or better, is you can connect it to level 2. So I'm going to take the top constraint here and go up to L2, and then I will return to the ceiling command, and now we're able to create separate ceilings on either side of that wall. Now, the next thing I want to show you is another common problem that sometimes occurs. I'm going to switch to this ceiling type called GWB on metal stud. Okay, so there's one of these in each of the imperial and in the metric file. So this is a drywall ceiling. And then I'm going to come down here to this conference room and click. Now, I clicked, but it doesn't look like anything happened. So sometimes folks are a little dismayed by that, so they click again. And now everything turns orange, and I get this, there are identical instances in the same place message. So what's the problem? Well, the first time I clicked, it created the ceiling. We just couldn't see it because unlike the 2x2 or the 2x4 ceilings, it didn't have a grid pattern associated with it. So what I'm going to do is click the modify tool to cancel. I'm going to select this section cut right here, which cuts through all the offices, right click it and choose go to view and zoom in on that location. Right here, I currently have 2 ceiling elements, and I can show you that by doing a crossing selection right here, and notice that it says ceilings 2. So when I clicked the second time, the reason it generated the warning was for that reason. So I'm going to select one of these and delete it. Okay, so just be aware of that. I'm trying to show you all of the little gotchas that usually come into play when folks are placing ceilings here. So I'm going to go ahead and close this section view. Now, the last ceiling that I want to create in this floor plan is here underneath this balcony. So we've got this balcony on level 2, and I'd like to put a ceiling underneath that. Trouble is, if I go to the ceiling tool, it's going to highlight that entire space. Now, this time it has nothing to do with the height of the walls or the height of the ceiling or anything like that. The fact is, there just simply aren't any boundary lines in this location to bound the ceiling. So if you don't have any walls there, then you're going to need to do something else. And that's where sketch ceiling comes into play. So we're just simply going to switch to sketch ceiling, and then you can use any of the normal sketch tools to create the shape of this ceiling. So I'm going to start with pick walls because we do have walls here, and here, and here. Now, this wall flipped to the wrong side, so I'm going to want to address that. So let's click the Modify tool, select that one, and click Flip, just to flip it to the inside. Now, this edge here is not walls, so I can't use pick walls for that. But there is another option here called Pick Lines, and this allows me to touch the edges of that floor, and you might want to zoom in to be able to get these edges. And then right here, you're going to need the face of this column. Now, while I'm zoomed in at that location, I'm going to do trim and extend and clean that up, trim and extend and clean that up. So just make sure you're picking the correct sides. Then I'll trim here and here, here and here. And you need to do this all the way around. And then just double check any of the other intersections. That all looks pretty good. Okay, so now I'm going to switch this to the 2x2 or the 600 by 600 just so we can see the hatch pattern when it's done. And I'll click finish. And now you can see we've created a ceiling in that location. So whether you're using the pick ceiling, the auto create ceiling, or the sketch ceiling, you should be able to create all of the ceiling elements that are required. In this video, we're going to manipulate some of our ceilings, and specifically, we're going to adjust the patterns that are applied to them. So let me zoom in over here on the right-hand side of the plan and show you a couple quick examples. So if you move your mouse around inside the space, notice that you're able to actually highlight the individual ceiling grid lines. So you can click and select any one of these lines that you like. Now, notice that the grid pattern in this particular office is running vertically. Maybe I want it to run horizontally instead. So it's as simple as taking one of these grid lines, selecting it, and then going over here to the rotate tool or type RO. Now, when you do that, it usually places the center of rotation at some strange location, so it's always a little off center there. you can click this little dot and then pick it up and move it somewhere else. So I'm going to place it right at the midpoint there. And the result of doing that is going to keep everything centered. So if you let it rotate around that off-center dot, then it won't be centered anymore. Now, you could rotate right on screen using your mouse, but you can also click right up here on the options bar and type in an angle. And I'm just going to type in 90 degrees and press enter. And notice that that has the effect of rotating the entire grid pattern 90 degrees. So what's important to understand about shifting grid patterns is you simply select any line that's convenient, and whatever change you make to that line will affect the entire pattern. So that's true of not just rotating, that's also true of moving. So I'm going to move to the room next door and select one of its patterns. And I'm going to start off just by nudging. Nudging is using the arrows on your keyboard. So you can use the left, right, up, down. So if I do a few arrows to the right or to the left or even up and down, you could see I can shift that pattern around in any direction. If you hold the shift key down and then arrow, it does a bigger nudge. It's 10 times the original. So those are all random though, because nudging is just sort of by eye. So if you want something a little bit more precise, you can use the move tool. So here I could select a certain start point, and then I could snap to another specific location. Or I could pick a certain start point, start moving in the direction I want to go, and type in a value. So there's a couple different ways you can use these tools to help you position the ceiling. Finally, you can also use the align tool. So here, if I wanted to start the grid at this wall, I could start with the wall as my alignment edge and then pick the grid, and it would shift everything over accordingly. So those are a few techniques that you can use to manipulate the grids. But really, the next question ought to be, how do I know if I need to do that in the first place? Well, let's shift our attention over to these offices on the other side of the plan, and let's talk about that. I think the best way to decide whether or not you need to shift the grids at all in the first place is to add some ceiling fixtures. So you're probably going to have lights or mechanical outlets or other kinds of items up in the ceiling. So place those items first and see where they land. And then if you need to shift things, then you can shift both the ceiling grid and the ceiling mounted fixtures together. So let's go to the architecture tab, and we already know how to place ceiling mounted equipment because it's the same component tool that we've used in previous videos. So the keyboard shortcut is CM. And if you open up the properties palette, the type selector, you can scroll through the list looking for light fixtures, but remember that there's a search at the top, and it might be easier to just search for a keyword. So I'm going to search for the keyword light, and you can see that in this file, I have some light fixtures already installed here. So I'm going to scroll down to the bottommost one, this troffer light, 2x4 parabolic. It's 600 by 1200 in the metric file. And then I'm just going to choose one of its types. And it doesn't really matter which one you choose. I'll choose this 4-lamp one here. Now, this is what we call a face-based family. So it's saying select a host face to place this instance. Now, face-based families default to place on vertical face. So you want to pay attention to that because for light fixtures, you're probably going to want to switch it to place on face. And that means we're placing it on the horizontal face that we can see, okay? Now, it will try to snap to the grid, and you can usually get good results with that. But a lot of times I'll just place it randomly because I find it easier to place one, come in, go to the align tool, and align it in both directions. And then once I've done that, I can select it, go to copy, and I can copy it to different locations. And so now I have a group of 4 lights. I'm going to select all 4 of those, zoom out, and then I can copy those into the other offices. And of course, when I do this, you can see that everything is off center. And in fact, the lights on the right are actually poking out of the rooms. So clearly we need to adjust those ceiling grids. So let's zoom back in now at the one up at the top. And something you need to be aware of with face-based families is if you move the grid, and I'll just do that with shift nudge, the light fixtures won't go along with it. They'll kind of stay behind. So let me undo that. And the solution is quite simple. Just select both the grid and the light fixtures. So I'm going to select all 4 lights and one of the grid lines. And now I'm going to go to the Move tool, pick any start point, start moving in the direction I want to go. And it looks to me like if I move half a tile, I should be in pretty good shape. So I'm working in imperial, so that's going to be 2 feet. If you're working in metric, it's going to be 600 millimeters, and I'll press enter, and that looks pretty good. Those lights are centered in that direction. Let's keep it all selected and do the same thing in the opposite direction, but this time it's just 1 foot imperial or 300 millimeters in metric. And now I've managed to keep everything centered, but it now matches the space a lot better. So you can repeat that in each of these other offices, and when you're done, it should look something like this. Revit has a number of opening elements. They all share one basic characteristic in common. Opening elements are a void element that cuts away from solids. So it's similar to the way doors and windows behave. When you place a door or a window in a wall, it cuts a hole in that wall. So with the opening elements, you're just creating the hole that you want to cut through the object, but you're not filling it with any geometry in that process. So I'm going to demonstrate 2 of the opening elements in this video, and the other 3 that are available will behave in a similar way, and you can explore those on your own. You're going to find all of the opening elements on the architecture ribbon right here. So the first one I'm going to demonstrate is the dormer opening, and I've actually created 2 conditions here in this file. One is complete already, and the other one we're going to do together. So if I take these walls here and select them, and this roof right here, and go to the sunglasses pop up and do hide element, you're going to see that dormer opening penetrating through the roof below. That's what we're going to create over here on the opposite side. So let me reset the temporary hide, and let's kind of focus in on this dormer right here. To get started, we need to finish the geometry of the dormer itself that I started building here. So you can see I've got 3 walls that are actually penetrating through the roof right now. But over here, notice that the wall has this triangle shape. So what I did was I actually used the attach top and base tool that we've talked about in an earlier video, but I used the base functionality of that. So let me demonstrate. I'm going to select this wall, hold down the control key, pick this one, and this one right here. So all 3 of those walls that make up the dormer geometry, and attach top and base. This is the same command we use to attach walls to the underside of the roof. The difference is when we were doing that, we used the top option. But notice that right next to that is a base option. So if you switch this to base and then pick the roof, and remember to pick the edge of the roof, it will cut the bottom edges of the walls to match the roof instead of the top edges. Okay, so that's the first thing. The next thing that we want to do is take this little roof that I have here and extend it back to connect with the other roof. And we've got a specialized tool specifically for that purpose right here called Join and Unjoin Roof. So we're going to click that. And the first prompt is going to ask us to select a roof edge. Okay, so that means an edge back here of the roof that we want to attach. And then once we've done that, it will prompt you to select a surface. So we're going to pick the edge of the surface of the main roof, and it will extend it back to connect that geometry to the other roof. So now that we've built our little dormer, we can now create the opening. So we're going to go back to architecture, and we're going to click the dormer opening tool. It will prompt us to select the roof that we're going to cut with this opening. So that's again going to be this main roof. And then it defaults to pick roof or wall edges. So we want to pick the little small roof, and that creates this small triangle sketch here. We're going to pick each of these walls along the 3 sides of the dormer. Now, it'll be a little easier to visualize this next step if we go to the roof plan temporarily, and let's zoom in. And what I want to make sure here is that my dormer opening is on the inside of the walls. So it looks to me as though they are, but one easy way to tell is to just click these little flip grips. And actually they weren't. It was on the outside. So I'm glad I tried that, right? So you can see here that you can click these little flip grips and flip them to the inside, okay? Then we're going to go to trim and extend and clean all this up. And then when you're done, you click finish. And I've created a little section cut here for us to see the result. And you can see that one of the unique features of a dormer opening is that the opening is flat at the top and it's vertical down near the bottom. So the opening automatically creates the correct shape based on the dormer geometry. So that is our first opening tool that I wanted to share with you here. The other one is also very useful, but very simple. And I'm going to show you that on the first floor plan and this section right here. So here's an elevator going up the 3 floors of this building. If I open up this section cut, you can see that unfortunately our elevator is being interrupted by these floor slabs along the way. Now, one solution would be to select the floor slab, edit the boundary, edit the sketch, and create a little hole for the elevator. But the trouble is I'd need to do that 3 times for each of the floor slabs that are in the way. Alternatively, we can create a shaft opening. So a shaft opening is just an object that's an opening object that you can create multiple stories tall, and it will cut through everything in its path: floors, ceilings, roofs, etc. So let's go back to the first floor plan here and create the shaft opening. So we're going to click the button, and then that puts us in sketch mode. And for this example, I'm just going to draw a simple rectangle, and I'm going to start on the outside of these walls here on the left and go to the inside face of the wall on the right. And that's the shape that I want for my shaft right there. I will click finish. It's still selected. So the way that void elements work is when they're selected, you can see them, but when you click away from them, they deselect and it's as if they're not there. Okay, so they automatically take care of their own visibility. Now, notice here in section that it is cutting through this floor slab here. Well, if you move your mouse kind of nearby where that shaft is and click, all we need to do here is adjust the height. So it's actually cutting through the bottommost slab and the second floor slab. It's not getting through the third floor slab. So you could just drag this little grip up a little bit, or another way to do that would be to set the top constraint, and I like to set that to a level like maybe the roof, and now you can see the shaft is cutting through all floors and allowing the elevator to pass through. So those are 2 of our opening elements, 2 of the more complex ones and the more interesting ones. I welcome you to explore the other 3 on your own: wall, vertical, and biface. In this video, we're going to look at adding stairs. So let's get started right away here by zooming in near the front of the building, and I'm going to go directly to the stair tool. Now, I'm not going to change any of the settings. We're going to accept all of the defaults. I'm going to simply click a point on screen here to start the stair, and then simply move the mouse a little bit away from that first point, and you'll start to see the stair get created. Now, you can draw the stair in any angle that you like, so just sort of move in the direction you want to go, and notice that little gray message down beneath the stair that says a number of risers created and a number remaining. So what I want you to do is move the mouse all the way so that it says 18 risers are created and 0 are remaining. And when it does, go ahead and click to create our first stair. That's all we need to do. We're going to click the finish edit mode, and that will not only create the stair, but let's zoom in just a touch here. You can see it also creates a railing on either side. Okay, so with 2 clicks, we've created a stair. Now let's take a look at that in 3D. So I'm going to come over here to the quick access toolbar and click the little birdhouse icon to open up the default 3D view. And let me zoom in there to get a better look at that stair. Okay, so not too bad for 2 clicks of the mouse. Let's tile these 2 windows now side by side so that we can continue to work in the plan view, but see our progress in 3D as we go. So I'm going to go to the View tab here and click Tile Views. And then just make sure that you can see a little bit of space here on both views. So I'm just going to adjust my screen a little bit, and I'm going to create a second stair in this location. So we just created a straight run stair by using all of the risers in a single run. But if we go back to the stair tool, make sure you're in the plan view when you do this, click on the stair button. And this time I want you to click your start point and then move just a few risers and click again. So notice the difference both in 2D and in 3D. So here in the plan view, we can see how many risers we've created. I've created 5 in my example. You don't need to do 5. It's just whatever number you clicked. But notice that the little run also appears there in the 3D view. Okay. Now what I'd like you to do is move away from that some distance, click, and then start moving again. Notice that those 2 runs are going to be connected together with a landing when you click. So I'm going to create some more risers there, and you can see the landing has appeared. That's controlled by this setting here on the options bar. Okay, so what that means is you just simply need to focus on placing runs, and Revit will fill in landings wherever they're required. And it will even shape those landings based on the context of what you're drawing. So if I kind of come over here somewhere and start drawing another run at this angle, notice that it creates an appropriately shaped landing. So now I'm going to finish this up by using up the remaining risers over here. And I've created this sort of multi-landing stair now because I've got several short runs and several landings along the way. And I'll click finish. And of course, I get the stair that shows here in 3D and of course the railing on either side. Now, those are the absolute basics of using the stair tool, just in terms of the mechanics of actually drawing a stair. Feel free to draw some other shapes if you like. And in fact, I'm going to point out just a few other tools that you might want to experiment with. We've been focused on straight run stairs, which is all I'm going to do in this video. But on your own, if you want to explore spiral and L-shaped and U-shaped, you can do all of those as well. I'm going to click cancel here to cancel that edit mode. I'm going to select this stair and delete it, select this stair and delete it. And notice, of course, that that will also delete the railings. So railings are hosted to the stairs. So if you delete the host, then the hosted elements also delete. Now, click over here into the 3D view, scroll down on the project browser, and make sure 3D is active here. And then double click this view called 3D stair. Okay. So that's going to open up another tab in this tile on the left. And so your 2 3D views are here. Then I want to click back over here into the floor plan and pan and zoom in on the lobby area here on the floor plan. So this 3D view that I provided in the exercise file is looking at that same space in 3D. Okay. So now we're going to create the stair that's actually required for this building design. And we're going to build it in the 2D view, but we're going to see it come together in 3D as we work. Okay, so this can be, it's not required, but this can be a nice way to do it. Okay, all right, so I'm going to go to architecture, click the stair tool again. And this time I want to point out some of the settings that we've already seen, but just in a little bit more detail. Okay, first of all, we are drawing runs and straight run. And as I indicated, if you want to explore the other shapes later, you're welcome to do so. We're not going to do that now. We've already talked about automatic landing. We're going to benefit from that. We're going to keep that turned on. Right next to that is actual run width. Now, mine is set to 3'8", which is appropriate for the building codes that I typically work under. So if you're working in imperial, set it to 3'8". If you're working in metric, go with 1100 millimeters. If you work in an area where the different building code and you want to choose a different number, that should be fine as well. But for this example, either 3'8" or 1100 should give us good results. Now, looking at the properties palette, the stair that you're drawing should be called steel pan stair. I added this type to the exercise files just to make sure that what we were seeing in imperial and metric was the same. So the name of the stair is called steel pan. If it's not, open up the type selector and choose it now. We're going to go from L1 to L2. So that just simply means we're going to start at the lower level and we're going to go up to the second level. Makes perfect sense. That ends up giving us 18 risers. So this parameter here that says desired number of risers, that gets automatically calculated for you based on the settings that are in this type called steel pan stair. Now, if I scroll down a little bit, it's calculating the actual riser height as a consequence of that 18. So if you take the floor to floor height between level 1 and level 2 and divide by 18, you come up with this number here. Okay, so you can't change that number, but you could potentially change this number. If you try to set this number smaller than the number that's there, it will probably generate a warning, and it will tell you that you've exceeded the maximum riser height. Okay, so I'm going to click OK there and set this back to 18. So notice it does let you click OK if you wanted to. So if you deliberately want to create risers that are too tall, it is possible to do that. Likewise, you could change the tread depth and make it smaller or bigger, but if you go smaller, that might also generate a warning. Well, let's leave this at 18. Let's leave this at whatever it was set to. It's 11 in the imperial file. It should be 275 in the metric file. Now, where do those settings come from? What's actually controlling whether or not a warning displays? Well, if we go to edit type, here at the top, you will see a maximum riser height and a minimum tread depth. So in the imperial file, that's 7 inches for the maximum riser and 11 for the tread. And in the metric file, that's going to be 175 for the maximum riser height and 275 for the minimum tread depth. So we're not going to change any of that. I just wanted to point out to you where those settings are coming from. So simply click cancel here and we're ready to start drawing the stair. So this one we're going to do a little bit more systematically. So I'm going to click a start point right about here in the lobby area and start moving directly to the right. When the gray message says that 9 risers are created and 9 are remaining, click your second point to create the first run of this stair. Now we're going to move straight down so that we're lining up with the first run, click a third point, move back to the left, and create the remaining risers with a fourth click like so. And that creates a U-shaped switchback stair and, of course, fills in the landing for us automatically because we had the checkbox chosen for that option. I'm going to zoom in here, and the distance between this run and this run is random right now because I just eyeballed the 2 runs. So to rectify that, I'm going to use a dimension, just like we've done with other elements in Revit. So I'm going to use my Align Dimension tool, or DI, pick the inside face of the first run, and I want to look at the tooltip and make sure it says runs. If it doesn't, use your tab key to make sure it does say runs. So if it says supports, you want to tab. So then I'm going to go runs to runs and place the dimension over here, click the modify tool to cancel, come back and select the lower run now. And if you set that dimension from run to run, then it should activate that dimension. And now you can type in the value that you want, which is 8 inches in imperial or 200 millimeters in metric. So before we finish this, there's one more setting I want to point out to you, and that is the railing setting. When we created the first few stairs, they automatically created railings. But why? Well, that's controlled by this setting here. So you can set that. It might be set to default. You can set it to default. You can even set it to none. So if you want to create a stair without a railing, you can set it to none. But the one we're going to choose for this example is the IBC pipe railing, IBC pipe plate stringer here. It should already be chosen, but if it's not, just pick it from the list. And then for the position, I want to change that to stringer. Okay, so it's probably defaulting to treads. Let's change it to stringer and then click OK. Let's click the finish button here to complete the stair. And we now get our new switchback stair complete with a railing on each side. Now, you probably are getting a warning here about the inner railing telling us that there's a break in it. We're going to address that in a future video. So for now, I'm just going to click anywhere to dismiss that warning and deselect the stair. So that's the basic mechanics of building stairs. Feel free to experiment further in this file before continuing. In this video, we're going to continue working on stairs, and we're going to take an existing stair and do some modifications to it. So the first thing that I want to point out is this exercise file has 2 views when it first opens. So the 3D stair view is here, and notice that there's also a floor plan, architectural level 1 floor plan open as well. So I'm going to start with the 3D stair view, make that the active view, go to the View tab and click Tile Views, or you can type WT. And then I'm going to adjust what we see on both sides. So in the 3D view, I'm going to zoom in kind of closely here at the transition of the inner railing. And then I'm going to zoom in roughly the same spot in the floor plan as well. Now let me go in nice and close on the floor plan because I think it's really easy to see the problem. Notice that in the upper transition there, it's kind of disjointed and sheared off, and you can see that a little bit in the 3D as well. Now another way that you could see that there's a problem there is to actually hover over the railing in 3D, press the tab key, and then that's going to allow you to select the top rail component inside that railing. And when we do, you should see that there's a button here that says Show Related Warnings. And when I click that, that's going to display this dialog, which says what we can already see very clearly in both views, that the rail is not continuous and there might be a break and a sharp angled transition. So yeah, we're seeing that, and it's just confirming that for us here. Now, there are potentially a few different ways that you could solve this, and your first instinct might be to select the railing and start manipulating it. It's not really the railing that we want to modify, because the shape of the railing is actually coming from, or as a consequence of, the shape of the stair, because this railing is hosted to the stair. So what we actually want to modify here is the stair, not the railing, and the railing will then take care of itself. Okay, so let me select this stair, and I will click the Edit Stairs button here to go into the edit mode for the stair, and the modification is actually quite simple. The first thing I want to point out to you is a stair is made up of multiple subcomponents. So we have runs. In this particular stair, there are 2 of them. And if you wait for the tooltip, you can see that it says runs there. We have landings, okay? And this one has just the one landing, but there it is right there. And then we have supports. And supports are like the stringers and the other supports all the way around the stair. Now, all of those pieces are interconnected to one another. So if you manipulate one, it'll have an impact on the others. So what we're going to do is select this run here at the bottom, go to our move tool. I'm going to pick a start point anywhere on screen, but up here out of the way is perfectly fine. And I'm going to start moving to the left. Type in the value you want to move. In the imperial file, I want to go 1 foot 6. If you're working in metric, do 450 millimeters and press enter. And you can already see that that has corrected this lower portion of the stair quite nicely. Notice that it has now added this dog leg to the landing, and it's also added in a new support here because we have a nice smooth transition now from sloped to flat. So we can repeat that same process with the upper landing to correct this kind of disjointed connection right here. So I'm going to select that upper landing, go to the move tool, pick a start point, start moving to the left. And this time I want to go 1 foot or 300 millimeters. And now you can see that we have a nicer transition there on both sides. Okay. Now, you obviously have to have enough room in your design to accommodate the larger landing, but honestly, in most cases, not only is this the simplest solution, but it's really the best solution because most building codes call for that kind of a configuration anyway. So if you're trying to follow a particular building code, there's a pretty good chance that it's going to require those kinds of clearances. And so the solution to both problems is as easy as moving the runs. Let's click Finish and see the result. You can see that now not only has it corrected the stair, but notice that the railing is much nicer. And if I tab in and select that top rail, notice that the warning button is gone because the warning no longer exists. There's no need to show us that as a condition anymore. Okay. So that was a real easy solution to that problem and gives us a much nicer transition there. Now, the next thing I want to point out is a little bit more about the interconnected behavior of those different parts and pieces. So I'm going to select the stair and go back into Edit Stairs. And let me zoom out in both views now, just so we can see the entire stair. So this time I want to direct your attention to the riser numbers. Now, remember, those numbers came into play when we placed the stair runs in the first place. So the points you click will set the start and end run. Now, if I select one of these runs, I'm going to pick the upper one where we go from riser 1 through 9. Notice that there are these grip controls at the end. There's a little dot and a little triangle. And I'm going to show you both of these. Now, I'm going to start with the little dot, and mine are right down the center of the stair, but those grips will follow the location line of the stair. And if you want to experiment with stair location lines, notice that there are actually 6 different options, but I'm going to leave mine right in the center. And I'm going to take this little dot here, and I'm going to drag it just a couple of clicks to the right. And notice what happens. We're now at riser 3 there. We're still at 9 on this side. So what it actually did was removed the bottom 2 risers. Now, if you look at it here in 3D, the stair is actually floating off the ground now. Now, the only time that might be appropriate is if you were going to build up a platform to reach those stairs. So that's not the condition that we have in this case. So I'm going to take that little dot and drag it back 2 clicks to get back to riser 1. But that's what the little round dot does. Now, the triangle, I think, is way more interesting. If you manipulate that one, watch what happens. So I'm going to take that and drag it to the left a couple clicks. So now my top run says I still start at riser 1, but look where I'm ending. I'm ending at riser 12. As a consequence, I need to end up at 18, right? So here I've got 13 through 18. So while we lengthened the first run, it actually shortened the second one. And then you may have noticed also that the consequence for the landing is that the landing had to move up, right? Now watch the landing as we do it the other way. I'm going to drag that now back this way. And notice that the top run shortens, the bottom one lengthens, and the landing moves down. So all of these pieces are interconnected with one another. In fact, you can even select the landing, and there's a relative height right here, and you can type in a value. I'll do 5 in imperial or 1,500 millimeters in metric, and that will affect both runs. Okay? So a lot of different ways that you can manipulate that. So what I want to do is I want to select the top run here, and I'm going to use the triangle and stretch this so that I end up with risers 1 through 11 across the top and 12 through 18 across the bottom. Okay, so that's the final configuration that I'm looking for there. Once I've done that, I'm going to go ahead here and click Finish. Okay, so that now completes the shape of the stair that I'm after. Now, notice the stair is kind of floating down here in space, okay? I often like to do it that way. When I'm building a stair, I like to just build it in free space first, and then I like to move it into the position where it needs to go. Now, it's not required that you do it that way, but that's just my personal preference. I just find it a little easier. Now, if you look here in the 3D, you can see we've got a little piece of the floor kind of jutting into the space there, and that's the top landing that we're trying to get to with these stairs. So I'm going to take the entire stair object and move it over to that location. Now, it would be easier to do that in plan if I could see where that landing is. And if you think back to one of our earlier videos, the video where we created roofs, you remember that we had a feature called underlay. Well, we can turn on the underlay for the level 1 floor plan temporarily and show the second floor so that we can make this move easier. So that's what I'm going to do. Make sure nothing is selected in your floor plan. Scroll down and locate the underlay setting. It's currently set to none, and I'm going to choose L2 and then apply that. And now you're going to see that underlay ghost in that location. Now I can simply select the stair and move it. So I'm going to kind of move it roughly first, then zoom in, and I want to snap right from the bottom endpoint right there. So right there, and snap that right to this point here. And so now the stair is positioned in the location where I want it. However, notice in 3D that even though it looks good in plan, it doesn't quite look right in 3D. So our runs are reversed. Well, it turns out there's a really easy solution to that. If you just click the stair, notice this little arrow here. This allows you to flip the direction of the stair. So I'm just going to click that. And the plan view remains unchanged, but notice that flipped the 2 runs and the landing adjusted. And so now it makes a lot more sense, and we're able to go up the stairs and end up at the desired location on the landing above. So those are some of the more common modifications you might want to make to stairs as you're working on your own projects. I encourage you to experiment further here in this file if you wish before continuing on. When you build a stair in Revit, initially it will span from one level to another. But it's possible to select additional levels and create what Revit calls a multi-story stair. So in this video, I want to talk about that concept, and I'm going to demonstrate it in the context of the sample architectural project that comes with the software. Now, it's possible that you might see it right here on your recent files area of the home screen, but chances are you're not going to see it displayed there because you're going to see your own recent files here. So if that's the case, come up here to the top and click this back button here. That takes you back to the ribbon interface. Open up the file menu, highlight open, scroll down here to sample files and click it, and that will display a window with all of the sample files. Scroll down to the bottom and you're looking for Snowden Towers Sample Architectural. And this is the file that we want to open. Now, you must open this from the locally installed copy that comes with Revit. I am not providing this separately as an exercise file, so you do need to open it from your installed copy, but it is included with the Revit software in that folder. So when the file loads, we're going to be looking at the cover page, and I want to consider the stairs, as we said. So I could scroll through the project browser looking for views that show the stairs, but a much easier thing to do is to take advantage of this search field here at the top of project browser. You can put in any keyword you want, such as stair, and notice that that will filter the list of available views to only those that contain that keyword. So we've got several 3D views that focus on the stairs and several sections that do as well. So I'm going to start in this one here called Cutaway Stair 1, and I'm going to double click it, and I'll just zoom in just a touch, and I just want to show you what a multi-story stair is in this view. Move your mouse near one of the stairs, and it will highlight vertically the entire thing with a dashed box. Now, if you're thinking that dashed box looks familiar and kind of seems a little bit like a group, then that's a correct intuition. It's not exactly a group. Multi-story stairs are not groups, but they have a lot of similar characteristics. And of course, they have the similar interface here. So when I click on it to select, it selects the entire stair tower as a single element. So that's what we're going to be considering here in this file. Now, I'm going to focus on a different one of the stairs. There's actually 3 stair towers in this project, and they're all a little bit different. So I encourage you to explore each one. But let's go to Cutaway Stair 3 instead. And the reason I wanted to go to Stair 3 is because at the bottom of the building, you've got just some standalone stairs. So right here, we have a straight run stair, which goes from the street level up to the next level above. This one is kind of interesting because it switches back twice. So it starts down in the basement level, goes up to a landing, then goes up to another landing, and then ends up at street level. Okay. Those are not multi-story stairs. Those are just plain old standalone stairs like the one that we built together in an earlier video. So if you want to create a multi-story stair, you start with a stair. Okay. And if you're not sure how to create a stair, go back and watch the earlier video where we covered that. Once you've done that, then you can turn it into a multi-story stair like we see here on the upper levels of Stair Tower 3. Okay. Now, in order to work with the multi-story stair, you need to be in a view where you can see the levels. So the levels are not turned on in this 3D view. So what I'm going to do is open up the section instead. So there is a transverse section, Stair 3 right here. I'll double click to open that. And now we're looking at that stair tower in section. So again, here was the basement stair. Here's that straight run going from level 1 to level 2, and then the stair tower above it. So why don't we start with this one right here? And what I'm going to do is just copy that over here outside the building. And then I'm going to click modify. And let me just show you how you can turn a regular old stair into a multi-story stair. When you select it, there is a select levels button right here. Simply click that and it will prompt you to select additional levels. So I could select just level 3, or I could add to that level 4. I could pick only level 4, or I could hold the control key down and select both levels 3 and 4. It's whatever you want to do. You can add one level or many levels. And when you click finish, it will turn that into a multi-story stair. So notice that it now gets that dash box around it. When you hover over it, it says it's a multi-story stair. And what it essentially did was take the stair that you had and copy it to the upper levels. But now you'll also notice an interesting thing takes place, right? The height from level 1 to level 2 was rather short, okay? I'm going to throw a dimension on here to show you. Now, even if you're working in metric, this particular file is in imperial only. So just bear with the imperial dimensions if you're a metric user. My apologies for that. Notice that the floor-to-floor heights of each of these stairs is different. So what that means is, even though this is considered a multi-story stair, if you tab in, each one of these is going to be independent of the others. Now, once you've created a multi-story stair, you can always modify it. So what I'm going to do is add to it level 5. Now, let's throw a dimension between level 4 and level 5, and notice that that dimension is the same as the distance between level 3 and level 4. They're both 13 foot 4 inches. So I'm going to select this stair, and now the button changed from add levels to connect disconnect levels. So using this button, you can now remove levels if you want to. So I can do disconnect levels and say I no longer want level 4, and it removes that from the stair tower. Now that's my stair tower. Or I could go back in to connect disconnect, and this time I will connect levels, and I'll add in both levels 4 and level 5. And I'll click finish. And now you can see that my stair tower goes 4 levels. But here's how it's different now. Because the height between level 3 and 4 is the same as 4 and 5, when I tab in, this stair is independent, this stair is independent, but notice what happens with these two. Okay. Now, I'm not sure the official term for this from Revit, but I call these height groups. Okay. So each height that's the same, it kind of treats those as a single item. And what we mean by that is if you were to tab in and select one of these stairs now and do edit stairs, if I were to change this stair in some way, the changes that I apply to it will apply to the other instances of the height group. Now, there's not much I can change about a straight run stair, so I'm going to do something a little silly. I'm going to delete the stringers. So that's going to leave me with just the stair itself, the run. And when I click finish, notice that those changes apply to both instances of that height group, but did not apply down here or down here. So that's kind of the overall behavior of a multi-story stair. Okay. So once you kind of play around with it a little bit yourself off to the side, then you can kind of see the ones that are already here in this file and kind of have a little bit more understanding about how they function. So I do encourage you to spend some more time in this file. Look at all 3 stairs in the 3 different stair towers because each one is a little different than the other. And I think you can learn a lot about stairs in general and certainly multi-story stairs by reverse engineering what you find here in this sample file. Most building codes have requirements for railings to extend past the ends of stairwells at both the top and the bottom. And so in this video, I want to show you some techniques we can use to achieve that using Revit handrails. So I'm actually going to do 2 different conditions. For this railing here, I want it to extend down and return back to the post. And for this railing here, I want it to extend and return into the wall. So since I want to do 2 different things, I'm going to duplicate the type for each of these railings and give them separate names. So I'm going to click Edit Type on the one by the wall there and duplicate it. And I'll just add a suffix to the name there for wall extension. And then I'll repeat that with this one. Duplicate it. All right. So now I have 2 different railing types, and we can treat each of them a little bit differently. So I'm going to pan this view over slightly because we're going to be going in and out of dialog boxes, and I want to be able to see the view in the background as we work. So with this railing selected, I'm going to click Edit Type, And I'm going to move this out of the way as well so that we can see both the 3D view and the settings. And there are several different places where we have rail structure in the railing type. At the very top here, we have rail structure non-continuous. That doesn't support extensions, so we're not going to be discussing that at all here in this video. So I'm just going to ignore that. If you scroll down a little bit, we have top rail, handrail 1, and handrail 2. Each of those does support extensions, so that's what we'll be discussing from here on out. Now, I'm going to start with the top rail, and notice that currently the type is set to circular. I'm going to click the little browse button next to that. That opens up the properties for the circular type. And then if you scroll down slightly, you will see extension settings for beginning and bottom and for end and top. So since we're looking at the bottom of the stair, I will edit this value right here. If you're working in imperial, put in 1 foot. If you're working in metric, put in 300 millimeters and click apply. And there's our first gotcha. Notice that it extended on both railings. Now, at this point, you might be thinking, why is that? Didn't we just duplicate both of those railing types? Shouldn't they behave independently? And the answer is yes, we did duplicate both railing types, but railings are a nested collection of settings, and both of those railing types that we duplicated are referring to the top rail type called circular. So what I'm going to do is set this back to 0, and I'll click OK, and that will remove the extension temporarily. And then what I want to do instead is click back into the properties here, but before I make any changes, I'm going to duplicate it and use the same suffix on the end of the name that I did a moment ago. I'll click OK, and now I'll set that beginning bottom length to 1 or 300 millimeters, click apply, click OK, and then apply, and notice that it now only applies to the one railing. So now we're starting to make some progress. So what's most challenging about this functionality is just knowing which dialog box to be in and kind of getting through all the weird little gotchas that occur along the way. So you just have to be very methodical about your approach here and you can get good results. So, okay, so now that we've done that and we know that we're getting what we want, there's still one more setting I want to change because I did, after all, say that I wanted to extend it and return it back to the post. So let's click in here and go back to those properties one more time. The length is just one of the settings, but notice here, there's a drop down for extension style, and we can do wall, floor, or post. So here's what floor looks like. And we said we wanted post, so here's what post looks like. So that looks pretty good, but we also have this other setting here where you can extend a tread depth in addition to the length. So I'm going to check this box and click apply, and that extends it out further, the distance of 1 tread, which is a pretty common code requirement. And that completes that railing type. So I'm going to OK out of there a few times, and now we'll direct our attention to this one. So I'm going to go back to edit type here. And notice the top rail here is still set to circular, okay? Well, you could go to edit type, duplicate, and call it wall extension, except that even though the extension types say that they support wall extensions, that's actually not the case for top rails. So that's another gotcha that I will spare you from in this example. So we can't use a top rail here if we want to do a wall extension. So what we're going to do instead is focus on handrails. Now, it doesn't matter whether you use handrail 1 or 2. Railings can have 1 handrail or they can have 2 handrails, 1 on each side. So that's why there's 2 of them. But in our case, we only need 1. So I'm just going to focus on handrail 1, and the type currently says none. So what we're going to do is click the little browse button there, and we're in a similar dialog, and it has its own type called circular. Now, just to keep all this straight, best practice, let's duplicate it and rename this to wall extension. I'll click OK, and now we can configure it to have that extension. So we've already seen that we can set the length. We've already seen that we can do plus a tread depth. And right here, we can choose one of the three types. So in this case, I want the wall extension type, and I'll click OK, OK again, and there's our final gotcha. Nothing happens. So at this point, it would be understandable if you were getting frustrated, right? So let's go to edit type. And the last thing that we need to talk about with respect to handrail 1 and 2 is, even though you can configure a type and assign it and set up all the settings, there's a little setting right here that we missed called position. And it currently says none. And you may be thinking, why on earth would I ever want to choose a type and leave it set to none? I don't really have a good answer for that question, but when you open up the list, it maybe makes a little bit more sense because there's an option for either left or right or both left and right. So when you consider that there's different places we can position it, I suppose having the none option seems a little more logical. But anyway, we need to choose one of these other settings. So I'm going to choose left and click apply. And in that case, I actually took a guess and I guessed correctly, and it looks fine. If in fact it went to the opposite side, you could just switch it to right and try that again. But that completes that wall extension railing as well. So setting up the extensions, a little bit challenging if it's your first time, but stick with it. It's one of those things that once you get past all the little gotchas, it's really not that hard to do. And you can get railings that conform to local building codes. In this video, we're going to create a freestanding railing. So up until now, the railings that we've seen have been attached to stairs, and railings are somewhat unique in the sense that you can create them either hosted to a stair, in which the stair determines the shape of the railing, or you can draw them yourself freestanding for guardrails, handrails, that sort of thing. So in this video, we're going to look at a guardrail example, and I'm going to zoom in here. I'm in the second floor plan, and I want the guardrail to follow this balcony that we have up here on the second floor, this floor element here. So to do that, we're going to go to the railing tool, and you'll see that there's two options, sketch path or place on stair and ramp. We're actually going to look at both of these in this video. I've removed the railings from the stair so that we can try both tools. But let's start with the sketch path tool, and we'll sketch a freestanding guardrail first. So we could just simply start drawing the path of the railing, but I think it'll be easier if we use this pick lines tool right here. And the reason for that is because we can just touch the edges of other geometry like the edges of the floor. Now, the only trouble with that is if I just click the edge, it's putting it right on that edge. And I think it would be nicer if it was offset away from that just a little bit. So I'm going to do Control Z one time to undo that. And then up here on the options bar, I have an offset parameter. And in the imperial file, I'm going to use an offset of 2 inches. If you're working in the metric file, use 50 millimeters. And now you'll see that I can either offset to either side of the line. So I just want to offset to the inside where the floor slab is. Click. I'll do this little short line here, click, and this long one right there. I'll click the modify tool to cancel. If we zoom in at this end, everything looks pretty good. If we go to the other end, you'll see that the sketch line is just a little bit too long and it penetrates into this column right here. So easy enough to fix that. Just select the sketch line, use the little grip control at the end here, and we're just going to drag that back some distance like so. Then you're going to see some temporary dimensions appear here. And there's a witness line grip right here, which is referencing this reference line. I'm going to click and drag that dot to snap it to the column face. And now I can edit this dimension value and put in the offset that I'd like. I'm going to use 4 inches for imperial or 100 millimeters in metric. So that is the sketched path for my railing. I'll click anywhere to deselect. Let's click the Finish tool. And you can see the railing appear here in the floor plan, but I think it'll be a little bit easier to understand what we've created if we go to 3D. So I'm going to scroll down here on the project browser and locate the 3D stair view. This is a view that we used in earlier videos. And you can see that railing right there up along the balcony. Now I'm going to hold the shift key down and orbit the wheel to kind of spin around to a different vantage point so that we can see it maybe a little more clearly. So you can see it stops here right at the top of the stairs. And then right there, you can see the little 4-inch or 100 millimeter gap that we placed at the end. Now, if you're satisfied with this railing type, you can leave it alone, but I've got some other railing types here in the file, which might be a little bit nicer in this scenario. So in earlier videos, we were using the IBC pipe rail type. Now that type is right here. This is the one that was built into the template file that we used to start this project. So it's IBC pipe rail stringer, extension top and bottom. If you watched the previous video, then you saw that railings can have extensions at the top or bottom. Now, this railing is not on a stair, so top or bottom would be like left and right, if you want to think of it that way. So if I use that railing type for this guardrail, you can see that the extensions don't really work for us in this scenario because now it's penetrating past and kind of projecting over the stair. And then this one, you have to hover over it to see it's actually now penetrating into the column geometry. So what I've done in this file to kind of save us a little bit of time is I duplicated this railing type a couple times and removed the extensions for the different scenarios that we're going to have here. So this one here that says no extension is a copy of the same railing, just with the extensions removed on both ends. So I'm going to choose that one. And you can see now that we've got the railing freestanding over here and freestanding over here. And I think that looks a little bit better. So to finish this up, I'm going to spin this around in 3D here so that we can see the staircase now. And I've removed the railings from the stairs in the exercise file, so let's add them back again now. That was that other tool on the drop-down for the railing tool that we saw at the beginning here. So all you need to do to add the railings back to the stair is choose Place on Stair or Ramp, and then you can touch the stair and it will add those railings. Now, before I do that, though, I always forget to check this. So let me point that out to you and see if I can save you the trouble of making that mistake. Just like we saw when we were placing the railing inside the stair, you can choose whether or not the railing should reference the treads or the stringers. I think it'll be nicer if we reference the stringers. So I'm going to choose that button before I click it. And then when I do, you'll see it'll create a railing on both sides. Now I'm going to click the Modify tool to cancel out. And of course, it's using that default handrail rectangular again. So now what I'm going to do is swap out each one of those with the appropriate types from the ones I showed you a moment ago. When you're using the Pick Stair tool to add railings, it automatically uses the same railing on both sides of the stair. You don't have control over that. So you're always going to need to come back later and change out the railing type to whatever you want after you've placed it. So for the internal railing here, I've created one that has the extension only at the bottom. So you can see up here at the top where it meets the other handrail, I don't want to have an extension. I just want those to come together nice and cleanly. But down at the bottom, I do want to extend out. So that's what this railing is for right here. And you'll see that it will connect to this one and it will extend out here. Now we've got a little bit of an overlap there that we'll deal with in just a moment, but let's come back to this one now. And we're going to choose the original type for that one with the extension at both the top and the bottom, since it's freestanding over here and here. Now I'm going to go back to the level 2 floor plan, and you can see that I've got a slight overlap and that my offset is a little bit off there. So you can easily go back to the railing, choose Edit Path. It looks as though the offset of 2 inches should have probably been maybe 1 inch. Now, I still like 2 inches for this segment and the other segment. So what I'm going to do is just take this segment here, move it down 1 inch or 25 millimeters if you're working in metric to get it in the center of this other one. And then I'll just take this little grip here and pull it back to right there so that it snaps to the end of the railing. There it is. Okay. And I will click Finish. And now you can see that touches more cleanly. And when we go back to 3D, that looks a lot better. So that is how you can create custom railings, both for handrail conditions, guardrails, and also to place them on stairs or ramps that don't already have them.
The subject of all the videos in this chapter is going to be walls. So I thought it would be good for us to take a high-level look at walls before we start on any specific topic. Let's begin the discussion with a reminder of how walls fit into the overall Revit element hierarchy. At the top of the hierarchy, we have categories. There are many categories, including walls, and they are responsible for making elements behave in ways consistent with their real-life namesakes. Categories next branch into families, and there are two varieties: component or loadable families and system families. The main two distinctions of note between these two are if the family is loadable or if it is editable. Component categories are loadable and editable by the end user. System categories are not. So to use a loadable category, you must first load and possibly create a family of that category to make that element available for use. With system categories, loading is not possible, nor is it necessary, because they are already available within your file. System families are built in. That's what system means. Walls are system families, and this means that all of the wall families that you have available to you are already built into every project and available for your use. But what about the subject of editability? When I say that you cannot edit a system family, when I say that system families are not editable, what we're really talking about is just at the family level. At the type level, you can always edit. So every kind of family, both system and non-system families, can have user customizable types. And we frequently do this. Consider the typical process of edit type, then duplicate to make a custom version of the type. This can be done for both component categories like doors, fixtures, and furnishings, and we can do it for system categories like roofs, floors, and of course, walls. So to be clear, walls are system families, and this means that we can't edit the wall families themselves, but we can and often do edit the wall types. So when folks talk about different kinds of walls like stud walls, brick walls, or block walls, what they're really talking about are different types of a wall family, and specifically in these examples, the wall family called basic wall. So just how many wall families do we have at our disposal? There are only three. The first is the basic wall. This is a simple assembly of layered construction where you have one or more layers of material sandwiched together. If you look at that wall in either floor plan or in section, you'd see essentially the same thing. The same set of layers would be running in both directions. That's why they're called a basic wall. The structure is basic in the sense that it's the same material throughout, regardless of how you slice it. The next family is the stacked wall. It's slightly more complicated because it contains two or more basic walls, literally stacked on top of each other vertically. So if you slice it in plan, you're going to see the structure of whichever basic wall you happen to be slicing through. But if you slice it in section, you're going to see the entire stack. This means that it varies in the vertical direction from what it looks like in the horizontal direction. The third and final wall family is the most complex. It's the curtain wall. This has a complex grid pattern of structure that defines a series of bays running both horizontally and vertically. We can express those bays using a variety of nested subcomponents, which include mullions and panels. One way to think about the three different wall families is that they get progressively more complex as you move from the basic wall on up to the curtain wall. In the videos that follow in this chapter, we're going to consider each kind of wall family and gain some hands-on experience using each one.
In this video, we're going to create our own custom wall type. Now, we're going to be focused on basic walls here, and we're going to create a wall for this condition right here in these restrooms. So the wall that's there is a bit narrow to receive the plumbing that would be required in that wall. So we're going to create our own custom type to accommodate that situation. Now, what I typically recommend that you do when you are getting ready to create your own custom wall type is to start with a wall that's close to the one that you want to create. And I've done that here in this situation. So this wall is the same as any of these others in these other spaces here. And the assembly structure of that wall is that it is a metal stud in the center, and then it's got a layer of drywall on each side. So it's a pretty basic stud wall construction. So let's take a look at that, and then we'll talk about how to create our own custom one here. So to get to that assembly structure, you just select the wall and then click Edit Type. And that's going to take us to this dialog. Now, I do want to remind you that walls are system families. So we're not going to be creating a new wall family. Sometimes folks say that, but what you're really doing is creating a new wall type. Okay. Now, this is super important. The absolute first thing that you want to do here is remember to click Duplicate. If you don't, you will be changing the interior partition type that you have selected there. And when we finish, lots of walls in my model will get really thick. Okay, so we don't want that to happen. So the very first step is to click Duplicate, and then I'm going to give this a good descriptive name. So I'm just simply going to call this plumbing wall for this example and click OK. Now I'm going to click this Edit button here next to Structure, and this is where we can see the assembly structure of this wall type. Okay, so a few things about this dialog. First of all, mine might be wider on screen than yours is. This dialog is resizable. So if yours is really narrow like that, you want to stretch it out so that you can read each of these columns. In addition to that, there's a preview down here at the bottom. And if you click to open that up, then it gives you this little thumbnail preview over on the side, and that can be helpful while you're working here as well. Now, you've got two different thumbnails you can choose from, a floor plan or a section. I like the section because when I select layers in the table here, they highlight over here, but it doesn't do that in the floor plan. So let me show you. I'm going to switch to section. Now, initially, it's going to get really tall. So over here, there is a sample height field, and I'm going to drop that down to just 3 feet if you're working in imperial, or 900 millimeters if you're working in metric. Then I'll right-click anywhere in this preview and choose Zoom to Fit, and that brings us in a little bit closer so we can actually see what we've got here. And now notice that I have layer 5 selected, and it's highlighted there in the preview. Here's the core boundary. Here's the structure layer, the next core boundary, and the finish layer, layer 1. So I just like that a little bit better. I think it's a more interactive experience. And so that's what I recommend, is to work in the section preview. So now we're here, and what we want to do is consider the current assembly and how we want to modify it to create this plumbing wall. And it turns out that all we really need to do is add another stud layer and then an airspace in between the two. Now, let's talk about the way these layers work here. Notice that there's a green line here in the preview. And if I click over here on this finish layer, there's another one over here. Those green lines are this core boundary and this core boundary. Okay. And those are always 0 in thickness. So they're not really layers. What they are is the boundary between the core and the finish. So that means you can think of the wall assembly as being in 3 zones. You've got the core, which is like the structural part of the wall, and then you've got the potential for a finish on either side. Okay. This particular wall has 1 layer in each of those zones. Now, any one of those zones can have more than 1 layer. And in fact, the finish zones, you can remove layers. So you could have no layers in the finish zone, but you can't remove the last layer in the core. Okay. So the core must contain at least 1 layer, but all the others are optional. Okay. But you can have as many layers as you want within each of these zones. So what we're going to do is select layer 3, the core, the structural layer, and then click Insert 2 times. That's going to create 2 more structural layers in that core zone. So notice that they're between the boundary and the boundary. Now, the preview hasn't updated yet, and that's because the thicknesses of these 2 layers are still set to 0. So the easiest thing to do is I want to make layer 3 match layer 5. So I'm going to select the thickness of layer 5, Control C to put that on my clipboard, and then click here and do Control V to paste that in. So that's the easiest way to copy that information over, just using copy and paste. Then I'm going to repeat that with the material. So I'm going to select metal stud layer, Control C, click on where it says by category here, and Control V. And now I've got those two stud layers established. So now I just need to widen the space in between those two to create my air gap. So let's click here in the thickness for layer 4 and type in a value. If you're working in imperial, go with 5 inches. If you're in metric, do 125 millimeters. So we're almost there. The only thing we need to do now is assign an appropriate material and function to this layer. So let's start with the material. I can't do copy and paste this time. So what I'm going to do instead is click the browse button here and just find an appropriate material in the material list. Now, it turns out that I just want an air gap, so it's right here at the top of the list, but you can also search in this dialog. So if you're looking for brick or concrete or some other material, you can just type the name up there. But again, as I said, we just want the air material here. That'll be perfectly fine for this, and that will assign it to that layer. Finally, that leaves us with the function here in the first column. Now, the functions are a list of built-in values, starting with structure at the top, going down to the finish layers at the bottom. And there's also a membrane layer, which we're going to ignore for now. So the first 5 entries have numbers next to them, 1 through 5. Number 1, structure, is the highest priority component. Finish to 5 is the lowest priority component. So all that means is when two walls intersect one another that have varying priorities, those numbers are going to help determine how those wall layers interact with one another. And I'm going to show you that directly on screen in just a moment. So for the time being, let's choose thermal air layer, priority number 3, and let's OK, and then OK again. Now, the only change we're going to see here in this view is the wall is going to get thicker. Okay, so that's good. That's what we wanted to have happen. But now I want to show you that layer assembly in closer detail. And rather than try and do that here in this floor plan, I'm going to use this callout that I've placed at the top of the intersection here for that purpose. So select the callout, right click, and choose Go to View. And now we're zoomed in on just that intersection. But we want to turn the level of detail from coarse to either medium or fine. So there's a little pop-up down here. I'm going to choose medium. And now we're seeing the layer assembly on both of those walls. So this exterior brick wall has its core in this wide layer down here. That's the stud layer. And then it's got a substrate, an air gap, and a brick veneer on the exterior finish side. On the interior finish side, it's got drywall. Our wall, well, you've already seen the assembly of it because we just built it together. Now, to really understand how the priorities work, let's just temporarily do something that would not normally be done, but let's go ahead and drag this wall through the brick wall like so to get it to pass right through the brick veneer on the exterior of the wall. Okay, so looking at it this way, you can start to understand now how the priorities function. The metal stud layers in both walls are intersecting each other and cleaning up seamlessly. And that's because both the priority, structure priority 1, and the material, metal stud layer, match. If either of those don't match, you'll get some sort of a seam there. It won't be smooth and continuous. Now, if you recall the assemblies, the next priority was substrate priority 2, and that's plywood sheathing in the case of this wall. And if I zoom in here, you can see that's right next to the core. Then next comes an air layer of priority 3. That's this one here, finally followed by brick at priority 4. So as we look at this, you can see that even though the plywood layer is priority 2, it's being interrupted by the metal stud layers because they have a higher priority. Okay. And then finally, when we look at the finishes, you can see that the two drywalls are cleaning up together seamlessly because they're the same material and the same priority. So hopefully that gives you a little bit better sense of how the assembly structure works and how these walls will clean up with one another. I'm just going to reverse that wall connection there. And feel free to explore further in this file on some of the other assemblies, or try your hand at creating your own custom wall type. In this video, we're going to take a look at stacked walls. Stacked walls are one of our 3 system families, and they are quite literally a stack of basic walls sitting on top of one another. So let me start by showing you what we're going to do. I'm going to go to the building sections branch here on the project browser, double click the section at East Wing. Let's zoom in over here on the right. And what we currently have is a basic wall with brick veneer sitting on top of another basic wall for the foundation. As an alternative, you could create a single stacked wall that incorporates both of those basic walls and then draw it as a single wall. Now, it's not necessarily better to do it that way. It's not worse to do it that way. It's just another way to do it. So I want to go through the process with you here so you can see that as an alternative. Okay, so if we're going to use that as our approach, that means that all of these foundation walls that we currently have are going to become redundant. So what I'm actually going to do is select all instances of the foundation wall in the view. You'll see there are 8 of them, and I'm going to delete them. Now, that will also remove the foundations, so we will have to come back and re-add those foundations later, and I'll show you how to do that. The next step is I want to take the walls that remain, the brick walls, and I'm going to highlight one of them, press Tab, and that should give me a chain going all the way around the perimeter of the building. Now, you may recall that if you move your mouse slightly, you can end up with one of 2 chains here, either an internal chain or an external chain. So I want to make sure that I'm getting the external chain and click. In other words, I'm going to ignore this wall across the top here, and I want to get the remaining walls, which is a quantity of 9. So with those walls selected, the first thing I want to do is change their base constraint. Since we removed the foundation walls, we're going to take these walls and drop them down to top of footing. When you apply that, you're going to see the bottom edges of all those walls drop down to that new location. Keep them selected. And now we're going to come over here to the type selector drop down, scroll all the way down to the bottom, and you will see that there is a stacked wall branch, and there are 3 types currently in this file. So you always want to pick one that's close to what you want and then modify it. So the same approach we took when building a custom basic wall. So I'm going to pick this one in the middle here, which is exterior brick over CMU with metal stud, and I'll select that. So that'll take a moment to apply, and when it does, you're going to see the construction of the wall change slightly. The most noticeable thing will be the concrete masonry units at the base, and it will generate this warning here. Okay. Now, it says it cannot be ignored. If you expand, you can see that what can't be ignored are the first 4 errors. There are 8 of them that can be ignored. Now, these errors have to do with some of the dimensions that are here in our file. I'm going to just remove those dimensions. I'm not concerned about that for this example, but if you want to investigate, what you can do is select an error, click Show, and that will attempt to take you to a view that shows what the problem is, and then you can investigate further before making your decision. In this case, I'm simply going to click Remove References so that we can continue, but that does mean that I have deleted some of the dimensions in some of the views, so just be aware of that. Okay, I've still got the 9 walls selected. I'm going to go to Edit Type next, and now I'm going to click Duplicate. Now remember how important it is to duplicate before you make any changes. You don't want to change the original type. You want to create your own custom type first. So I'm going to call this Exterior Shell and click OK. There's a single Edit Structure button here, so let's click that next. That takes me into the list of basic walls that we are stacking on top of one another. This one is really simple. There's a CMU wall upon which is stacked a brick wall. Now, the brick wall is the type we were already using in this project. We're going to keep that one. One of the walls in the stack will have a variable height. That's the brick wall. We want to keep that as well. So there's nothing to do on layer 1. It's already correct. For layer 2, we're going to select it, and open up this drop-down list here. And this lists all of the basic walls that are currently in the file. Scroll down to the foundation walls and select foundation 12-inch concrete or foundation 300 millimeter concrete, depending on which file you're working in. That replaces the bottom wall with the foundation wall. And then next to it, we can set the height of that wall. Now, the walls that we deleted were 5 feet tall in imperial or 1,500 millimeters in metric. So go ahead and set that as the height. That leaves us with the location line. So as you can see, these two walls are jogged from one another at the moment. And that's because up here, the location line that's being used is core center line. And that's not maybe the best choice for these two walls. So you can choose any of these options. And I think a better choice will be core face interior. And you'll see it shift. And I think that works a lot better for this construction. So that's all we need to do. I'll click OK, OK again. And now our model is pretty much back to where we started from. The only difference is instead of being two separate walls on top of each other, this is now a single stacked wall. Now, we lost the footings, as we've already seen. So let's go to the Structure tab. The wall footing tool is right here. And you can just simply touch each of the walls and it will add a new footing underneath those walls. Hold the Shift key and spin around, and you can keep going around the model to make sure that you get all of the exterior walls like so, and click the Modify tool to cancel out. Now, we've got the 3 walls on the east wing, which we ought to treat a little differently. So let's select this one, hold the Control key down, this one, and this one. We're going to go to Edit Type. We're going to duplicate it again and give it a new name. So I'm going to add the suffix with parapet to the end, and I'm going to zoom in up here near the top, go to Edit Structure. We're going to click the Insert button to add another layer. What that did was it split that top wall into 2 pieces, and it just duplicated the one that was already there. So at the moment, we have 2 brick on metal stud walls sitting on top of each other. Change the top one, which is now item number 1, to a wall type that I've already placed in the exercise file. It's called RET for Revit Essential Training Exterior Brick Parapet. And notice that that has brick on both sides with a parapet cap on the top. Now, the height is a little large for a parapet. Let's drop that down to 2 feet imperial or 600 millimeters in metric. And then finally, that leaves the location line. Now, this offset feature here controls the whole wall. So if you shift it to something else to fix the parapet, you'll mess up the foundation. So instead, you can use the offset field here and apply an offset to just this wall. To figure out how much that offset should be, the easiest thing to do is to OK out of all of here, go to a section view and measure it. I did that already, and the value that we want in imperial is 2 3/8 of an inch. And if you're working in metric, it is 57.5 millimeters. When you do that offset, everything should line up perfectly. Click OK, OK again. You can see the wall is coming in the background, but we've got this message here saying that walls overlap, and it's highlighting the one at the top there in orange. I'm just going to ignore that for now, but you can see there is a little bit of a gap there that you might want to address, but I want to get past that so that we can see the result of what we've done. Notice that we now have this new stacked wall here that incorporates this parapet design. Now, that pretty much completes what we want to do with stacked walls, but I want to point out a few things that you might want to further explore in this file. Your roof sketches need some attention because the sketch lines that make up those sketches no longer touch the faces of the walls properly. And that's true of this one and this one. Notice that this one here is kind of penetrating into the walls right now. So you might want to select each of those roofs, do edit footprint, and use your align tool to adjust those sketches. You'll want to do something similar with the ceilings because many of the ceiling objects need adjustment, and you might need to do the same thing with the floors. So that's all because we didn't start with the stacked wall. We had a basic wall first and we swapped it out with a stacked wall. So just as a matter of best practice going forward, if you decide to use stacked walls, you might want to incorporate them early to avoid having to redo a lot of this, to make these kinds of adjustments to the model. But it's not wrong to do it after like we've done. It just means that there will be some areas of the model that require some additional attention, and I'll let you explore that now. In this video, we're going to continue our exploration of the various wall families and move on to the curtain wall. So to begin exploring the curtain wall, I'm just going to create one freestanding out in front of the building. And to do that, you just simply use the wall tool. So the wall tool gives you access to each of the 3 wall families. So of course, up until now, we've been accessing basic walls with this tool. But if you scroll down, you will see the stacked walls here that we looked at in the previous video. And then right above that are the curtain walls. So choose this one here called storefront, and then click a point somewhere out in front of the building. Start moving directly horizontally to the right, and then type in 28 feet if you're working in imperial or 8,400 millimeters if you're working in metric. I'm going to click the modify tool to cancel out of there. And then I'm going to ignore this duplicate type marks warning and just sort of click anywhere to dismiss that. Now, let's zoom in closely on this curtain wall and let's investigate a few of its behaviors. So as you can see, this wall is a little bit more complex than, say, a basic wall would be. Well, the first thing I want you to do is move your mouse nearby, and if you highlight the center line of the curtain wall, it will highlight the curtain wall itself. And that's how you could select it by that dashed line and move it around, delete it, copy it, what have you. Now, if you click away from it and then move back again, if you get near one of the divisions, you should see a little perpendicular line marking where that division is. That's called a curtain wall grid. So curtain wall grids are used to subdivide the curtain wall's mass into bays. Now, sitting on top of that grid is a curtain wall mullion. So if you just move slightly, you should be able to highlight that little rectangle. In fact, right next to that here and here are also curtain wall mullions. Those are just running horizontally down at the base of the curtain wall. And then if you move nearby this really thin rectangle here, you're going to need to use your tab key, but you should be able to tab in and locate the curtain panel, which infills each of those bays. So those are the different pieces that make up a curtain wall. You're probably going to be able to see that and understand that even better, though, if we switch to another view. So why don't we switch to the default 3D view? So I'm going to click the little birdhouse icon up here on the quick access toolbar. I'll zoom in. I'm going to select the curtain wall, which I can do by selecting the dashed box, and then hold the shift key down and drag the wheel to orbit around that selected curtain wall until I can see it at a better vantage point. Now, I think the first thing you're probably noticing is the curtain wall panels are transparent. So notice that we can see right through them there, okay? So that's the first thing that I wanted you to see. The next thing I want you to see is that take notice of the direction of the mullions. So notice that the horizontal mullions are being interrupted by the vertical mullions, okay? So we'll look more at that in just a moment. The next thing I want to direct your attention to is these little dots at the end and these little triangles on the top and the bottom. So let's take this little dot at the end here and interact with it. Now, before you do anything to that dot, I want you to look at the curtain wall and count how many bays we have. So notice that there are 6 bays running vertically, and they're all equally spaced. That's important, okay? So now I'm going to click this little dot, and I'm going to drag it about the width of 1 bay. And what you're going to see is that it now has 7 bays running vertically, and they're still all equally spaced. Now, if you missed that, try dragging it back the other way, and you should be down to 5 bays, possibly 6, depending on how far you dragged it. But regardless of whether it's 5 or 6, notice that they're still equally spaced. Okay, so that's the behavior running in the length direction. Well, what about the height? I'm not going to use this one at the bottom. I'm going to focus on the one at the top instead. And what you see is that we currently have a tall bay with a short bay up on top of it. If you grab this little triangle and start to stretch it, you'll still have a tall bay with a short bay. It's just that the short bay now is a little bit less short. It's a little taller. I'm going to keep stretching that and keep stretching it. And at some point, it will be tall enough that we can add a new tall bay. So what the curtain wall will do is it will add in another tall bay of the same size as the one at the bottom, and then the leftover just gets applied to the top. So it's similar to what we saw running laterally, but not exactly the same, because in the vertical direction, we're repeating a fixed distance, but in the horizontal direction, we're keeping the bays equally spaced. Okay. So now that we've seen some of the behaviors of this curtain wall, let's keep it selected and come over here and click Edit Type. Now, you can position this window on screen so that you can still see the curtain wall in the background. And what we're going to do is talk about some of these settings that are in here. Okay. So the first one I want to point out is this one called Automatically Embed. I'm going to show you that in just a few moments. Okay. So just make a mental note that that is a setting that's there and it's currently checked on. And you can certainly read the tooltip here, which explains how it behaves. Right beneath that is Curtain Panel. It's currently set to System Panel Glazed. Now, we can tell that that's the case because we can see right through the curtain wall. Well, notice that you can actually open this up and choose something else, like System Panel Solid. If I click Apply, notice that now all those panels are solid and we no longer can see through them. Okay? Right beneath that is Join Condition, and it says Vertical Grid is Continuous. Well, we talked about that already. Notice there's other choices, like Horizontal Grid Continuous. And if I click Apply, notice that it reversed the direction, and now the horizontal bays predominate over the vertical ones. If we scroll down a little bit, we've got vertical grid and horizontal grid. Well, we already saw the behavior of both of these interactively, but now you can hopefully start to understand why they behave the way they do. Notice that the vertical grid is using a maximum spacing of 5 feet. This accounts for why they were equally spaced, because every time it gets close to going over 5 feet, it just simply adds another bay and then redistributes all of the spacing. Contrast that to the horizontal grid, which is using a fixed distance of 8 feet or 2,400 millimeters and repeating that along the height of the curtain wall. As we scroll down a little further, you've got your mullion settings. Now, these are all using a simple rectangular mullion at the moment, but you can change any one of these conditions and choose a different mullion if you want to see the effect. So for example, there's a circular mullion here, and I'm going to choose that and click Apply. And notice that all of the vertical mullions now on the interior of the curtain wall have changed to this round shape. So the one thing that I did wrong here, or not following best practice, is I broke the rule about always duplicating the curtain wall first. So what I'm going to do is cancel, and then I'm going to come up to my undo drop down here and remove those 3 modifications that I made to get back to the original. If you want to do any of those changes more permanently, then select the curtain wall, edit type, duplicate it first, and then feel free to make whatever changes you'd like to make. So I'll let you explore that further on your own if you wish. Meanwhile, I'm going to go back to the level 1 floor plan, and I'm going to focus on the stairwell here at the top of the plan. And now I want to show you that automatically embed behavior that we pointed out in the edit type. So I'm going to go back to the wall tool and start creating another storefront. So notice it remembers all of the previous settings. I'm going to highlight the midpoint of this exterior wall, and I want to be able to see that dimension there. And if you're working in imperial, let's go with about 6 inches. If you're working in metric, let's go with about 150 millimeters, and then click right on top of the existing wall. Move to the right horizontally, and then type in 18 feet for imperial or 5,400 in metric, and it will create the curtain wall right on top of the existing wall and embed itself within it. So I'm going to click the Modify tool to cancel, and we can probably see this better if we switch to an elevation view. So let's expand building elevations, open up the north elevation, and zoom in. And now you can see this curtain wall very clearly is embedded right in the mass of the wall itself. So it's almost like the curtain wall is a giant window now. Now, we've already seen that we can adjust things like the height and so forth and reshape the curtain wall. You can do that right in the embedded curtain wall, and it will adjust the whole interactively. Well, what I didn't show you before is sometimes these numbers, when you drag it with the grips, are a little bit random. So what I actually prefer to do is to use my properties palette, and I'm going to set the top of this curtain wall up to the high roof, and then optionally apply a top offset if I want to customize it further. Now, when I do that, it looks pretty good over here, but on the left-hand side, it's a little too close to this roof eave. So you could use the top offset to drop the height down a little bit, but then that top bay is going to get a little narrow. So what I'm going to do instead is take advantage of a feature that all walls have, which is called Edit Profile. With Edit Profile, you can customize the shape of your wall's elevation to any shape you like. So I'm going to click Edit Profile. That puts me in a sketch mode. I'm going to open up my toolbox here and choose the Pick Lines. I'm going to couple that with an offset of 4 feet imperial or 1200 millimeters metric, and I'm going to offset a line down from the underside of the roof. Then go to Trim and Extend and trim this corner and this corner, click Finish, and that customizes the shape of the curtain wall, and it now looks a little bit better with respect to the roof. So there's plenty more that you can explore with curtain walls here in this file if you wish, and then when you're ready, you can move on. Sometimes you'll want to create a curtain wall where the layout of the grids and mullions is customized. So this isn't easily achieved in the Edit Type dialog, so I'm going to show you an alternative approach here in this video. So to do this, we're going to create a custom entry for the main part of the building here, and I've removed the door that used to be here, and we'll replace it with a curtain wall now. So let's go to the Wall tool, and it remembers that the last curtain wall that I used was storefront. I'm going to change that, and this time we're going to use one called Not Defined. Now, all Not Defined means is there's nothing set up in this curtain wall type. It's going to be just a big blank slate, and we'll be able to customize it to our liking. So I'm going to draw this directly on top of this exterior wall here. Okay, so you just want to put your mouse right on the center line of the wall. And I'm going to start about 1'6" away from the end there, or 450 millimeters. If you can't snap exactly to 450, you can do about 400. It doesn't matter. You just want to be offset a little bit from the end. And I want the length of this to be 15 feet in imperial or 4,500 millimeters metric, and you can just type that in and press enter. Now, when you do, it will generate a warning down here telling us that the highlighted walls overlap, but it's telling us that we can use cut geometry to solve the problem. So let's look at that now. I'm going to click the Modify tool to cancel. I'm going to click anywhere to dismiss that warning. So let's go to the Modify tab, and cut geometry is right here, and I'll click that. And what you do is you select the wall that you want to cut, so that's the brick wall, and then what you want to cut it with, and that's the curtain wall. And that will embed that curtain wall into that wall and solve the problem. Now, another thing I want to address while we're here in Plan is to select the curtain wall. It's got a little flip grip. Notice that the glass is favoring the inside right now. I'd like to flip that the other way so that the glass now favors the outside. So at this point, I want to switch views because I think it'll be a little bit easier to work with this curtain wall in maybe an elevation view. So let's scroll down here on the project browser, locate the south elevation, and double click that to open it up. And then let's zoom in on the curtain wall here. Now, you can see that it came in rather tall. So I'm going to tab in until I get just the curtain wall here and select it. And instead of a very tall, unconnected height, what I'm going to do instead is change it to up to level 2. And that will shorten it down to just underneath this canopy that we have in the front of the building here. And now I'm going to zoom in even closer so that we can begin customizing the layout of our design. So to do that, we go to Architecture, and we're going to use the Curtain Grid tool. Now, Curtain Grid is quite simple. You just put your mouse near the edge of the curtain wall, and you can add grid lines either horizontally or vertically. So let's add one on all 4 edges. And then I'm going to add 3 more in the middle. And I'll click the modify tool to cancel. Now, I place those kind of randomly because, like other places in Revit, we can simply come back and select them later and use the temporary dimension value here to modify the position. So make sure you're clicking right on the number and put in 2 in imperial or 600 in metric. I'll do it again at the top, 2 in imperial or 600 in metric. Now, you could continue with temporary dimensions, but I think sometimes it's a little easier to use a permanent dimension first. So let me show you that method. I'm going to come up here to the quick access toolbar, click the aligned dimension tool or DI, and let me dimension the location of each grid line. So I'm going to select each grid line here to add those as witness lines, and then also add the edges of the curtain wall on both left and right. I'll move down below the curtain wall here to place it in empty white space, and then let's click the modify tool to get out of there. So now that I have a dimension string, what you can do is select the grid line, and you will see a temporary dimension appear here, and you could use that if you want, but notice that the 2 numbers down on the permanent dimension have activated, and you can edit those as well. So that's what I prefer, and that's why I wanted to create the dimension string. So for the first distance from the left, I want to do 1'6" or 450 millimeters. And then the next bay over, I want to be 3 feet or 900 millimeters. Now here's a common mistake. You see the dimension, so you go right in there and edit it, and notice that that actually moved the same grid line, and it's changed the distance here. So I wanted this one 1'6" or 450. Let's leave it there. What we were supposed to do is change selection. So just try to remember that you need to change the selection before you edit the value. So keep going in that fashion, moving across the facade here until you have edited all of them like so. So just double check your distances to see if they match. Here's the dimensions right here. And now let's move on to customizing the curtain panels. So what I'd like to do is have a doorway right in the middle of this curtain wall. So your first instinct might be to just simply go to the door tool. And while that would work fine if you were placing a door in the brick wall, notice that if you try and move over here to the curtain wall, it won't allow you to do that. So curtain walls can't host doors directly. So what we need to do instead is use a custom curtain panel that you would choose on the properties palette that is configured like a door. So the first thing, though, is that none of my panels is correctly sized yet. I actually want my door to occupy the 4 panels in the middle here. So we can merge the panels together. Let's do that first, and then I'll show you how we can put a door there. So I'm going to select the grid line running right down the middle. And up here on the ribbon, we have an Add and Remove Segments tool. So I'll click that, and you just touch the segment that you either want to add or remove. So in that case, I've removed the one in the middle, and I now have a big wide bay in that location. If you want to reverse that, you can select the grid line, use Add and Remove Segments again, click the invisible segment, it will come back, and now you're back to having 2 bays. So that's how that tool works. So now that we understand that, let's go back to Add Remove Segments. Let's remove this one and this one. That merges both of those bays. Let's take this one here, add remove segments, and that gives us the final bay that we wanted for the doorway. Put your mouse near the edge, tab, continue to tab until it highlights that middle bay. Click to select it. And I've preloaded a curtain wall storefront door panel here. So you can choose that off the list, and it will put this custom curtain panel door in that location. Now, the way that I loaded that was simply to go to Insert, Load Autodesk Family, and searched for that family and loaded it in. So if you want to use this same door family in your own projects, it's simple to load. Now, if we look at it back in the floor plan, notice that it does have a door swing and it is categorized as a door. So it's going to behave like a door. It's just that the process of getting it into the curtain wall is a little more involved than just simply using the door tool. Okay. So in addition to changing the door panel, what I also want to do is the bottom base here, I want to use spandrel glass. So I'm going to highlight one of the edges and start to tab until I get one of those bottom panels. I'll right click it, go to select panels along the horizontal grid. I don't want the door to be included, so I'm going to hold the Shift key and remove that. And then with that selection, I will go to the Properties palette, the Type selector, and change from glazed to solid. Now, when you deselect it, it's going to be difficult to tell that we've made any kind of a change here. So let's change the shading mode in this view to make that a little bit easier to see. So there's a visual style pop-up here. And if you choose consistent colors, it'll do a pretty good job of showing you that the bottom bay is now set to spandrel glass. Okay, so those are the panels that we need. Now let's move on to mullions to kind of finish up this design. So let's go to architecture and click the mullion tool. It defaults to grid line, which means that if you touch the grid line, it'll add mullions all the way across. So let's do that above the door. Let's do it at the very top of the curtain wall. And let's do it for all of these verticals, including the one above the door there. And then finally, the horizontal one at the top of the spandrel glass. Don't do the bottom edge because we don't want mullions under the door. So what we're going to do there instead is use grid line segment. So you just change the selection mode here. And now you can place one mullion at a time in just the locations that need it. And then click modify when you're done to cancel out. So the last little finishing touch that I want to do here is the mullion joints can be toggled. And that can be a little nice detail to add sometimes. So go ahead and try that in a few locations just to add a little bit of interest to the design. Now, I did it selectively there, but if you prefer to toggle the mullion joints across the entire grid line, then it's a little quicker if you first right-click one of the mullions, select mullions on the grid line, and then you can use this button here on the ribbon to make them continuous all the way across, and that will toggle all of the joints for you. So I'm going to switch to the default 3D view now, the little birdhouse icon on the view control bar. Zoom in, hold the Shift key, orbit around so that we can get a better look at this, and kind of zoom right in. And you can, of course, see all the glasses nice and transparent. We can see our spandrel glass and our door. One last little finishing touch would be to change the level of detail in this view to fine. And notice that that will display hardware on our curtain wall door and actually on this other door off in the distance there beyond. So feel free to experiment further with this curtain wall, or if you like, try your hand at creating your own custom design off somewhere else on the facade. Sweeps and reveals offer powerful ways for us to customize the geometry of our walls. With a sweep, you are adding geometry to your wall, to the mass of the wall, and with the reveal, you're cutting away from the mass of the wall. Now, in both cases, you're going to use a profile family to determine the shape of the geometry that's going to be either added or removed from the wall. And then the wall itself essentially becomes the path of the sweep or reveal. Now, there are many different shapes included with the software. These are called profile families, and you can even make your own custom profile families if you need a custom shape. So in this example, I'm going to switch back to Revit and we're going to add some simple sweeps and reveals to our building design here. So what I'd like to start with is a brick soldier course along our brick walls here. Now, the first thing that you need to be aware of is remember that our brick walls are actually part of a stacked wall. So if you simply select the wall, it's going to say stacked wall here. That's not where we can add the sweep. What we need to do is tab in. Now that's going to go chain first. We don't want the chain. Tab in again, and then click, and it should now say basic wall exterior brick. If it doesn't, then you need to try again, because when you click edit type, you need to make sure you're looking at the type properties of the basic wall family, not the stacked wall. Okay, once you've done that, the next thing that you want to do here is go to the structure button and click edit. Now, down at the bottom of this window, it says modify vertical structure section preview only. So what this means is you must have the preview window turned on the left side, and it must be set to section. So notice that if I change the preview window to floor plan, it grays out all those buttons. And of course, if I turn off the preview, it also grays out those buttons. So make sure the preview is on, make sure it's set to section, and then that should light up sweeps and reveals. Now, we've got both sweeps and reveals, and we can add them either at the type level or we can add them wall by wall. So in this example, I'm doing a sweep at the type level, which means that it's going to apply to all instances of this wall, even though I only selected this one wall in the background, okay? That's a type-based sweep. We could do the same with reveals. Later, we're going to add a reveal instance-wise, wall by wall, but you could do both sweeps and reveals in the same way. Now, this sweep dialog that appears, I'm going to position it here so I can still see the preview in the background, and then I'm going to stretch it out a little wider so that the columns are more legible. And the first thing that you need to do is click the Add button here. So that's going to add your first sweep using the default profile. So let's click that drop down. And I've got some profiles already preloaded in this template file here. So when you scroll through the list, you can see there are several choices. And the one that I want is this brick soldier course, 3 bricks down toward the bottom there. Now let's click Apply. And this is the advantage of having the preview open so that we can see what that did. So notice that because it's a sweep, it's adding geometry to the wall, and it put it down at the base of the wall there. So the distance field allows you to determine where along the height of the wall you want this placed. If you're working in imperial, I want that to be at 6 foot 4 inches. If you're working in metric, I want that to be at 1950 millimeters. We're measuring that from the base, but the other option is top. So if you prefer to measure down from the top of the wall, you can. So let's click Apply, and you'll see that moves up to the new location. Now, we're going to skip orientation. The side is exterior. Well, since this is going to be a soldier course for brick, it makes sense to keep it on the exterior, but the other choice is, of course, interior, which is what we're not going to do here. Now, notice it's hanging off the wall, which might be appropriate, but I actually want this soldier course to embed in the wall a little bit. So we're going to use an offset value here, and I'm going to set it to the thickness of a typical brick. So I'm going to let it protrude just a little bit. So a brick in imperial units is about 3 5/8 inches. I'm just going to go with 3.5 inches here. And the equivalent in metric would be maybe about 85 millimeters. Okay. The trouble is, if you put in that number and you click Apply, it'll actually push it away from the wall. So make sure this number is negative and then try again, and that will embed it in. Okay. So the last thing that I want to look at right here is to assign a material to it. So if I click where it says by category here and I click this small browse button, that takes us to the material browser, and you can search up at the top for soldier, and it should find a soldier course material right here. Click OK, and then let's do OK again, one more time, and again, and now you should see that soldier course has been added not only to the wall that we have selected, but notice that it repeats all the way around the entire building. Now, notice that it's being interrupted by the windows there, and I don't really care for the way that that looks. So what I'm going to do is keep that wall selected, go right back to Edit Type, go back to Edit Structure, go back to Sweeps, and if you check this cuttable option right here and then OK out of all of this, that will rectify it. Okay. So I wanted you to see what it looked like when cuttable wasn't checked first before we enabled that. So that is a type-based sweep. Now that works great, except that unfortunately we have an instance of this wall up here, which doesn't really need to have that soldier course. So it's pretty simple to deal with this one. You simply select it, edit the type, duplicate it, give this a name like no soldier, click OK, edit it, go to sweeps, and you can remove the sweep and then OK all of that. That will only apply to that one instance of the wall. The remaining walls will still have the soldier course. Now let's look at a reveal and specifically an instance-based reveal. Now, if you want to add instance-based either sweeps or reveals, you do that on the wall drop-down menu. So here you could add a sweep, and here you could add a reveal. So since we've already done sweeps at the type level, I'm going to just do reveals here at the instance level. And to keep this simple, I'm going to accept the defaults. So if you want to change the shape of the reveal, you could choose edit type, you could duplicate, and you could pick a different profile. Okay, I'm going to accept the default one and simply go right to selecting a wall here. If I click modify and show you the result, notice that it has carved out that shape from the wall. Now, an interesting thing about instance-based sweeps and reveals is they can run either horizontally or vertically. So over here, there is a toggle switch to vertical, and I could make a vertical reveal like so. Now, if you want to create a second one, you can click the restart here, and then you can add another one. Restart, and you can add another one. So that's how you could stay in the command and add as many reveals as you like. So feel free to experiment further with both sweeps and reveals. I do want to point out that there was already a sweep in this file. If we look at this parapet wall that we used in an earlier video, notice that there is a concrete cap on the top of that wall. If you edit this type and edit its assembly, you will see that is actually a sweep. So you might want to explore that in a little more detail as well.
In this video, I want to address a topic that often gets discussed when we talk about building information modeling, and that is what is the appropriate level of detail at which we should model things. And there is no simple definitive answer to this question. There's even some potential controversy surrounding it. Different folks have different opinions on which things should be modeled, which things should be simply drawn or drafted in views. So my goal here is not to definitively answer this question and tell you the absolute truth of the matter. Rather, I want to raise some of the issues, have a little discussion, talk to you about what some of the considerations might be, and then give you potentially a few possible solutions you can choose in your own projects. So I've got a few examples queued up here for us to have this discussion. And I'm going to start with this 3D model here. I'm going to actually spin it around to this side of the building here and zoom in just a little bit. And in the last video, we did sweeps and reveals. And so you may recall that we were able to create these reveal elements that would carve into the surface of the wall geometry. So if I zoom in a little bit here and just kind of move my mouse so it's not highlighting the wall there, you can see that those reveals are definitely carving away from the brick and kind of creating a little architectural detail. I would consider that to be an appropriate use of the reveal tool, given the scale of that architectural detail. However, right next to this one and this one, there's this other item right here. I'm going to use my tab key to select it. That item right there, and it looks like a single bold line at this level of zoom. But in fact, if I select that, it turns out that that is yet another reveal. And the name of it kind of gives a clue as to what its function is. It is one called brick joint. Now I'm going to zoom in really close on that item, and it's really difficult to tell that is in fact a reveal even when you zoom in really close. You would probably need to turn on the thin lines and then zoom in significantly closer in order to begin to understand that is in fact a reveal. So my question to you is this an appropriate use of modeled geometry? You could argue that for control joints and expansion joints that they are literally gaps in the wall material, and so therefore we should model them as such. And so one school of thought is to use a reveal for this purpose. However, what I'm going to argue a little bit to the contrary here, particularly when thin lines is toggled off, which you know my thoughts on that, I prefer to leave thin lines off most of the time. We're not really getting the sense that is actually any kind of a reveal. And in fact, if anything, it might be giving us an inaccurate effect. And that might be easier to see in an elevation that I've prepared for this purpose. So what I'm going to do is come over here to elevations, and I've got one that I've called reveals, and we're just going to open that up. And then there is a zoom command that we haven't looked at previously that allows us to zoom the screen to match the scale of the view. So if you're working in the imperial file, we're in 1/4 inch equals a foot. If you're in the metric file, it's 1:50. And if you come over here to the navigation bar and look at the zoom flyout, there's a tool here called zoom sheet size. And the keyboard shortcut for that is ZS. So when you choose that command, and then be very careful not to roll your wheel, what you've got now is an on-screen rendition of what this view will look like to scale. And it's very accurate, especially when you consider today's high-resolution monitors. So if you look at this one here on the left and this one running horizontally, at this scale, there's enough detail where we can make out that architectural detail. We can see that that is a feature of the wall. However, if we look at that one to the right, you can see that in this view and at this scale, it really just looks like a big bold line. Okay, so it's actually the boldest thing on the elevation and taking on more prominence than maybe a control joint or an expansion joint really ought to have. Okay, so I would argue that in this case, it may be considered correct for the purposes of the 3D model, perhaps, or something like that, but it's really not serving us well in other views for our construction documents. And so I think a lot of times with building information modeling, that's exactly the challenge, is you're trying to balance the needs of different uses of your BIM, and you need to strike that balance and find out where that is. Again, it's not a one-size-fits-all answer for everyone. I'm just raising the issues here, and I want to share with you some possible solutions. So one possible solution is what I have right here. This is a drafting line. Okay, now you may have noticed that back here in the 3D, that line didn't show anywhere out here. It's not because it's hidden. That element is not hidden. It's because of the definition of what a detail line is. A detail line, or a drafting line as it's sometimes called, is a view-specific element, meaning that it only exists in this view in which I've created it. So I can create one by going to Annotate, choosing the Detail Line tool. You have a number of shapes over here. I'll just click Circle. Now, thin lines is the default, but you can choose any line style that you want. And I'll just sort of draw this thing anywhere, like maybe right here. Now I'm going to cancel out of there. I'm going to select it. And as I said, you can choose any line style you want. So I could make it medium. I could make it wide. Okay. And you'll see that it changes the rendition of that line. But if we go back to 3D, we don't see a circle there. So it's not, again, because it's hidden. It's because the nature of a detail line is that it only shows in the view that it's created. So that is certainly one option. You could use detail lines instead of reveals, and you could just draw where those control joints occur. But now that's sort of the extreme the other way, because now you're only representing the control and detail joints here in this elevation, but they won't appear anywhere else in your BIM. If that's all your goal is to be able to call them out in elevation, then that would solve the problem. So is there any other solution? Is it either model it with too much model detail or detail it with something that's not adequate to represent it in multiple views? No, there is another option, and that is using a model line. Okay, so a model line is kind of exactly what it sounds like. It is line work similar to the drafted line, except that it's considered part of the model. So let me demonstrate that to you. I'm going to go to Architecture, and I will click the Model Line tool right here. And you can already tell that it's a little different because now it's asking us for a work plane. Okay, so model lines must be drawn on a work plane because they are part of your model. So I'm going to accept this default pick a plane option that appears here, click OK, and then notice that I'm able to pick the surface of the wall. So I'm going to draw these right on the surface of this brick wall. Now, I'll just do a circle once again, just so you can see very clearly what this is, and then let's click modify. Now it came in this greenish color because it's using this style called lines, and let's just leave that for now, but I just want to show you the difference. Notice that here in 3D, I am seeing that green circle. Okay, so that's the difference between a model line versus a drafted line. The model line is part of your model. So what we could do is we could go to model lines, and then we could draw these lines right along the brick joints here, like so. And then once I've drawn one, I could copy it at whatever spacing I want the joints to have. And I just sort of did them randomly there. I ended up right in this window, so maybe move that over a little bit. But you get the idea here is you could draw these, and then they would be part of the model, they'd be part of the elevation. So it's a good kind of compromise solution, sort of somewhere in between, and it doesn't overpower the graphics of the view. Right now I've got it set to that green color, but if we change that to say medium lines or thin lines, notice the difference between this one set to medium lines and that reveal, okay? It's not suddenly the boldest thing on the elevation. It's got an appropriate level of weight to it so that it conveys what it needs to convey without overpowering the elevation. Okay. So I would suggest that there are situations like this where you might want to consider doing something like that, using a model line as a sort of compromise solution. And I'm going to point out to you two more examples of where this is frequently done. Here, I've got a couple families. Now, this one, I just sort of sketched it on the view just to show you the concept, but this is just a flush door. But sitting on top of it, I have added these model lines to represent a louver there. And the idea is that you could build a three-dimensional louver with all the louver blades and all the little details, but do you really need all that detail to convey that there's a louver in that door? I can't answer that for you. That's something that each person has to decide for their own project. But I would argue that in a lot of cases, what I've got here would be adequate. Now, what I would do differently is I would put that right inside the family. And we have an example right here. This is an out-of-the-box window family. And you'll notice that there are these muntin bars dividing the lights into 4 panes there. Those are, if you zoom in close enough, those are just simple model lines representing those muntin bars. Now, the way this family works is at coarse level of detail, you don't see them at all. At medium, you just see model lines. And then when you go to fine, it actually substitutes in full 3D geometry. So they're actually using all 3 techniques in this family to achieve the result they want, and it would depend on the scale and the level of detail which display you would use. But these are just simple model lines embedded in that family. So it's definitely something to consider. So the next time you find yourself in a situation where you're trying to decide, should I model it, should I not model it? Now, hopefully you have a better understanding of the issues and a few different potential solutions that you could use to achieve the result that you need.
In this video, I want to talk a little bit about the slanted wall property of walls. Now, slanted walls are not a special kind of wall. It's just a property of walls. So I've got this empty view here where we can do some sketching and just play around. And to do that, we're just going to go to the wall tool. So type WA or click the button. And if you scroll down here on the properties palette, we'll accept all the defaults except for the cross section. This is where we can make walls slanted. So there are 3 choices: vertical, slanted, and tapered. We're going to do slanted in this video. We'll consider tapered in another video. And that makes a property appear beneath the cross section called angle from vertical. And you can see that that can either be positive or negative. So put whatever angle you want in here. I'm going to use 10 degrees. And then you're ready to start drawing some slanted walls. So I'm just going to start anywhere and just draw out a little segment, maybe turn the corner, draw a couple more, and you can kind of see that it's doing some nice cleanup there. But let's zoom in a little closer to see that a little more clearly. Notice that there are actually 3 lines. So the 2 bold lines are where we're slicing through the wall, but then the wall slopes away from us down to the ground, okay? And so you're kind of seeing that sort of battered base down there at the bottom. Let's say you wanted to change something about this wall, like change the angle or something. Well, like any wall, you can't change the properties while you're in an active chain. So just press escape once. That breaks the chain, keeps you in the command, and allows you access to the properties palette where you can make changes like choosing a different angle. So I'm going to put in 20 degrees there. And now I want to start back up where I left off. And this can be a little tricky if you don't know the trick here. So I'm going to start right at this endpoint, which seems logical to me, and I'm going to pull this out and create it. But notice that it did a horrible job there with the cleanup. Well, we're going to come back and fix that a little bit later. There's a real easy solution, but let's just continue. If you continue and draw your next segment and your next segment, it should work just fine. Now, in some cases, depending on where you click, you might generate an error here. It's working pretty well for me right now, but I have had occasions where it says can't join the wall and it kind of breaks your chain. Just try again and pick up where you left off. Now I'm going to press escape one time here, and I want to show you the trick to connecting to this wall and getting it to join automatically. Instead of the endpoints or the midpoints or any of those, you're looking for this little dashed box. And it's a little counterintuitive because it doesn't seem to be in any kind of logical location. But if you click when that dash box is highlighted and then draw, it will do a nice clean joint. So let me click the modify tool to cancel out of there. And I'm going to zoom out a little bit. And those were several straight slanted walls. But if you go back to the wall tool, you can draw all of the different shapes. So we could do a circular slanted wall, or we could even do an elliptical slanted wall. Okay. And the result of both of those is they'll kind of be like truncated cones. Okay. And we'll see that in a few minutes when we go to 3D. You can do arcs. It works the same way as straight lines. You're just simply picking 2 points and then setting the radius. And in fact, it will even snap to tangents if you pay attention as you're drawing it there. So a variety of different shapes are possible. And other than the fact that it's slanted, it's going to behave a lot like the standard wall tool as you would expect. Now, what if you come in and draw other walls intersecting these? Well, I could leave these slanted, but that'll just complicate things a little bit. So what I'm going to do is switch back to a vertical cross section, and I'll zoom in over here. And again, this is where you need to know the trick. Like you might be tempted to try and snap to something here and expect it to join up, but it's not actually going to do that. And again, even if you did something like this, it's probably not going to work. So what you want to do is look for that dash box again. And if you click that, that's when it will properly join up with the existing wall. Okay. Now, if you draw all the way through, it should be no problem. And that is true with curved walls usually, but sometimes you can see that it's not going to respect that. And it really has to do with what angle it's at. Okay. So sometimes I'll get it to intersect and other times not. So now that I have some of these situations where it's intersecting properly and others where it's not, what can we do about that? Well, I'm going to zoom in over here and consider that first corner where we changed angle and we had a problem. The solution to this is trim and extend to corner. This is going to do a great job cleaning up this intersection. So I just simply select the first wall and the second wall, and it will create the mitered condition for me. Now, on that basis, you may be thinking that over here, we could do trim and extend single element, pick this wall, and then extend this, but that really doesn't seem to have any impact at all. Okay. I'm not really sure why that is, but the trim and extend T conditions don't really do anything, but trim and extend a corner works wonderfully. So my solution is a little bit of a workaround, but what you do is you take this one and you trim it to this one. Now that's going to generate a warning, can't join these. I'll unjoin the elements, but then I'll just work my way from left to right here and join it to each of the remaining walls. And when you do, you should eventually get to a nice clean intersection. I could do the same thing with this curve. Select the curve, select this, and then I could take the curve and extend it back to the other curve, and that will clean that up. Should even work with the ellipse, and you can clean that up. So in cases where you have these intersections that are not behaving properly, that's what you can start to do. If you needed this to go through, you can pull it back through again. And then this is where you get a little frustrated because you're like, well, now what? It's still not cleaning up. Well, in cases like that, I split the wall. So I'm going to split it at a point, and I'm going to go to trim and extend and start with this one and trim it to here. Then I'm going to take this one and also trim it to there. Then finally, I'll take this one and trim it to there. And you've got a split now between this wall and this wall, but you've got a proper intersection. Now, I'm sure you're anxious to see what this looks like in 3D. So let me go up here to the default 3D view, and we can start to spin this around and see what it's looking like here in the 3D view. Don't let this trouble you here. That's just the crop box of my view is truncating the shape, but I could just extend that like so. Okay. So that is a little bit about just sketching the basic slanted walls. Now, if you want to understand this a little bit more scientifically, I've got a couple other views in here to help out with that. So let's go to this floor plan called 02 Angles and Dimensions. It's a little cluttered because it's got an underlay to the floor below showing. So let's scroll down to the underlay properties here and set it to none. And then if you zoom in, these grids are telling you the angles of each of these walls just for your reference. And then of course, I've got some dimensions here. Now the dimensions between the grids are consistent at 10 feet or 3,000 millimeters, but as you can see, the distances between the walls vary. I've got a section cut running through here as well, and I'm going to open that up. And it's just trigonometry. If you take a measurement of the wall itself, so I'm going to tab to that face and that face, there's the thickness of the wall. So this wall in the imperial file is a generic 8-inch wall, and its thickness is 8 inches parallel to the wall. That means if we measure it parallel to the ground instead, there's a really thin little triangle there, and naturally the distance you measure there is going to vary because of the nature of triangles. And then the more acute the angle, the more dramatic that difference will be. Now, to help you visualize that, I've created a reference plane over here to kind of mark where the cut plane is. And so that helps you hopefully start to visualize what's going on there when you have these slanted walls. So feel free to experiment further in this file, or if you want a fun exercise to learn more about slanted walls, you can check out a video I did in my weekly tips series. So this is back from March 2022, and I did this little futuristic sci-fi example here where I'm using both slanted and tapered walls and showing you some of the features of them. In addition to that, I've got a couple other videos in the series that talk about using formulas and calculations for slanted walls. And so you can check out any of those if you're interested in this feature. In this video, I want to explore the tapered walls feature. So there are 3 different cross-section possibilities for walls. I'm going to select this wall number 1 over here. And we've obviously seen plenty of examples of vertical walls. That's your default. In the previous video, we looked at slanted walls where you could choose slanted and type in an angle. In this video, I want to talk about tapered walls. Now, if I select wall number 1 here and click tapered, it will fail. And it says this wall's type is not compatible with tapered cross-section. So that's the first little gotcha with tapered walls. They are definitely more complicated than either slanted or vertical. So let's move over to this wall, wall number 2 here, and let's talk about how to set this wall up to be tapered. Now, this is just the standard exterior brick on metal stud wall. I'm going to click Edit Type because the error message said that our type wasn't compatible. And then I'm going to go to Edit Structure. And to make this compatible, you need to make one of the layers of this wall variable. So notice over here on the right-hand side, you have this variable column. You can simply check one of the layers to make it variable. Now, you're only able to check one layer. So if you check one and then another, it'll uncheck the first one. And I think the layer that makes sense to be variable in this case is the air layer. Okay, so the air gap between in the middle of the wall is what I'm going to make the variable layer. I'll click OK. I'll click OK again. And now we're going to come over here to the properties palette, and it should allow me to set it to a tapered wall. But nothing really very exciting happens when I do that. So in addition to enabling it to be tapered, you still need to establish what you want the tapering to be. And that actually starts in the type dialog as well. So I'm going to go back to Edit Type. And now that I have enabled a variable layer, that will make these cross-section definition properties available here. And I have an exterior angle, an interior angle, and the width measured at property. So let's put in 5 degrees for the exterior angle and click OK. And then finally, we will be seeing some results here with this wall. And notice that it kind of kicks the bottom edge out at 5 degrees. Now, you could choose just about any angle you want in the positive direction here. So I'm going to try 15 degrees, and that will kick it out further. If you try to go in the negative direction, This is where you will run into some challenges if you don't understand what's happening. So when I try to do -5 degrees, it says it would cause a degenerate or intersect. And so, in other words, it doesn't work mathematically. Now, why is that exactly? Well, let's keep the wall selected. Let's go to Edit Type. And currently, the thermal air layer is only 3 inches wide in the imperial file and 76 millimeters in the metric file. So it's very slight, which means that it only allows for a small amount of variance. And the reason for that is because this width measured at parameter now comes into play. So this can be one of 3 settings: top, base, and bottom. If you wanted to change this to base or bottom, it might impact the wall and change the way it behaves, but I suspect we would still have very few angles that would work here. In fact, the only real angle that's going to work here in the negative direction is -1. If I click that, you can start to see why. Here is measured at top, the 3 inches or 76 millimeters. But down here at the bottom, notice that that air gap is now down to a very slight distance, which is almost 0. When it goes past 0, that's when it fails. So really, with this air gap only being that small, you really can't taper any further than 1 degree in the negative direction. So that's where this wall comes in. What did I do here? Well, if I click Edit Type, I have just increased the size of the air gap. So now if you wanted to try a negative value of, say, -5 inches on this wall, it should work just fine. Now, again, this one will fail eventually. If you go to, say, -10, maybe -15, something like that, you will start to close in that spacing there. So really, it just comes down to math at this point. You need to know how big your variable layer is and make sure that your angle doesn't exceed that so that you don't create a situation where it fails. Now, another really interesting feature that tapered walls have is that if you want, you can override the taper angles on a per wall basis. So what I'm going to do is make a couple copies of this wall, and I'll select this first copy, come over here to the cross-section definition, and notice the Enable Angle Overrides feature. I can check that, and now I could put in a custom angle for the exterior angle, and even though the type says use -5, this wall is using +5. And I could do it again with this one, and let's put in -10, which should still work. Nope, that's too far, so let's try maybe something like -8. There we go. Okay, that works. And so now each one of these walls has their own unique settings for the angle parameters. This one is still using the settings of the type itself. So if I select any one of these instances, it doesn't matter which one, and I go back to Edit Type, if you change the angle here, so let me change this back to 5 degrees and click OK. Notice that the one on the left and the one on the right will not comply. They're going to stay with their custom angles, but the one in the middle did change. However, if you go to Edit Type, Edit Structure, and you change the size of the thermal layer, so let's go with 3 feet imperial or 900 millimeters metric, that will apply to all 3 instances. So the only setting that's being overridden here is the angles. Everything else is still being driven by the type, which I think is pretty powerful and pretty useful. So there's certainly plenty more that you could do in this file to experiment and kind of get comfortable with how the tapered walls behave. But I want to offer you one other example. Here in the background, I have the sample architectural model that comes with Revit open. Now, we've opened this model before, so you should know how to get to it. What I want to show you is that there are both tapered and slanted walls in this model. So if you want to see an example that's maybe a little bit more practical, then this could be a good place to look. Now, what I'm going to do is zoom in on these bays down here on the lower left-hand side, and these bays are pointing due south, and they've got sloping walls because there are solar panels mounted on them. So those sloping walls help the angle of the wall get closer to the sun angle. I'm going to cut a section right through this window here, running perpendicular, and it's going to go all the way back here. I'm just going to pull it back so that we're only looking at this bay. Now, you may be wondering why I didn't just open this section. This section has some display overrides on it that I didn't want to deal with. So I'm going to create a custom section so that we can open it up and do whatever we want graphically here. Now I'm going to zoom in here, and what you're going to see is that this is the tapered wall. Now, I'm going to get some of this other geometry out of the way, like the structural model here. I'm just going to go to the sunglasses and hide that element. And then I'm going to come over here to the detail level pop-up and choose medium and show you that the wall assembly here looks essentially like the one that we were just working with. And you can click on it and you can edit its type and you can understand the same set of properties. But notice that the air gap is set to variable and it's got an angle assigned to that. Sitting on top of that is a curtain wall that follows the slope. So if you first hover over it, it's going to say model group, press tab, and you should be able to reach right in and grab the curtain wall called solar panels. And if you scroll down, you will see that its cross-section is set to slanted and the angle matches the tapered wall underneath. So here's a really good example of both a slanted wall and a tapered wall. And if you want to play around further with them, hopefully that will give you a little bit more comfort level with both of those tools. If you are using either slanted or tapered walls, then there's going to be some additional parameters and considerations for your windows and your doors and your sweeps. And so in this video, I'd like to look at some of those issues. So this, in some ways, will tie together lots of the topics that we've been talking about in many of the previous videos. So I'm going to zoom in here and select this wall on the exterior of the small building. And I want to make that a slanted wall. So I'm going to scroll down here on the properties palette, and the cross-section parameter I will change to slanted, and then I'll give it an angle of maybe 5 degrees, and let's apply that. And you can see that a positive angle typically will tilt it in toward the building. And if you want to tip away from the building, you can use a negative angle. And when I do, that's going to generate a warning here. Now, no reason to panic. It's not that big of a deal, but let's go ahead and expand the warning and see what it is. It's talking about the roof and the wall, and we could either unjoin the elements or click OK and ignore the warning. So the idea is really quite simple. When you tip this wall away from the building, you're going to have a gap between the roof and the wall. And so even though they're joined, they're not touching. You can unjoin them, or you can just click OK and ignore that and worry about it later. If you're going to go back later and edit the roof and fix that problem, then you might want to leave them joined. So that's why I'm clicking OK there. So now I want to talk about the first issue, which is inserts. And in this case, I've got windows here, but the same would apply with doors. When you have inserts in a slanted wall, you will now have a parameter on the properties palette called orientation, and you can choose between vertical or slanted. So if I choose slanted here, notice that the windows will now match the orientation of the wall, which looks a lot nicer here in this 3D view. But if I open up this section view that I have right here, and let me zoom in, you may or may not be satisfied with the orientation of that sill and head any longer. So I'm going to right click and choose select previous. And unfortunately, you just have the two choices. So if it's slanted, it follows the slope of the surface, but the head and sill are also going to be slanted. If it's vertical, the head and sill are parallel and oriented to the ground, but now you're going to see the wall is kind of poking into the interior of the space. So you're going to have to choose the one that you dislike the least, I suppose. If you wanted to customize that behavior in any way, that would, of course, involve selecting the family and editing it in the family editor. And that, I'm afraid, is a little out of the scope of what we're going to discuss right here. But that is, I suppose, a third option. Now, let me move up toward the top of this section cut. And this is where that error was generated a moment ago, by the way. So now you can see it more clearly that the roof used to touch the wall, and when we sloped away, there's now that gap there. So to fix that, you could select this roof, go to Edit Footprint, and edit the sketch so that it now touches the wall. I'll let you do that on your own. But meanwhile, I want to talk about what's going on here at the top of this wall. You can see it looks a little strange. Now, to really understand that, toggle thin lines, and now it should be pretty evident what the problem is. What we've actually got there is that parapet cap is a sweep, and that sweep is following the angle of the wall, but notice that the wall itself is being truncated parallel to the level. So it's a little interesting that we're getting those two different behaviors there, but that is what we're dealing with. So how do we fix that? Well, I'm going to zoom back out a little bit and select the wall. and sweeps happen in the type, right? So I'm going to go to edit type, but notice that this is a stacked wall. So you can't get to the sweep properties from the stacked walls type. So you need to cancel this. And what we're going to do instead is get to the basic wall type that's inside the stacked wall. Well, it turns out you can get there just by hovering over the stacked wall, pressing tab. That's going to do a chain of walls. Press tab again. And now you're reaching right into the stacked wall and selecting the basic wall that's inside, the parapet wall in this case. And now if we go to edit type, you'll be able to edit structure and we have access to the sweeps button. Now, if you watch the video on sweeps, you know that the only way this button is lit up is if you have the preview open, which I do, and if you have the view set to section, which I do. So make sure both of those things before you get to the sweeps button, and then you click that. And finally, we have our orientation parameter here, which we can change to parallel to the ground. Now we have to click OK, OK, OK. So we're pretty deep in there, several dialogues, but eventually you get back and now you can see that it looks much better here in the section view. However, if we go back to 3D, I'm not really satisfied with the connection between these two walls here and here. What I'd really like it to do is to look like that, where it does a nice mitered condition. Now, how are we going to achieve that? Well, first, let me explain to you why this is occurring. So if you select this wall, you should be able to tab in and get to just the sweep that's inside of that wall. So it's going to take a couple tabs, and then there's a little dot right here. And it turns out that you can actually drag that dot to pull that sweep back from that intersection. I'm going to repeat that over here by tabbing and clicking that little dot and pulling that away. And then if I deselect everything, now you can kind of see what the problem is. For whatever reason, the plane at the top of this wall is a little bit lower than the one at this wall. Now, to my mind, the easiest solution is the align tool, right? So I'm going to go to align and I'm going to highlight this face and press tab to get the top face, click it, and then I'm going to click this one and nothing happens. So we're running into, again, another issue with respect to this being a stacked wall. So at this point, you may be thinking, why bother with these stacked walls, right? And it's a fair comment. But in this case, I'm afraid the solution is going to be to remove the stacked wall. Now, if you're not sure how to do that, let me remind you that you can select a stacked wall, right-click, and choose Break Up. And when you do, let's press Escape a few times to deselect. When you do, you now have two separate basic walls sitting on top of each other. Okay, so it's no longer a stacked wall, and that also means that you should be able to go to Align, tab into this top surface, and then pick this top surface, and now those two surfaces are flush with one another, and I can go back and tab in a few times and get this sweep here, stretch this to that corner right there, then I'll tab in a few times to this one, and grab that one, and snap it to the same location, and that will clean up the miter nicely. Unfortunately, though, we need to do it at both ends. So I'm going to tab in again, but at least in this case, we only need to adjust the grips here because it's already flush. So I'll just tab in a few times to get those grips, and then that completes that. So those are some of the issues you might run into when using slanted walls with respect to doors, windows, and sweeps. Let's spin around to the other side here and talk about a similar condition that will occur if you're using a tapered wall. Now, the first thing you want to know is that stacked walls don't support tapered walls. So if I scroll down and try and change the cross-section here to tapered, it will tell me that it's not allowed for stacked walls. Okay, fine. So let's right-click and break up again. And then I'll select the one at the bottom here. And I want to set that one to tapered. But you might recall from the earlier video on tapered walls that you first need to go to Edit Type, edit the structure, and decide which layer you want to be variable. So I'm going to make the air gap layer variable, click OK. Then you decide what angle you want it to be. I'll do 5 degrees on the exterior, click OK. And finally, with that wall selected, I will change its cross-section to tapered, and that will kick it out. And the only thing I wanted you to see that's a little different here is if I select these windows and scroll up, notice that the vertical cross-section here now has two options. It can either be slant along interior or slant along exterior. but otherwise it will behave in a similar way that we saw with slanted walls. So if you're using either slanted or tapered walls, these are some things you might run into with respect to the other geometry that participates with those walls. Feel free to experiment further here to get a better sense for how all this functions.
The subject of the videos in this chapter is visibility and graphic control, and this video is devoted to a high-level overview of that topic. When contemplating visibility and graphic controls, folks often jump to commands like visibility graphics or hide in view. And this is because often what Revit displays by default in each view is suitable most of the time, and we therefore don't think about it until something is not to our liking. But if you really want to understand what is happening behind the scenes, you cannot start with visibility graphics or any of the other similar tools. This is because the first question you need to address is what, not how. Visibility graphics changes how elements will display in a view, but before its effects kick in, we need to determine what will display in the view. So how do we do that? Don't start with the visibility tools. Instead, start with the view's extents. Consider standard drawing types like plans, sections, and elevations. How does Revit generate these views? Well, it starts with a cut of the model. In elevation, this would be a vertical cut, usually outside of the building and facing toward the model. For a section, it would be similar, except that this time the cut slices through the model, thereby excluding elements that fall behind the cut. The most dramatic example is a plan. Here, the cut is horizontally oriented, showing only a thin slice of the model. Now consider any element category after such a slice. For example, the model overall may contain many more windows than what we end up showing in that floor plan slice. Therefore, if you seek to control the display of an element using customizations like visibility graphics, it may prove wasted effort if the element in question is outside the view extents and therefore not eligible to display in the first place. The specifics of controlling the view extents will vary slightly by view type. Elevations and sections are easily manipulated with on-screen controls, for example, but plans require a little bit more effort using the view range dialog. But once you're certain that the extents are correct for your view's purpose, you can move on to any required visibility and graphical customization. To do that, you can use several options, and here's a short list. Keep in mind that the effects listed here are progressive. So, let's take a look at each one of these. Everything begins with object styles. They set the overall default display characteristics for each category in your project and apply to all views that have not been overridden. So this is a global effect, and it's usually determined by some office standards. Now you can override the effects of object styles in several ways, starting with visibility graphics. Visibility graphics are still category-wide, but they apply only to the view in which they are applied. Now next comes filters. These are limited to a selection of elements determined by user-defined rules. This makes filters very powerful and flexible. And because the selection is rule-based, they continue to apply as long as the conditions that triggered them remain valid. Finally, overrides can be applied manually to individual elements. Preferably, this should only be done on rare occasions and when absolutely necessary. Now, I've also included temporary hide isolate here in the chart as well, but naturally, the most significant difference is that the effects are temporary and they do not persist with the model. So with this general overview in mind, the remainder of the videos in this chapter will move systematically through each of these topics.
In this video, we're going to look at view extents and cropping. So I've got a few different examples to share with you, and I'm going to start with a site plan here. So I'm actually in the site plan sheet, and you can see that I've got a site plan view placed on this title block. and it's too big for the title block. You can see it's kind of going off the edges in all directions. Now, if we zoom out, it actually goes farther than it looks. So the full size of the viewport is way out here, and we're really only interested in the portion in the middle that looks at the building geometry and at the building site. So what can we do about that? Well, let's double click inside the viewport, and that will activate the viewport. And now you can see that you're actually able to select the model geometry. So you could work on the model as normal here, and the viewport is just grayed out in the background for reference. So what we're going to do now is turn on the cropping behavior of this view, and we have two ways to do that. The first is on the properties palette. So if I scroll down here and we're looking for the extents grouping, there are two checkboxes of interest: crop view and crop region visible. You can check crop view in order to enable the cropping of the view. And when you apply it, you're going to see a large majority of the view will disappear, and we're cropped in much closer to a smaller rectangle shape around the building there. Now, the other way that we could enable cropping is using this icon down here on the view control bar. You can see that that toggles that checkbox on and off as you choose it or not. Right next to that is a show crop region icon, and that one will enable the visibility of the crop rectangle or the crop boundary. And you can see that's the same as checking or unchecking this box here on properties. So let's make sure that both of these boxes are checked, or that you've toggled both of these switches. And I'm going to zoom in just a little bit here. And as you can see, there was already a crop boundary configured for this view, which is a much closer crop than what we were looking at a moment ago. Now, it might be such that you want to adjust this now. So to adjust a crop boundary, you simply select it, and there are these small grip controls on each of the sides, and you can use those to manipulate the size of this cropping. So there is a dashed boundary line marking the property line, and I want to make sure that I'm seeing the entire property line in this site plan. So I'm going to stretch the grip controls in each direction large enough that I can see that complete property line. And there, that looks pretty good. Okay. So when I'm satisfied with the shape of the cropping, then I can just simply click away from it. If you want to see the crop region, you can leave it turned on, or you can hide it again. And then if you double click outside the viewport, notice that the viewport has now resized to fall within the sheet, and it no longer goes off the sheet. And so this sheet will print more correctly now. So that's our first example of working with a crop region, okay, and a practical reason for doing so. So next, let's open up the L1 architectural floor plan. And here you can see that the crop region is already turned on. So this rectangle out around the outermost edge here, that is the crop rectangle. And when I select it, notice that it does not have the little grip controls on any of the sides there. Now, I'm going to open up two other views. The south elevation, it also has the crop rectangle turned on, and it also does not have the little dots at the sides. And then finally, let's open up the longitudinal building section right here. Now, it also has the crop rectangle turned on, but it does have the little dots. So what's the difference? Well, let's tile these views first of all, so that we can see them all on screen simultaneously. So let's go to the View tab here. We're going to choose Tile Views, and then I want to zoom everything to fit. So you can use the View control bar and choose Zoom All to Fit, or you can simply type the keyboard shortcut ZA, and that will make each of the views fit their respective screens. So the floor plan and the elevation are configured the same way. The section is more like the site plan. So what do I mean by that? Well, I'm going to double click over into the viewport of the site plan again and zoom in a little bit closer. Notice the presence of this dashed green box and this dashed green box. Now, this one out here is labeled Views Overall. That is something called a scope box. And if you think back to one of our earliest videos where we first created the project from a template, the template that we used to create this project from included these two scope boxes. What is a scope box? Well, one of its jobs is to help you control the extents of your various views. So we're now going to see a direct example of that. If you select the scope box, you get these small triangle controls. I'm going to click this one here toward the east side of the building, and I'm going to drag it down to about the middle of the building and let go. Notice that both the south elevation and the floor plan have adjusted as well. So both of those views are using the scope box to size their crop regions. The section was unaffected. So if we click into either of those other views, architectural floor plan, and look at its properties, scroll down, you will notice that the orientation says by scope box, and then a little bit further down, you will see the scope box property in the extents area, and it is set to views overall. If you look in the longitudinal section and look under its extents, you will see that the scope box is set to none. And that is why the longitudinal section has these little grip controls, and that means that you could crop it independently. So what I'm going to do is, using the undo dropdown here, I'm going to reverse some of those changes so that I've gone back to the full-size scope box. I didn't want to actually crop those views, but I wanted you to see the difference in behavior. So the main advantage of a scope box is that with a single object, you can control the extents of multiple views. And in this project, all of the elevations and many of the floor plans are assigned to that single scope box. So by manipulating that one object, you have control over all of those other elements. So that's pretty powerful. Okay, so now what I want to do is take the architectural plan and make that the active view. I'm going to tab the views. That's going to remove all the tiles. The other views are still here. Now I'm going to choose Close Inactive Views, and the inactive tiles disappear. I'm going to zoom in on the stairwell and open up this section cutting through the stair. And I'll do that by double-clicking the blue section head, and then finally I will tile the views. So now we just have the section on one side and we have the floor plan on the other. Go ahead and select the section marker in the floor plan and notice what selects as well on the section side. The crop region of the section highlights when you pick the section indicator in the floor plan. Those two are the same thing. Now, there are little grips and controls in both views. So the little dots on the four sides of the crop region in the section allow us to control either the width running laterally or the height running vertically of this section. And we've seen this behavior. We could stretch it, we could stretch it, and it would adjust the cropping of that view. I'm going to undo and undo. Likewise, you've got these controls here, which do essentially the same thing to the width. Let me undo that. But in addition to that, we also have this one, which controls the depth. So when we talk about view extents, it's not just the 2D extents that you're seeing in the view, it's actually a three-dimensional extent. So if I take this grip and I stretch it back to just inside of this glass wall here, notice that all those mullions and glass panels disappear in the section view. If you pull it back even further to about halfway on the stair, notice that the columns and the opening in the wall disappear. In fact, if you want to go even further, part of the stair will start to disappear. So depending on how deep you make that section, it will display more or less geometry back in the respective view. So when we talk about view extents, we really are talking about three-dimensional extents. Now, this is true for elevations, plans, and sections. Now, to understand it in plans is going to require a command called view range, and we're going to talk about that in a future video. But it's a little easier to understand here with the section. So now what I want to do is just show you how we can customize the cropping of the view. It doesn't have to be rectangular. So let's do a quick example of customizing this section. So in the section view, I'm going to make sure the rectangle is selected, and then I can click Edit Crop. That will temporarily disable the crop. And now using any of the sketch tools, you can modify the shape. So I'm going to align this edge, then the floor and this edge, the inside wall here and this edge, and then finally the slope of the roof and that edge. Then I will go back to the modify tool, pick lines, pick this diagonal edge here, and then finally use trim and extend to clean that up. When I click finish, I now have a custom shaped crop region for this section view. So it doesn't have to remain a rectangle. And in fact, one last example, if you want to build a custom shaped crop as you're creating a view, that is also an option. So here in the floor plan, I'm going to go to this callout tool. And instead of drawing it as a rectangular callout, I'm going to sketch it. And now I simply click and draw the shape that I want. And this can be any custom shape that you like. And so I'm simply going to draw around the lobby and the corridor area there, click finish, and then that creates this call out. I'll move the symbol over here, select it, right click, choose go to view, and you can see that the crop region of this new view matches that custom shape. So those are some very common examples of working with view extents and cropping. And it is one of the very first things you want to consider before moving into any of the other topics that we're going to discuss here in this chapter about visibility.
This video is going to be part one of a two-part look at the view range dialog. View range is how we control what we see in floor plan views. So it works for both floor plans and reflected ceiling plans. And one of the primary things that view range does is determine where we're slicing through our model in order to generate the floor plan graphics. So that's what we're going to be focused on mostly here in this video. And then we'll look at some additional settings of the view range in the next one. So first, let's just talk about conceptually what we are going to be discussing here. If you consider a floor plan, the way a floor plan is generated is by taking the model and slicing through it at some location. Now, this is a pretty standard height that this occurs at, but you could really do this at any height that you like. And then whatever geometry is being sliced through at that level, that determines how to draw those elements in the plan view. So for example, if we consider things that are outside of the slice, like the sills of these windows here, you can see that they're rendered a little bit lighter than the walls themselves, which are being sliced through. So all of this is being determined simply by that cut height in the view range. So let's switch back over to Revit here and figure out where we can manipulate that. So I've got a really simple example queued up here for us to discuss this concept. I'm going to zoom in on this conference room here on the second floor plan. And there are these three windows over here on the right-hand side, but above them, there are some clerestory windows that are a slightly different shape. And perhaps I'd like to see those clerestory windows shown in this plan instead. Well, in order to do that, I would need to adjust the view range. Now, to help us visualize what we're trying to do here, I've created another view in this file. So I'm going to scroll down here, and under the elevations branch, there is this understanding view range elevation view. And you can see here that we're looking at that east wall of the conference room. You can see the larger windows down below. Those are the ones we're currently cutting through with this red line right here. And what we want to do is actually cut through these clerestory windows at this taller height, and that is going to be 12 feet if you're working in imperial or 3,600 millimeters in metric. So now that we understand what we're trying to do, I can close that elevation view, and let's go ahead and look for the way to achieve that. So one way to achieve it is to work directly here in this floor plan and look at its properties over here on the properties palette. So I'm going to scroll down, and we're looking for the view range setting. So it is down here underneath the extents grouping. You can see view range right there, and there's an edit button next to that. When you click that, it will display the view range dialog, and there's this little show button down here in the corner that will allow you to expand it open, and there's a little diagram that appears on the left-hand side. That diagram is annotated, and you can see the key on the far left and each of the items illustrated in the little diagram. So we're going to focus on item 2 there, which is the cut plane. And you can see over on the far right that the cut plane is currently set at an offset of 4 feet above the level in the imperial file. It's 1200 millimeters in the metric file. So all we need to do is change this value. So I said we wanted to use a value of 12 in imperial or 3600 in metric. Now, the trouble is, if you try to apply this, you'll get a warning that says that the top clip plane is now below the cut plane. So another thing you need to understand about view range is there's 4 values here. They can't get out of order. So that means the item for top needs to be the biggest number and the item for view depth needs to be the smallest, and the others need to fit in between. Now, the 2 numbers can be the same. They just can't switch places. So that means that for top, we could also put in 12, and that will allow us to continue. So you could put in anything 12 or greater, and you should be fine there. Now, we'll talk about top and bottom and view depth in that next video, but for now, we're just going to set them both to 12 here, and we'll click OK. And we have succeeded in getting our clerestory windows to display, as you can see. However, I wouldn't call the rest of the result in the floor plan a success. You can see several things have changed, which are not desirable. We are now slicing through the roof, both over here and over here. We're now seeing lighting fixtures in our floor plan. We are cutting above the doorways here and here and these 2 walls. We're not seeing anything in the conference room. So clearly this cut plane is much too tall for most of the geometry in this view. So what I'm going to do is use my undo drop down here, and I'm going to back up 2 steps there to get back to where we started from. And what I want to do is show you an alternative way that we could approach this. So rather than changing the view range of the entire floor plan, we can limit the effect to just a small area. And we do that by going to the View tab, Plan Views dropdown, and using a plan region. So a plan region is just a sketch-based zone that you will set a different view range in. So I'm going to go to plan region. You can use any of the shapes that are shown here. I'll just do a simple rectangle, and then I will sketch out the rectangle around the area where the windows are. I'll click the Finish button to complete that. Keep it selected, and then over here on the Properties palette, you will now see an Edit button next to View Range. It's the exact same view range that we were just looking at. I'll set both of these values to either 12 or 3600, and then click OK. And now you'll see that the clerestory windows are displaying within that little zone only, and the rest of the plan is unaffected. So hopefully that quick example gives you some idea of how the cut plane in the view range functions, both globally across the entire floor plan or in a isolated region should you need to do so. Now, we are going to talk more about view range in the next video, as I mentioned, but in the meantime, if you're looking for some resources to help you learn more about view range, I've written an article here on LinkedIn that you can check out. If you're wondering why a pizza box, well, that's because in my mind, if you visualize a pizza box, it's about the same size and proportion and shape as your typical view range. And so it's a good way of visualizing what's actually happening in your model. But you can go ahead and read the article to learn more.
In this video, we're going to continue our look at view range and consider some of the other settings in the view range dialog. So I'm going to start right here in this little break room, and let me just zoom in a touch on that. And I'm going to go to the component tool, and there are some upper cabinets loaded in this file. So I'm just going to start typing the word cabinet, and that should find a few items, and you'll see an upper cabinet right here. Now, it doesn't really matter what size you choose, but just go ahead and pick one of the sizes and add a couple of those on the wall there to the right. I'm going to select one of those cabinets that I just placed, and I want to direct your attention to this property, elevation from level. Now, here in my Imperial file, that is at 5'6". Now, in metric, it's probably closer to 1700 millimeters. So if you think back to the video on view range cut plane, the last video, the cut plane was at 4 feet or 1200 millimeters. So clearly these pieces of cabinetry are above the cut plane. So that begs the question, why are they still displaying here in floor plan. Now, the fact is, I don't mind that they're displaying because usually we would want upper cabinetry to display, but I want to talk about why so that you can understand how these things behave. So to help us with that, I've got a section cut right here going through the break room, and I'm just going to double click that blue section head to open it up. And then I'm going to go to the view tab here, tile the views side by side, and then I'll zoom in here on the left-hand side of the section on this side, and of course, focus on the break room on the right-hand side. So I still have the cabinet selected, and I've superimposed this line work on here to kind of remind us of the settings in the view range. Now, if you want to see those yourself, you can click over here to the floor plan, scroll down and locate the view range dialog, or you can type VR. Make sure you deselect the cabinet first. And then there's view range, or you can type VR, and these settings match what I've illustrated over here. So remember that the cut plane is where we're slicing through the plan and we're seeing all the geometry below that point. Well, the cabinets are clearly above that point. So again, the question remains, why are they displaying? Well, I'm going to expand this show button here, and you'll see that there's this illustration, and I mentioned this last time. And this illustration also shows a few items in the zone between item 2 and item 1. So anything that occurs between the primary cut plane and the top must adhere to certain rules, certain criteria before it will display. So I'm going to cancel out of there. And the cabinets are adhering to those criteria. So let's look at another object that does not meet those criteria, like this doorway. I'm going to select that door, and I'm going to scroll up on the properties palette, and it has a sill height. And let's set the sill height of that to 5 feet imperial or 1,500 millimeters metric. Now, clearly the door still exists. It didn't get deleted. We can still see it here in section just fine. But notice that in the floor plan, it has disappeared. Okay? So the door clearly does not meet the same criteria that the cabinets do. So you may be thinking, well, it's just because the door is above the top of the cut plane. The cabinets aren't doing that. Well, let's test that theory out. So I'm going to select one of these cabinets, and I will increase the elevation here to, let's try adding about a foot or 300 millimeters. So I'm going to go to 6'6" in imperial, or you can just add 300 millimeters to whatever it is in metric. So now this piece of casework is doing the same thing as the door. The top of it is poking out of the top there, but notice that it is unaffected here in plan. So clearly that's not it, right? So what I'm going to do is use my undo drop down here and undo back a few steps to get the door to go back down to where it was previously. And now let's talk about what the rules actually are. In order to display in the zone between cut and top, the element must be of one of 3 categories. It must be generic model, or window, or casework. So the reason that these elements are displaying is because they're casework. And the reason that the door did not is because it is not one of those 3 categories. So in addition to being of one of those 3 categories, casework, generic models, windows, it also will display if any part of the element intersects this upper zone. That's why when the cabinet was poking through the top, it's still displayed. But if I were to select the cabinet and move it all the way out of that range, it will finally disappear. Okay. So in order to display, it's got to be those 3 categories, and it needs to fall within that zone. So that's the behavior of the above cut plane view range. Now I'm going to click to the floor plan here, and looking at my floor plans, I don't have a foundation plan. So what I want to talk about next is a similar concept related to view range, but in order to do it, I want to create a new floor plan. So let's go to the view tab here, floor plans drop down, and we'll choose floor plan. And then we're going to make an architectural plan. And the only view it's offering us is the one that I want to use, which is top of footing. So let's just simply click OK there. All right. Now, when this floor plan gets created, you're going to see an element right here, which is an elliptical arched opening, and a couple countertops appearing in the foundation plan. Now, what's a little bit strange about that is that those elements are not down at the level of the foundation. Now, to make this a little bit clearer, what I'm going to do is I'm actually going to select one of these, and then I'm going to click back to the floor plan, and notice what is highlighted right here. And then if I click this one and go back to the foundation plan, notice what's selected. And if I click this, so this is geometry that occurs in the floor plan. We've got this opening and these two countertops. Why are they displaying here in our foundation plan? Well, it's exactly the same issue. This is a generic model, and these two are casework. Now, to really understand this, let's take our section. Up here, you've got a split segment tool. So I'm going to click that. I'm going to click right about here with this little knife and then move down to move the bottom portion. You could move it forward or backward. I'm going to pull it backward to in front of that casework there. I'll click the modify tool to cancel. And now I'm going to take the section and pan it over. And I've got some additional illustration over here, which will start to explain what's happening. The top of footing level is here. That means that when you measure 4 feet or 1,200 millimeters above that, your cut plane ends up right about there, just below the slab. If you measure 7'6" or 2,300 above that, the top of your view range ends up going right through the middle of these countertops and, of course, through the middle of that generic model opening. And that is why these three elements are displaying. So the solution in our foundation plan is to adjust the top of view range and just lower it down so that that is no longer an issue. So I'm going to click in the top of footing. You can locate and click the view range button or just type VR. And then what I want to do here is lower the top of the view range down. Now remember, these numbers can't get out of order, but they can be equal. So I'm just going to make the top equal the cut plane. And then I will click OK, and those elements will disappear. So the last thing I want to talk about is the view depth. Now you can see here I have created it at 2 feet or 600 millimeters lower than the bottom of this view. And that is so that the structural foundations underneath those walls can display. Notice here in the floor plan, they are not currently displaying, right? So if we go back to view range in this view, you're going to see that currently we don't have a view depth at all. The bottom and the view depth are both set to 0. So the view depth is a special zone that will display any of the geometry that falls within it using a special override. So the first thing you need to do is enable it. Okay, so I'm going to do that with that setting that I got illustrated there in the section. So -2 feet in imperial or -600 millimeters in metric, and I'll click OK. Now, the trouble is, it looks as though nothing happened. So the extra little wrinkle that we have here in this particular file is that if you zoom out a little bit, we've got this site plan model right here. And it turns out that that site plan model is just simply covering up the foundation and making it impossible to see it. Okay. I'm going to take that site plan model and go to my sunglasses, and let's just hide that temporarily. Okay. We can deal with it more permanently in a future video, but for now, I just wanted you to understand the concept of view depth. So now let's go back to view range, VR. I'll set this back to 0 and click apply. The foundations disappear. I go to -2 and I click apply, and the foundations reappear. So now you can see the way that the view depth operates. Now notice that they're coming in not full intensity. They're kind of like light gray there. The reason for that is anything in the view depth zone will appear using a special override line style. So this illustrates perfectly the point I'm trying to make in all the videos in this chapter. The very first thing you always want to do when you're trying to change the way something appears in a view is to start with the view's extents and then move on to other settings. So start with the what before you move on to the how. What do you want to display? I want to see the footings, right? So the footings aren't displaying. How do you make those display? That's the first thing you solve. Then you can move on to how they're displaying. I'm not satisfied with the way these footings display. I want them to have a dashed edge. That comes next. It doesn't matter if you make the edge dashed and you can't see them. Okay, so always start with the what before you move on to the how. All right, so how do we make this a dashed edge? Well, that's on Manage. We're going to go to Additional Settings and Line Styles. And the reason for that is if you expand this, and let's just widen this column, it's a little narrow for me. Okay, there is a line style here called Beyond. That is what we're seeing there for those footings. And you can see now why it's gray, right? Because the color is assigned gray. Well, it's got a solid line pattern, and I can just choose a dash pattern and click OK. And now all those edges will display in dashed. So admittedly, some of the settings here in the view range dialog can be a little bit complicated, a little opaque. So once again, I would like to remind you of the article I wrote on view range on my LinkedIn feed. I mentioned it in the previous video. And also I want to point out that I have a course here in the library called Revit View Range that digs in more deeply into the view range feature as well. This video is going to be our first example of changing how elements display instead of being focused on whether or not they display in the first place. So the last several videos, we were concerned with what displays in a view. And so if we didn't see elements we wanted, or if we did see elements that we didn't want, then we were concerned with adjusting things like the view extents and the view range and so forth to be able to determine which elements were eligible to display in the first place. Once you've gotten elements to display correctly in the view, then it's a matter of, are they displaying as desired? And now we move our attention to how they're displaying. And this video is going to be the first look at that. And we're going to focus on the most global way to modify how elements display, and that is object styles. So I've got a section open here, and I'm just going to zoom in and point out a few problems that I see. There are some wall elements, and I've got one here and here and here that are all being sliced through in this section. There's a roof element that's being sliced through, and those are nice and bold on the edges to indicate that they're being sliced through. Ceilings, on the other hand, here, and this floor element, they are not showing that bold rendition, and I'm not satisfied with that. It's difficult to tell that those items are actually being sectioned through, and I want to address that. So that's going to be a job for object styles. And the reason we want to use object styles for that is this problem is not limited to just this view. If I open up another section view like this transverse section, notice that I have the same problem here. So I've got a roof that's bold, walls that are bold, but floors and ceilings that are not. So what I want to do is find a way to modify this behavior, but not have to do it in every single view independently. And that's exactly what object styles is for. So I'm going to go to Manage, click the Object Styles button here. And it's possible you might need to expand some of these columns here to be able to read everything. So I'm just going to expand the first couple like so. And then notice that here on the Model Objects tab, we see a list of all the model element categories. Now I'm going to scroll all the way to the bottom and locate the Walls category. And then let's focus on the line weight column. So notice there are two line weights, projection and cut. So for walls in projection will use a pen weight 2. Walls in cut will use a pen weight 5. So Revit line weights start at 1, which is the thinnest, and go on up from there. And so a pen weight 2 is much thinner than a pen weight 5. Now you can see examples of that if I move the object styles out of the way and we look off here in the distance. Here and here we have two examples of walls in cut. They're nice and bold with the pen weight 5. And then off in the distance on this soffit condition here, we have some additional walls here, but we're seeing them uncut off in the distance, so they're using only pen weight 2. So I would like the floors and the ceilings to behave the same way. So it's as simple as scrolling back up to the top of the list. Let's locate the ceilings category. And I'm going to change the cut line weight for ceilings to pen weight 5, press enter, scroll down, locate the floors category next, and repeat the same thing, 5 and enter. Let's click OK. And now you're going to see all the floors and ceilings in this model are now displaying in the same bold pen weight here in section. But more importantly, that change applies everywhere. So you don't need to do the change again in the transverse section or any other view. It's already done in every view when you do the object styles. That's the advantage of object styles. So if you discover a deficiency in a particular object that really should be handled globally, then the right place to edit it is object styles. Let me show you another example. I'm going to open up the default 3D view, and I'll zoom in, hold the shift key, tilt down slightly, and we've got several roofs here, here, and here. Now, those roofs could be different types, they could be different configurations, but they're all this bright green color. So if I'm not satisfied with that bright green color, then I can actually change that default. The reason they're bright green is because of a setting in Object Styles. So I'm going to go to Object Styles, and this time scroll down and locate the roofs category. And when I select it over here in the material column, let's just widen that up a little bit, you can see that there's a material assigned to the roofs called default roof. Now there's two remedies to this situation if I'm not satisfied with the green color. I can click the edit icon here, and in the material browser, I can change the color, or I could just simply remove that material designation and click OK. And that's what I'm going to do. And then the roofs remove that green color. So those are two really simple examples of modifications you might want to consider in Object Styles. I do want to stress, however, that Object Styles is considered an Office Standards command. And so if you have a CAD or BIM manager at your firm who manages those sorts of things, you should definitely consult with that person first before you make any changes in Object Styles. As we continue working our way down the display hierarchy, in some of the earlier videos, we considered the crop regions, the view extents, the view range. Then we moved on to object styles, which configured the global display settings. And now we're ready to start talking about individual view display settings. So there will be many situations where you want to customize a particular view to convey certain kinds of information, and you won't want those settings to apply to any other view. That is the purpose of the visibility graphic overrides command. So in this video, we're going to be talking about visibility graphics, and I'm going to show you several examples of using this tool. So I'm going to start right here in the first floor plan. And the first thing I noticed is that it's an architectural floor plan, but it's showing a lot of site information. So I don't think I want to see all of that site information here. So the way that we can control that is using visibility graphic overrides, and we can hide the categories that we're not interested in. So let's look at that as our first example. So I'm going to go to the View tab, and the visibility graphics button is right here, or you can type the keyboard shortcut VG. When this dialog displays, I want you to take note of the message at the top. It says visibility graphic overrides for floor plan L1 architectural. So even though this dialog looks a lot like the object styles dialog, it's actually very different. And anything that we change here only affects the current view. Now notice that the first column here is the visibility column this time. So that's also unlike object styles. And so that means if you want to hide a category, you just simply uncheck the box. So the first category that I want to hide is the planting category. So I'm going to scroll down here and locate planting, and I will uncheck it, and let's click apply. And you're going to see some trees disappear there. And if I kind of move this out of the way, you can see the trees have disappeared throughout this view. Now, we've got some windmills over here. We've got a property line over here. I'd like to hide some of that information as well. If you scroll down and locate the site category, you will see that several categories also have subcategories. Property lines are a subcategory of site. Now, if you were only interested in hiding the property lines, you could uncheck and click apply, and it would just hide that, but the windmills would stay. If you would rather hide all of the site information, then instead you can uncheck the parent category, and that would apply to everything, including the subcategories. So the property line would also disappear in that case. Now, in addition to those categories, I'm also seeing the roads and the sidewalk and the parking lot. That's all controlled by the topography. So if I scroll down here and locate Topo Solid and uncheck that, and let's click OK now, you can see that I now have a much cleaner first floor plan. So that's our first example of modifying things with visibility graphics. So the next thing I want to do is show you or confirm for you that all of those changes only affected the first floor plan. So if you look here on the project browser, you've got a branch called Floor Plans Site Plan. I'm going to expand that. And then there's our site plan. I'm going to double click to open it up. And we've seen this view before in an earlier video, but let's zoom in here a little bit. Now notice that the trees, the property line, the windmills, the parking, it's all still displayed here. But if you zoom in a little closer, you'll notice that in addition to that, we're also seeing electrical outlets and light switches. So it doesn't seem like those categories ought to display on a site plan. So let's go right back to visibility graphics, or VG, and let's hide the categories we don't want to see here. So that's going to include things like data devices, electrical equipment and electrical fixtures, and lighting devices. And when I click OK, all of those elements will disappear. And now that looks a little bit more correct for a site plan. So I'm going to close the site plan view. And those are two really simple examples of just focusing on visibility that we can use visibility graphics for. But it's visibility and graphics. So it's not limited to just visibility. So what I want to do next is create an example where we're going to do both visibility and graphics. So to do that, though, I need to create another view. So I'm going to start with my level 1 architecture plan. I'm going to right click it, duplicate the view, and there's a couple ways we can duplicate, and I'm going to demonstrate the first two. So I'm going to start with the first one, which is just labeled duplicate. That's going to add the word copy 1 to the end of the name. I'm going to right click and choose rename, press the end key on my keyboard to jump to the end of the name, backspace out copy 1, and then put in furniture at the end of the name. Here, this view now is going to be my furniture plan. And what you'll notice is that when we do duplicate, it creates another view of the model itself. So you see the model geometry, but when you compare that to the architectural plan, it contains none of the annotation, none of the tags, the dimensions, or the text. Now, if you want a copy of this view that contains a copy of the dimensions and text and annotation, then what you can do instead is right-click the view, duplicate, and choose duplicate with detailing. So that's the difference between those two commands. So I'm going to right-click that one and rename, and then remove copy 1, and instead write power as a suffix. So I now have 3 copies of my first floor plan, my default architectural, and then a furniture and a power plan. So I'm going to go to the furniture plan and do some more work in visibility graphics. So let's go to VG, or visibility graphics button, and I want to hide the same categories we hid in the site plan. So I don't want to see any of the electrical information in this view. So I'm going to scroll down and hide data devices, hide electrical equipment and electrical fixtures, and hide the lighting devices. And I will click apply there. So you're going to see all of those elements disappear. So now let's move on to the graphics idea, right? So that's the visibility, but remember, this is visibility graphics. So what else can we do? I'm going to select the furniture category, and notice the presence of all these override buttons. So there's lots more that we can do here than just hiding things. So I'm going to click the override button for projection lines, and I'm going to boost the line weight up to a pen weight 4 and click OK. Then under patterns, I'm going to click the override button and change the pattern to this diagonal crosshatch small. And then I'll change its color to this medium gray and click OK. So let's click OK and then find the OK one more time. And now you should see that all of the furniture has taken on this crosshatch pattern, and its outline is now bolder than it was before. So this serves to emphasize the furniture here in the furniture plan view and make it a little bit more prominent. So now let's direct our attention to the power plan. Now here in the power plan, I obviously don't want to hide the electrical outlets and so on, because that's the purpose of a power plan. Now you could hide the furniture so that the electrical outlets stand out, but it might be nice to see the furniture here. So instead of hiding it, let's go to visibility graphics and look at one more example of changing the graphics. So as an alternative to scrolling through the list, you can type the letter F. That takes you down in the alphabet, and then you scroll a little further, and there's furniture, just another way to do it. And over here on the far right, there's a halftone checkbox. I'm going to click that and click OK. And now that effectively de-emphasizes the furniture without hiding it entirely. So those are just some examples of the kind of things you can start to consider doing in visibility graphics. Now, there are certainly plenty more that you can do. But what I want to leave you with is making sure that it is very clear that all we've done is customize the way things look in this video. We have not actually changed the model in any way. So when I created these 3 views, these are not copies of the model. This is still one unified model. If I grabbed hold of this reception desk here and moved it, notice that as I click through the other views, not only is it moved in each of those views, it's still selected. There's only one reception desk, and we're just simply seeing it in 3 different views and rendered in 3 different ways. So feel free to experiment further with visibility graphics here in this view. This is a very common and powerful command that once you start using Revit on a regular basis, you'll find you're using visibility graphics quite frequently as well. In this video, I want to consider the fundamental difference in behavior between model geometry, things like walls, doors, floors, roofs, and annotative or detailing geometry, things like detail lines, dimensions, tags, and text. These 2 classifications of elements behave fundamentally differently in Revit projects. And it's really important that you understand that, especially when you consider things like manipulating and controlling those elements' visibility. I've got a floor plan here that contains both types of elements. So there's naturally a bunch of model geometry. And, if we kind of zoom in and look around, you can see I've got tags for the windows, tags for the doors, tags for the rooms. Okay. And there's some dimensions out here. So I've got both kinds of elements. Now, this is the main architectural floor plan, but if you watched the previous video, you recall that we created 2 duplicates. So we had a furniture plan, and notice that this view does not contain any of that annotation, none of those tags or dimensions, and then this power plan does. It's an exact copy of the original architectural view. So when we first created this power plan, we duplicated it with the detailing from the architectural view. But let's say that now we are looking at this and deciding that maybe we don't really need to see the door tags or the window tags after all. Well, your first instinct is probably to say, oh, sure, I know what to do. Let's go to visibility graphics. And here you'll find there's an annotation categories tab. So far, so good. Let's expand this a little bit so we can read it better. And let's scroll down, and we've got categories like door tags, and scroll a little further down. We've got our window tags here, and I could just simply hide those 2 categories and click OK. Problem solved, right? Well, I'm going to recommend that you don't do it that way. Now, at first, it may seem surprising to hear me say that, but I've got a few different reasons why I don't like that approach. First of all, it's redundant. The idea behind tags is that tags, by definition, are already view specific. All annotation is. So we've already seen this, that annotation exists only in the view that it's created in. And that means that it will already only show in that view. If you hide it, you could send the wrong message, or it could be confusing to people. Like, let's say that at some point, somebody kind of comes over here and says, oh, I think I want to add some window tags to this view. Now, maybe they weren't in the meeting where we decided we didn't want to see window tags in the power plan, or maybe we've changed our mind, whatever the case may be. So I'm going to go to the tag command here, and I'm going to touch this window. Now, it generates a warning, but maybe I missed that warning. Maybe I didn't notice. And I go on to this next window here, and I go, well, that's strange. Why isn't it displaying these tags? And so maybe I try again. And it may take me a while to notice that it's actually creating the tags, but simply hiding them because that category is hidden. So when I finally figure that out, perhaps I cancel out of the command. I go back to the View tab, go back to Visibility Graphics or type VG and go back to Annotation. And I'm going to scroll down and I'm going to locate the door category and turn it back on and the Windows tags and turn it back on. And I click OK. And now notice that I ended up with multiple tags in the same location. Now, at first, that may not be that big of a deal, but it certainly will be a little bit disruptive to realize that you have these double tags, but it also might be frustrating for the person who did the second set of tags to realize that they wasted all that effort creating that second set of tags when there was a perfectly good set of tags just hidden from the view. Now, I understand why folks' instinct is to hide the geometry. You know, they're worried, oh, just in case I'm going to hide it, we may want it again later. But that's not the way that annotation is designed to behave in Revit. In Revit, model geometry is visible in all views. So therefore, we want to hide or show when it comes to model geometry. Annotation, by definition, is view by view. Therefore, we want to either add the annotation or remove it. So what is my recommended solution to not wanting to see the window or door tags here in the power plan? I recommend that you select everything, go to Filter, check None, select Door Tags and Window Tags, click OK, and then press Delete. And I know at first that might feel uncomfortable, and you're not sure that that's correct, and you're wondering, well, why wouldn't we just hide it just in case? I'm going to ask you to trust me on this. This is the right way to do it. Now, there are so many easy ways to annotate views. We're going to talk about this in a future video, but let me just show you a quick example right now, okay? It's not going to be door and window tags, but I'm going to focus now on room tags, okay? I'm going to select everything once again, go back to Filter, check None, and I'm going to pick room tags, click OK. And this time I'm not going to delete them, but looking at my furniture plan does not contain any room tags, and it might be nice if it did. Well, rather than painstakingly create each and every room tag, perhaps I look at this other view and I say, hey, there's a perfectly good set of room tags right here. All I need to do is select them as we've done, copy that to the clipboard, click over here to the furniture plan, go to this drop-down menu right here, and choose Paste Aligned to the current view. And I'll get a new set of room tags in exactly the same locations as the parent view, and it's just that easy. So if for some reason you decided you wanted window tags here in the furniture plan, instead of having to painstakingly go place them one at a time, you would simply go back to a view like the architecture plan, select them all. And in fact, you can even do that by right-clicking and saying, select all instances in the view. And that's even faster than using Filter. And then with those window tags selected, copy them to your clipboard and paste them to the other view. So that's the way that I recommend that you manage annotation. If you don't need the annotation in a view, don't have the annotation in the view. So don't hide it, simply remove it. And then if you don't want to see a model element in a view, then yes, by all means, hide it. Because if you delete something in a model view, it is deleted everywhere. And by the way, if you delete something that has a tag on it, like say this window, not only is it deleting the window, but it will also delete any tags that rely on that window. So deleting model geometry is a much bigger deal. So I'm going to undo and undo to get the reception desk back. Okay. But deleting tags, it's a totally different proposition. Deleting dimensions, it's a totally different proposition. So those elements can safely be deleted, and it's actually preferable. I rarely, if ever, hide anything annotative, and I recommend that you don't as well. If you take the time to customize the display of a view, and then you realize that you have other views in your project that have similar customization needs, it can become very tedious to try to remember what all the different settings were that you configured and then manually reapply those to the other similar views. Now, this can happen if you have multiple floor plans that are similar, or elevations or sections, or really any similar views that have the same display needs. Well, in any of these situations, this is what a view template is good for. A view template is a tool that can capture all of the visibility settings applied to a view, and then you can easily reapply those settings to other similar views. So we're going to look at some examples of setting up and using view templates here in this video. So I'm starting in the architectural power plan, and what I want to do is capture everything that we've established here in this power plan and apply it to the second floor. Because if you look here, I've duplicated a level 2 architectural power plan, but it's still showing the site information and it doesn't quite look the same. So I want to customize that now. So rather than try and remember what all the settings were that I did on the first floor, I'll just simply go back to the level 1 power plan here and create a view template. So I'm going to go to the View tab, and there's a View Templates drop down right here, and we want to choose Create a Template from the current view and give it a name. So I'm going to call this Typical Power Plan and click OK. Now that will create the view template, and it will display the View Templates dialog and show you all the settings that have been captured in that view template and give you an opportunity to further customize them. So we were mainly concerned with VG overrides for model right here, but notice that it includes all the visibility graphic overrides. It includes the scale, model display, whether shadows are turned on, background settings, etc. So it includes literally anything to do with the configuration of this view. So this is a very, very powerful command. Now you can even uncheck things that you don't want to include, but in this case, I'm going to accept all the defaults here and simply click OK. And that creates that view template, and it's now ready for use. So how do I use it? Well, I'll just switch back over here to the level 2 power plan, use the same drop-down menu, but this time I'm going to apply the template properties to a current view, and I'll choose Typical Power Plan and click OK, and it's really just that easy. So now you're going to notice that the second floor power plan matches the display of the first floor one. So there's one small issue that I noticed though. Previously, we had set the furniture to halftone, and it appears as though that setting has been disabled. So I'm not sure why that is, but one of the advantages of view templates is if you discover something wrong with a view, you can just simply recreate the view template and do it again. So I'm going to go to Visibility Graphics, and I'm going to locate the furniture category, select it, turn on halftone, click OK. So now the furniture is all halftoned. I'm working in the second floor, but it doesn't really matter because you can capture the view template in either floor. I'll go back to View Templates, create template from the current view, and what you want to do is type the same name. When you do and click OK, it will tell you that that already exists and ask you if you want to replace it. And I'll answer yes. Again, you get to confirm the settings. I'll click OK. And now I have created an updated version of the power plan. However, it's important that you understand that you've only updated the view template at this point. You have not updated any of the views. So there's two methods to using view templates. The method I'm showing you now allows you to create the view template, and then you choose when you want to apply it and how. So if I want to reapply it to the first floor, I would simply repeat the process here and apply the template properties to the current view, choose Typical Power Plan, click OK, and now it matches the second floor. But notice that the process of creating and applying it is still a manual process, but you can easily reapply it once you've made updates. Now, it turns out that there's a slightly faster way to do this. You could do it on the project browser. So I could have selected level 1 architectural power, hold the control key down, level 2 architectural power, and then with both of those views selected, and that could just as well be 10 views or 20 views, then you right click and apply view template is here, and then you would get the same opportunity to choose the view template and click OK. All right, so that's a little quicker than doing it one view at a time, but you would still need to apply it on a view by view basis. Now, let's say you don't want to do that. I don't want to have to apply it on a view-by-view basis. What I would rather have instead is for it to automatically be applied and automatically keep my views up to date. So let's look at that workflow using the furniture plan. So I'm going to double-click the Level 1 furniture plan, and then I'm going to come up here to the Quick Access toolbar and close inactive views. So that's going to close both of the power plans and leave me with just the furniture plan. Now, the furniture plan already is correct because we've set up all these settings in an earlier video. So I'm going to go right to View Templates and choose Create a Template from the current view, give it a name, and then click OK. I'm satisfied with all the settings, so I'm going to OK again here. And now I have this view template. So here's the difference in how we're going to apply it this time. I'm going to select the Level 1 Architectural Furniture Plan and hold the Control key down and Level 2 Architectural Furniture Plan. Now, I just showed you that we could right-click. That's not what we're going to do here. What we're going to do instead is go to the Properties. Up here, it'll say Views 2. So we're applying properties to 2 views right now. And when I scroll down, you're going to notice that there is a View Template setting here under Identity Data. It's currently set to None. I'm going to click that and choose the typical furniture plan and then click OK. So now if I double click to open up the Level 2 furniture plan, you can see that it matches Level 1. Now I'm going to do window tile. So tile the views or type WT so that we can see both of these furniture plans side by side. And now I want to show you how this alternative way of applying the view templates behaves. There are some consequences. If somebody comes into this view and decides they want to change the scale, everything's grayed out. What about the level of detail? What about the shading mode? Really, anything that you see here, it's all grayed out. Suppose they want to change visibility graphics, VG. All of that is grayed out. Now, why is that? Well, because everything right now is currently being controlled by the view template. So that means if I want to change any settings whatsoever on any of my furniture plans, I need to return to the view template and modify it there. Now, how do I do that? Well, it turns out you can click the drop-down, and the final command on this menu is Manage View Templates. So I'm going to do that, locate my typical furniture plan view template right there. And remember all these settings over here? Now you can change anything you like. So I'm going to do something that'll be really noticeable on the screen. So for VG overrides for model, I'm going to click Edit, scroll all the way down to the bottom, locate the walls category, and then over here in the cut column for patterns, I'm going to click the override button, and I'm going to apply a solid fill pattern to the cut of the walls. And I don't want it to be solid black, so I'm going to choose something that's not quite as dark. Maybe I'll use this purple color right here, and I'll click OK, OK again, and then one more time, and then finally dismiss the View Templates dialog. And now you're going to see that I have this solid fill purple poche applied automatically to any view that is using the furniture view template. So that's the difference in behavior if you choose to apply it selectively or if you choose to use it as a setting of the view. So again, it's not right or wrong either way. Both methods are perfectly valid. It really is a matter of personal preference and how you want to manage things. But regardless of how do you choose to use the view templates, the view template tool itself is an incredibly powerful way for you to manage visibility settings across really any size project, but certainly on larger projects, it becomes very handy. We have many ways we can hide elements in Revit. We've only looked at some of them. So there are the temporary hide isolate tools. There is visibility graphics where we can hide categories. Most hiding takes place on a view by view basis. Okay, almost all methods of hiding will happen view by view. So that's important to understand. And it is possible to even go down and hide individual elements at the object level. So I'm going to show you how to do that here in this video, but I'm going to recommend that you do it very sparingly. Okay, so let's just jump right in and let me show you how to hide elements individually. And I'm going to do that by working in this 3D view, selecting one of these columns, and I want to hide this column in the view. There's 3 ways you can do it. There's a right click where you can say hide in view by element. There is this little light bulb here, hide element, or you can see there's the keyboard shortcut EH. So use whatever method you wish there, and you can hide that column. So I'm just going to repeat that with another one, and now I've hidden 2 of those columns there. Okay. Now, as I mentioned, those elements are only hidden in this view. So if we go to some other view, like the level 1 architectural floor plan, and zoom in, notice that all of the columns are still visible here. Okay. Now, I was hiding things one at a time. It's not necessary that you hide them one at a time. You can do a multi-selection like so and hide several elements all at once. All right. So let's say you've hidden some stuff and then you change your mind and you want to get them back again. Now, of course, right now I could simply undo, but when I close the file and I go home for the day and I come back tomorrow, I'm not going to have the option to undo. So when something is hidden and you want to restore its visibility, how do you get it back again? Well, if it's done in visibility graphics, it's easy because you just go down through visibility graphics and you check and uncheck the boxes, right? So that's no big deal. But when it's done by object, you don't have anything like the visibility graphics dialog to go to. So how are you going to get these objects back? Well, there is a special display mode down here on the view control bar called Reveal Hidden Elements. And if you click that, it will put this colored border around the screen. It will tell you that you're in Reveal Hidden Elements mode. And then you could select one or more of the elements that you've hidden. And if you hover over them, it will tell you whether they are hidden by element or by category. So in this case, it knows that these columns were hidden by element. You can see it very clearly there. And then there's an unhide by element button right here, or the keyboard shortcut is EU. Now I've restored the visibility of those columns, and I can turn off the temporary mode to return the display of the model to normal. So that's a very simple example of using element hide and then reversing the operation. Okay. Now I'm going to zoom out a touch, and you'll notice that out here, there's still some site information. And in an earlier video, we hid that. Now, the way we did it in the earlier video is my preference. We went to visibility graphics and we located the categories in question, and we hid those categories. And that's what I recommend that you do. But based on what we're covering in this video, you might be tempted to just simply select this and say, well, I don't actually want to see any of that site information. Why wouldn't I just hide the Revit link, right? So that's an object, and I could go up here and choose hide element. Problem solved, right? It hid the topo, it hid the parking, it hid any of the trees and the planting, all of that stuff. Well, you certainly could do that, but I prefer to do it, as I've already indicated, using the categories that we've done in the previous video. Or if you're not going to do it with the categories and you want to just hide the entire model, then there's also a way to do that in visibility graphics as well. If you go to VG, there's a Revit links tab, and you can actually uncheck the Revit link, which would have the effect of hiding it in this view. I think either doing that or coming over here and going category by category is the preferred way. But if you choose to do what I've just done and hide it by object, the only way anyone would be able to get it back is using the Reveal Hidden Elements mode again. Now, when I go to this mode, it's interesting, right? Because it's not actually highlighting the Revit link in color, but it does say it's a hidden element if you hover over it. So that's one of the reasons that I don't love hiding it by object. So notice that the trees are showing up in the color, and that's because we previously hid that category. So it's a little tricky here if you hide with Revit links, and this is why I'm not really a fan of using hide by element for the links. So I'm going to select this and unhide it. And then, as I say, if you want it to be invisible, then either hide the categories or the link itself. So are there any good uses for hide by element then? Well, I think there's a few possibilities. What about this section right here? This is kind of a temporary section that we used when we were figuring out view range. And maybe I don't want to delete it, but I certainly don't want to see it in this view. So if I tried to hide by category, it would hide all of my sections. So this section would disappear and any others as well. So I don't want that. But maybe I just want to hide this one. Well, that might be a good use for hide elements. Another possible scenario is maybe this reception desk is going to be provided by others. And so I don't want to confuse folks looking at this view into thinking that they need to install this item as well. So perhaps I would do hide element on that as well. The only trouble with that is you need to be very careful because remember, hide by element is view by view. So just because I hid it in the main architectural plan doesn't mean it's going to disappear in the other views as well. So you might find yourself having to hide this element in lots of different views, at which point, if that's occurring, you might want to think twice about your approach and think if there's a better way. But anyway, that is the hide by element command. It is definitely a powerful and useful command if you use it sparingly, but that's really the key. Make sure you're using it sparingly and try not to overdo it. Throughout this chapter, we've looked at lots of ways to control the visibility of elements, and in the previous video, we did some manual modifications to the visibility and we hid a few elements. In this video, I'd like to show you what I consider to be a better alternative. We're going to look at something called display filters. Now, display filters are somewhere between what we were doing with visibility graphics and what we were doing with element level modifications, because they're more parametric like visibility graphics is, where visibility graphics applies to the entire category in a view. The filter applies to a collection of objects that meet a certain criteria that you get to establish. So you can say, give me all the objects of a certain size, or all the objects of a certain category, or all the objects that meet X, Y, and Z. You get to establish what those criteria are. And then once you've got that collection of objects, you can do something to it, hide it, show it, change its graphics, and so on. In this example, we're going to look at some filters that are already here in the model, and then we're going to create our own custom one. So for starters, I'm going to zoom out a little bit here in the floor plan, and I want to point out to you that there's a section line right here called section 1, and another one right below it called longitudinal section. And if you look at the two of those, you can see they look quite different. Longitudinal section is using solid line and it's a black color, but the section 1 is red and it's got this dashed line. So what's the difference? Why is it that the section 1 is displaying differently like that? Well, that is the consequence of a view filter that was part of the template that this file was based on. So if we consider the previous video, we had a section mark running down the middle of the break room, and we decided to just simply hide it. We didn't want to see it anymore, and we hid it. I'm going to bring that back now. So if you watched the last video, you know we can go to Reveal Hidden Elements. That will reveal anything that's hidden. I can select that section, and then I'm going to choose Unhide Element or EU, and then I'll turn off Reveal Hidden Elements mode, and now I have this section back displayed again here in this view. Okay. What I want to do is I want to make this one behave the same as this one. So how is it that these are different? Well, it turns out that there's something called a display filter, which is changing the graphical display of section 1 based on the kind of section that it is. So if you select section 1, you'll notice that it is a working section. That's the name of the type that's assigned to it. So I can select this section right here, the one that I just unhid, and open up the type selector, and you will see that there are several choices here, including working section. So if I choose working section, watch what happens to our section at break room. It now matches the graphics of section 1. So next, let me explain to you how that happens, right? That is a display filter. Okay, so let's take a look. I'm going to go over here to the View tab, and there's a Filters button right here. When the Filters dialog opens, you'll actually see that there are lots of filters in this file. Okay, all of these came from the template that this was started with, and most of them have to do with other disciplines, MEP and electrical and structural, but there are several that are useful for architectural here as well. Now, we're going to focus just on the one that we are looking at here for the sections, and it's called Views Working. Now, the first thing is that a filter will apply to one or more categories. So over here in the middle, you'll see categories, and the easiest way to see which categories this applies to is to check this box here, and that will hide anything that's not checked. So this filter, Views Working, is applying to callouts, elevations, and sections. And from all of those categories, it's looking at the family and type, And if the name contains the word working, then it triggers the filter. That's it. So the way you can think about a filter is, imagine it's just asking a question from the model. It's saying, hey, callouts, elevations, and sections, does your family and type name contain the word working? And if you kind of phrase it that way, like a yes/no question, it makes a lot more sense. So then the answer can only be yes or no. Yes, my name does contain working. No, it does not. If it contains working, then visibility graphics can kick in and change the graphics of that collection of objects. If it says no, then it's just simply ignored. So what I'm going to do now is cancel out of here. We didn't make any changes. And let's go to visibility graphics. And what you'll notice is there's a filters tab here. And the views working filter was already added to this view. That, again, came in as a consequence of the template that we started this project with. And this right here is why it's using a dashed red line. It's also set to halftone. So you can see that those are a little bit lighter as well. So anything that answers yes to the question is getting the dashed red line, and anything that is not is being ignored. Now we could go a step further. And earlier in the previous video, I decided I wanted to hide that section. I didn't want to see it anymore. Well, visibility is one of the choices here. So I could simply turn off the visibility, click OK. And now both of those working sections will disappear in this view. And of course, the other sections here, 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 those are unaffected. So that's a much more effective and powerful way to control the visibility of those elements, because you're able to create a subset of elements based on logical criteria and then only apply your modifications to that subset. Now, I should point out that everything I've just done is just in the architectural floor plan. So if I open up another view like the furniture plan, notice that the working sections are still displayed here. Now, they are dashed red. Okay, so the filter is applied here in VG and making it dashed red. It's just that it's still visible. Now, notice I can't uncheck visibility, and you may recall why, because in an earlier video, we applied a view template to the furniture plans. So the way that you would have to modify the furniture plans to hide the visibility would be to edit the view template, which I could do by going to Manage View Templates, scrolling down, locating Furniture Plan, clicking over here on Filters, uncheck the visibility, and then OK out of all of this. And then it would disappear not only here, but also on the Level 2 Furniture Plan, because it's using the same view template. So I'm going to close both of these furniture plans. For the last example in this video, let's consider the reception area. In the previous video, we hid the reception desk and its chair. So let's restore those now with unhide element. And then I'll turn off reveal hidden elements mode. And let's look for a better way to isolate these items. I'm going to select both of these items. And what I want to do is think about some way that I could establish that they are different than the other furniture in the model. Now, there's a number of ways we could do that, but one of the simplest things you can do is simply come over here to the comments field and put something in the comments. So I'm going to write by others in the comment field for those two items. That's step one. Step two is to go to filters and create a new filter. So I'm going to use the new icon down here. I will also call this by others. Click OK. And then in the middle here, I will check the furniture category. Now you can select more than one category if you want, but for this example, furniture by itself is suitable. Now you'll have a drop down over here of all the properties or questions that you can ask your furniture. Well, we put our information in comments, so that's what I want to query. I want to query the comments of the furniture and ask one of these questions. Is it equal to? Does it begin with? Is it greater than? Etc. Now, there's a couple ways you could do it, but I'm just simply going to do equals, choose the value by others from the list here, and click OK. So now I have a question that says, hey, furniture, do your comments equal by others? So the final step is to go into visibility graphics and say what to do with the items that answer yes to that question. So here's visibility graphics. I'll go to filters. I will add a filter, and I'm going to add the one called by others. Click OK. And now what would you like to occur to the items that are answering yes here? I'm going to change the fill pattern to a solid fill, and I'll just choose this bluish color here, okay? You can do whatever you want here, but when I click OK, notice that the reception desk and chair now change color, and it's very easy to tell that those are different somehow. Now, the cool thing about having this approach, doing it this way rather than right-clicking and selecting it individually, is if you go to any other item now and decide that it is also by others, it will immediately take on the characteristics established in the filter. So it's a much more powerful and consistent and easy to maintain approach. So even though it takes more effort to set up the filter in the first place, I think it's completely worth it. So I hope that you'll agree that using display filters is a superior approach to these kinds of issues, and I encourage you to explore them further. In this video, I'm going to look at two different graphical tools to help us fine-tune the graphics in a view. The first one is going to be the line work tool, and then a little bit later, we'll look at depth queuing. So for the line work tool, I'm going to start here in this floor plan, this furniture floor plan, and I would like to see a dashed line indicating where the balcony is up above. So there's a balcony looking down into this reception space, and we really have no indication of that currently in the first floor plan. But if we open up the second floor plan, you may recall that we had this floor element kind of looking down into the space below. Now, I could just use detail lines like this and set them to dashed lines and trace over that. That would be fine, except that there's a really good chance that if you later change the model in some way, that those detail lines would need to be manually updated, that they're not going to follow along. The line work tool is going to give us a better chance of keeping it associated with the underlying geometry. So that's what I want to show you here. Now, in order to use the line work tool, I need to be seeing the object that I want to modify. That's the floor in this case, and it's not currently visible. Easiest way to make it visible is to turn on the underlay in this floor plan. So instead of none, I'm going to set that to L2 and then apply that. And now you'll see ghosted in this gray line indicating where the floor element is up above. So next, what I'm going to do is zoom in nice and close here, and I want to show you how the line work tool functions. So we're going to go to Modify, and the line work tool is right here, or LW. And what you want to do is choose a line style from this list right here. So I'm going to scroll all the way down to the bottom, and there's this one called Wide Red, and I'm going to touch this diagonal line right here, and then maybe this edge of the column. Now, I'm going to click the Modify tool to cancel out. And so what's really interesting about the line work tool is you can touch individual edges of the underlying geometry and customize just that edge. So it didn't do the whole column, it just did that one edge of the column. Now, you might be looking at this and thinking that's great, but what if I change my mind? How would I reverse it? That's not at all intuitive. So I want to go through that first before we continue here. So let's go back to the line work tool, and the way that you reverse this effect is to open up the list of choices here and change it back to by category, okay? And then you touch the same edges over again, and they will return to displaying the way the category told them to rather than the override that you've applied. Okay, so now that you understand how to use the line work tool, now we can apply it to get the effect that we were after, which is to display a dashed line overhead. And it turns out that there's a line type here just for that purpose. It's called overhead, and I'll click that. And I'll touch this little horizontal line, the diagonal line, and then the vertical line here. And that will, of course, go down the full length of the floor element. Now, you no longer need to see the underlay to keep this effect. You can set it back to none. And notice that when you do, the dashed line still continues to display. This dashed line is the floor. So notice that if I move my mouse there, that actually selects the floor. You could click Edit Boundary and try changing the shape of that floor. As long as you change the shape in such a way that you're basically just moving some of the lines around, it should continue to apply the dashed line. If you radically change the shape and add new edges and so forth, then you'll probably need to customize the line work modifications that you've made. Okay, so just feel free to experiment with that if you like to see that a little further. Meanwhile, I'm going to move down to an elevation now. So I'm going to scroll down to the elevations and double click the south elevation to open that up. And I want to show you some other examples of the line work tool here in this elevation view. But first, I need to change a few things about the way it is currently displayed. I don't want it shaded, so I'm going to change the shade mode here from shading to hidden line. That looks a little better. And then the next thing is these trees are really overpowering. They're just kind of covering up everything on the elevation. So the way that I like to deal with trees is to go to Visibility Graphics. So I'm going to go to View, Visibility Graphics, or type VG. I'm going to go down to the planting category, and I'm going to change the transparency. So I usually like to go with something about maybe about 85% transparent. Click OK, click OK again. And now you're going to see that all of my trees are mostly transparent, and I can actually see the building through those trees now. If we go back to the floor plan and considering the shape of the building here, this wall in the foreground is closest to us, and then these other walls start to recede back. So I want to start to convey that in the south elevation here. So I'm going to focus on this wall first, and I'm going to use the line work tool to kind of boost up the line weights in this foreground element to make it appear like it's coming forward. So I'm going to go to Modify, click the line work tool, and instead of overhead, this time I'm going to use wide lines. And I'm going to touch some of the edges here, like the sloped edges of the roof, and then that little edge of the eave, and this edge of the eave, and then start doing the walls. Now, notice that the walls are in 3 pieces because of the soldier course, so you will need to click 3 times going down the length of the walls there. Now, if you click under the eaves, it's going to go all the way across, and I don't really like the way that looks. But notice the little grip here. You can simply stretch that back to that location and adjust the effect so that it only applies to part of that line. And I think that is a really nice benefit of this tool. Now, once you've done that, maybe you realize that it would be nice to boost those lines a little bit, but just maybe not quite to wide lines. Change to a different line type like medium lines, and you can touch the same line again, and it will apply a different effect to part of the line. So I think that's super cool that we can use the line work tool multiple times on the same edge and apply different effects as appropriate. So that's one way that I could start to give some depth to this elevation. But there is an alternative way. So let me just take a few minutes to show you that tool. It is called depth queuing. Okay, so depth queuing is going to apply a grayscale to the elevation, and the objects in the foreground will be the darkest, and the ones that recede back will become lighter. So you get to depth queuing by going to the Visual Styles pop-up, choosing Graphic Display Options, or GD is the shortcut. Then here in this dialog, you want to expand depth queuing and check this box to show the depth. So then you just have these little sliders, and you just start to drag them and click apply. And at first the effect is kind of subtle, but after a while you'll start to see, if you drag it quite a bit, what starts to happen. I mean, eventually you could get the whole elevation to disappear. So you want to find the right settings that are going to give you an appropriate level of grayscale. Now, you can couple this near and far slider with the fade percentage here. And if you start to adjust that, that will compress the gradient that's being applied so that the furthest back object isn't quite as light. It will become a little bit darker. And so just play around with these sliders and adjust them until you're satisfied with the effect. And then using that in combination with the line work tool, you can work on this elevation until it satisfies your own personal graphical style. So I encourage you to continue working on it to do so.
But now I'm sure you've seen how useful it can be to have a good 3D view to study your model and investigate how things are shaping up as you work. Well, we can go much further than the 3D views that we've already created. In fact, we can create 3D views that cut away from the geometry and reveal the insides of our model and allow us to really start to understand how things are fitting together and clashes that we might have or other issues that we might want to investigate. So in this video, I'm going to show you 3 different ways that we can create cutaway axonometric views. So I'm starting here in the default 3D view, and this is just the view that Revit creates when you click the little birdhouse icon, as you've no doubt seen in previous videos. Now, that view is located for me down here on the coordination branch under 3D views, and you can see it right there in bold. And of course, it's bold right here. Now, what I'm going to do is just sort of hold my shift key down and drag my wheel to tip this a little bit so I can see it a little bit better. And we're going to crop away some of the site here. Maybe I want to focus in a little bit closer on just the building, okay? So the first way that I'm going to show you how to do this is just using the properties on the properties palette. So I'm going to scroll down, and you're looking under extents for the section box checkbox. And all you need to do is check that. And when you apply that, you'll see this box appear out here. And I zoomed in a little too close to show it to you. So let me zoom back out. And you can see these little grip controls on all four sides. There's also one here on the top and one on the bottom. And all you need to do now is just sort of start dragging these until they cut through the portions of the model that you want to exclude. So you can see that I can just sort of work my way around all four sides, making adjustments like so. Now you could even do the vertical and start to, shear off the roof or something if you wanted to, but I'm going to leave it the full height for this first example, but that is certainly a possibility as well. Now, alternatively, a little bit quicker way to get to the same place would be to use a scope box. So you may recall that when we talked about scope boxes in an earlier video, that they can control the extents of not only datum elements, but other views, right? So that includes 3D views. So I've got this scope box out here called Views Overall. So instead of turning on the section box and manually adjusting the grips, what I could have done instead is scroll down here, and it is right above section box. You can see currently the scope box is none, and I could change that to Views Overall. And now it crops in a little bit closer, and the crop of this 3D view matches that scope box. Now, the section box is still here, but notice that when I select it, it no longer has the grip controls. And that is because it is now being controlled by the scope box. So it's one or the other. You can't have both at the same time. So that is how you could start with an overall view and then crop it in a little bit closer in a kind of a manual way, right? So it's completely manual using section box, and it's a little less manual using a scope box. Now, very important, this next thing. Let me redirect your attention to the name of the view here, this curly bracket 3D name. That's Revit's default 3D view. So if you want to preserve what you've done here, it's very important that you get in the habit of right-clicking this and renaming it. Because if we change the name, then the behavior of the default 3D view button is going to change the next time we use it. So let's call this overall axon. Doesn't matter what you name it. And now I'm going to click away from it, deselect. And now watch what happens when I come up here and click the default 3D view button again. So notice that I get a brand new curly bracket 3D view, and it's kind of in the default orientation. It's not shaded, right? Like it's just a complete default view. Now, I do want to point out something else about the default 3D view. Any new view that you create in a Revit project will go into a branch on the project browser based on your default discipline. So notice that my default 3D view went to the coordination branch. Okay, yours might have gone somewhere else. It's possible it could have gone up here to architectural. Now, what controls that? If you go to the File menu and go to Options, there's a number of options you can configure in this dialog, but the one that I want to direct your attention to is here under View Options, and notice that mine is currently set to Coordination. I'm going to change that to Architectural, and the next time I create a new default 3D view button, you're going to see it's going to go into a different branch. So we'll see that in just a few minutes. Let's just click OK here, and let's continue with this 3D view now. So I'm going to scroll back down to where this view is. It's right there. And I'm going to zoom in. And now what I want to do is, instead of cropping this manually, I want to base the cropping of this 3D view on one of my existing views. And the way you can do that is using the view cube over here on the right-hand side. So just right-click anywhere on the view cube. A menu appears. Then you can do Orient to View. And notice that you can orient it to your existing floor plans, elevations, sections, and even other 3D views. So I'm going to orient it to one of my floor plans for this example, and I'm going to choose L1 Architectural. And what that does is it just simply matches the orientation and the cropping of that existing floor plan view. And if we zoom in, you can start to see the effect there, but I think it'll be easiest to understand what we've done if we go right back to the view cube and click one of the top corners there to orient it back to 3D. And now you can see that what we've created is this little cutaway plan version of the 3D view. Now, the section box is out here, and you can just see that it's really long and thin, but you've got the little grips, and you could maybe crop out those windmills or, crop out any other geometry out in the site that you weren't interested in. So you can certainly fine tune it after you've oriented it to the view, but orient to view is a good start to kind of get you close to what you're looking for. Now, just like we did before, it's a pretty good idea to get in the habit of renaming this. So I'm going to call this one 3D first floor. Okay. Now, a moment ago, I changed my discipline to architectural. So now watch what happens when I click the default 3D view button again. Instead of getting the curly bracket 3D view here under coordination, I'm going to scroll up to the top, and it's now under architectural. So where exactly? Well, under architectural, under a new branch called 3D views, and there it is right there. Okay, so it's still called curly bracket 3D. It's just that it's now been placed in a different discipline. So let's look at our third way that we're going to create a cutaway 3D view. And this is one of the reasons why it's so important to rename first, because you're going to see that this next command is going to take over our curly bracket 3D view here, right? So now I'm going to start, you can start this command in any view you like. So I'm actually going to start it in a floor plan. So I'm going to go to L1 floor plan and zoom in, and I want to create a cutaway 3D view of the lobby area. So in order to do that, you can start with a selection of geometry. So I'm going to start right out here outside the building and kind of drag about like so. Okay. So that's going to select most of the items that I want, but it selected a little bit more than I wanted. I don't want this floor element out here. Okay. So what I'm going to do is just simply hold my shift key down and drag a crossing selection back like so to try and remove that element from the selection. Now it seems to not be working, so let me go to the filter instead, and I will uncheck floors. There we go. That's what I was looking for. Okay. So now I have a selection of elements focused on just the lobby area. And the simplest way to create a cutaway 3D view is to simply click this little button right here or use the keyboard shortcut BX. So this is selection box, and it will make a 3D view that matches whatever you have selected on screen. So you can see that it is now focused on my lobby area. I could hold the shift key and I can orbit it around. I can zoom in. This is the section box out here. It has the little grips. So if I want to peel off that front wall there so we can see inside the lobby, maybe do the same thing with the roof there so that we can kind of look down into it and get a more interesting looking view. Those are all things you can do after you've created the initial view. Notice that this is the default 3D view. This is why I keep emphasizing renaming the view. So let's rename this one again. And I will just call this 3D lobby. And then as far as fine tuning this, you can use any of the techniques that we've already looked at in earlier videos. You can change the shading and the display. So for example, these scope boxes and levels always end up displaying anyway. So one of the simplest things you can do is just select that geometry and then use this little light bulb here and choose hide category. Now that is exactly the same as going to visibility graphics, VG, that we did in an earlier video, and unchecking the appropriate checkboxes, scope boxes, levels. It's just a little faster to do it that way. You could do the same thing with these room separation lines. I don't really want to see those. Hide category. If you wish, do it in visibility graphics, but it's just a little bit faster here. In fact, you can even hide the section box. So we can hide that category, and then here's our final result. We have a large collection of graphical display settings that we can configure for any view. Now I'm going to demonstrate here in a 3D view, but you can use this dialog in plans and elevations and sections as well. So to get started, how do we get to the dialog in the first place? It's called graphic display options, and there's two ways to get there. You can either use the pop-up menu on the visual styles and choose graphic display options, or it's also available on the view tab
on the graphics panel right here with this tiny little icon here. GD is the shortcut. So go ahead and open that using whichever one of those methods you like, and that will display this dialog with a number of configurable settings. Now, the first thing is the style, and that matches the pop-up menu that we saw on the view control bar at the bottom. So you can do everything from wireframe, which I rarely would do, to hidden line, of course, which is what we were seeing to start off with, to various kinds of shading. So there's this shading and consistent colors, which is like a flat shading, and then two modes that display textures and realistic. So if I click realistic and apply it, you will see some textures appear, and this also takes into account the lighting. Usually takes a little bit longer. If you choose textures, then that superimposes the textures on top of consistent colors, and that's usually a little bit quicker. Now, if I OK out of here and I zoom in, you can see that it's using the material textures. We've got wood grain on the windows, we've got brick on the walls, we've got concrete on the slabs, we've even got grass out in front. Okay, so that's a little bit of what's going on there with textures. So I'm going to leave that mode turned on for now. Okay, so the next setting is smooth lines with anti-aliasing. Now, to show you that, I'm going to zoom in on an area where we're seeing some diagonal or curved edges. So I want to focus your attention on the reception desk. You can see there's some diagonal and curved lines there, and also this column out here in the foreground. If you look at that, you can kind of see the stair-steppiness on the edges. So anti-aliasing is an attempt to correct that. So if we go to graphic display options again and check this box and click apply, you should now see all of those jagged edges smooth out, and that generally looks a little bit better. So let me OK here and zoom back out so that we can see the entire model again, and then I'll go back in. The next setting is transparency, and it's kind of interesting because you can start making the entire model semi-transparent, but this is all or nothing, so it applies to the whole model. What I prefer to do instead is something that's a little more selective. So if we OK out of graphic display options for a moment, you can select one or more elements on screen and then use this paintbrush tool here and either override by element or category. So if I wanted to apply transparency to all the roofs, for example, I could do it by category. If I wanted to apply it to just this roof, I could do it by element. And now there's a transparency slider here. So what I can do is just sort of boost the transparency of that. And now notice that that one element is semi-transparent. And I personally think that if you want to introduce transparency to a view, that's probably going to be the better way to do it rather than making the entire view transparent. But it really just depends on what you're personally trying to achieve. So let's go back into graphic display options and keep going here. Silhouettes is a feature that I love in concept, but I'm not wild about the execution. So the idea here is quite simple. It will silhouette or profile all of your elements by adding whatever line style you choose here to the profiles. So to see the effect most dramatically, I'm going to use wide lines, and then I'm going to click apply. And let me click OK here, and we'll kind of zoom in and look around. Okay, I think it did a nice job on this column. It did a great job on this column. It looks okay on the walls and the windows, but it's a little too bold on the soldier course. So there's areas where it's better than others. It's okay on the roof, but I really wouldn't want it bold over here by the walls. The furniture doesn't really look good at all. It's definitely a little too bold there, especially when you consider the handles and the details on the chair. Now, some objects are ignoring it entirely, like the railings and the stair, but it is doing a decent job here on the roof element and the ceiling element. So it really is hit or miss, okay? So I like it in concept, but I'm not sure I love the execution of it. Now, the effect is global and it is tied to the scale. So if you want to kind of reduce the overall effect, we could adjust the scale in here. So in the imperial file, I'm going to go to 1/4 inch equals a foot. In the metric file, that's 1:50. And that drops it back a little bit, so it's not quite as bad in some of the areas where it became a little too muddy. But ultimately, at the end of the day, if you're not satisfied with the result, you really don't have any choice but to just turn it off. Okay, you really can't control it selectionally or, on individual elements. So it's kind of an all or nothing sort of thing. So I'll leave that to you, whether or not you want to leave that enabled. Let's move on to shadows next. We have two kinds. Now, I really love ambient shadows. What that does is just adds a little extra punch to the view. You can see that it kind of dirties up the corners a little bit, almost like somebody took a piece of charcoal and kind of charcoaled in the corners and the edges, and it just gives it a little bit more interest. And I think it couples really well ambient shadows with this textures mode, consistent colors, or with hidden line. So if you just want a simple presentation where it stays in hidden line, but you want to show just a little bit of shading, ambient shadows is a great way to do that. Here's what hidden line looks like without ambient shadows, right? It's kind of flat. Here's what it looks like with it. Looks much better, right? So I personally love ambient shadows. I use that all the time. Now I'm going to go back to textures mode and I'm going to leave the shadows on, but let's talk about cast shadows next. So cast shadows is exactly what it sounds like. These are shadows cast by the sun. Now, in order to control the direction of those shadows, you need to consider the lighting. So if we expand lighting, you can then click in the sun setting window here, and the default scheme is just something called lighting, which I like to think of as over-the-shoulder lighting. So it's basically 45 degrees left or right, and there's some presets to that effect here. Now, if you're satisfied with that, then nothing to change there. But if you'd rather set the direction of the sun based on the real location of the project, then change to still rendering instead. The location of the project is here. You then get to set the date and time. And then when you click apply, it will adjust the shadows to match your actual geographic location. And in addition to that, there are some presets here like the summer solstice, the winter solstice, the spring equinox, right? So you can choose whichever one you prefer. And I think I liked the summer solstice best here, and I can click OK. Now, the intensity of the shadows is controlled by this slider right here. Now, it starts off being 50%. If you do a larger number, it will get significantly darker. If you do a smaller number, then it will get lighter. So I'm going to try about 40 or maybe even 35. Okay. And then click apply. And I think that looks a little bit better. Those shadows aren't quite so intense anymore. Okay. Now, if you're using realistic up here, then there are some settings that pertain to that in terms of exposure control and so forth. So you can look at those. If you want to introduce a background to the image, you can. There are some options here where you can do none, you can do the sky, a gradient, even an image. Now, sky sounds nice, and I'll click apply there, but that really doesn't look much like the sky. Well, what you need to do is consider that we're in an axonometric view. So the only way you'd see the sky is if you tip this up to look at the sky. So I think sky works best with camera views and elevation views, but not so much with this axonometric. So instead of sky, I'm going to change that to gradient, which just gives me an opportunity to have a little bit more interesting background, but I don't necessarily have to be pointing at the sky to see it. All right, now we already talked about depth queuing in an earlier video. There's an interesting setting here called sketchy lines, and if you turn that on and kind of drag these sliders, and let's click OK and kind of zoom in there, it sort of roughs up all the edges and makes it look a little bit more hand-drawn. So that can be a fun effect if you're interested in that. And I'm going to go back in, and I think I'm going to turn off the sketchy lines for this example, click apply. And the final thing I want you to see here is when you're satisfied with the settings, when you've arrived at a collection of settings that you like, this dialog has a direct link to view templates. So you can save this collection of settings directly to a view template so that you can reuse it in other views, and you don't have to try and remember what your favorite collection of settings were. So I encourage you to get in the habit of doing that because that can be really helpful. So spend a little bit more time in this file experimenting with the graphic display options. As I said at the beginning, it's not limited to just 3D views. So if you want to go ahead and open up a plan or an elevation or a section view and try some of the settings there as well, I think you'll find that there's a lot of different combinations that you can explore to really give each of your views a little bit of punch and try and find that collection of settings that matches your own personal preferences. In this video, we're going to add some rooms to this simple model here. Now, at first glance, you might be looking at this plan and thinking, well, there already are rooms here. But it's important to understand that having an enclosed space isn't the same thing as having a room. So in order for that to be recognized by Revit as being a room, we need to place something called a room element in that location. So on the architecture tab, there is this room and area panel here, and the room button is on that panel, and the keyboard shortcut is RM. So what I'm going to do is accept the default settings for this, which includes this setting right here, which is tag on placement. And I'm just going to move my mouse down into the view window, but not into the floor plan yet. So I'm off to the side here. And you're going to get this little blue rectangle that appears. So if I were to deselect tag on placement, you'd see that I would get just the blue rectangle without the label. And then if I reselect it, I'll get the label back again. Now, I think in most cases, when you're adding rooms, it's nice to see the labels. So having that tag on placement on is usually a pretty good idea. Now, I'm going to click out here in empty space. And when I do, that will actually generate a warning down here. Now, this is an ignorable warning. Remember, the yellow tinted ones in the corner, you can just click anywhere and they will dismiss. It says that the room is not a properly enclosed region. And I'm going to come back and talk about that in just a moment. So what do we mean by a properly enclosed region? Well, if we move into the plan somewhere, into an enclosed space like this bedroom in the upper left-hand corner, notice that the room now will conform to the shape of that enclosed space. And I can click to place the second room in that location. Now I'm going to click the Modify tool to cancel out of there, and notice that both rooms will disappear when I do. So rooms by default are invisible, and they only appear when you're either editing them actively or if you have them selected. So if I move my mouse into this bedroom area, notice that I can locate that X that runs through it, and I can click to select that room. Now, likewise, over here, even this one, which is not enclosed, I'm able to select if I can just find the edges or that X. When I select it, I want you to look over at the Properties palette and notice that it says not enclosed for both the area and perimeter. So now let me reselect the one here in the bedroom and we'll compare it. And notice that that one is generating the area and perimeter values because it is a properly enclosed room. So that's one of the reasons why it's important to make sure that your rooms are in a properly enclosed area. So if I want to, I can take this room that I have off to the side and I can actually pull it into the plan. So notice that there's a little move control right there in the middle. And if you click that and start to drag, you're able to pick this room up and move it. And it will actually start to conform to the spaces that you're moving it into. So I'm going to move it down here to this second bedroom and then let go. Now, when I do that, the default behavior is for the tag to stay where it was. So what I'm going to do is simply select the tag and uncheck this leader option, and the tag should now snap over to the location of the new room. Okay. All right. So I now have the two bedrooms located in their respective spaces. Let's go back to the room tool. And when we click the tool again, the room tool will always highlight any existing rooms to let you know where they are. And because it's an invisible element, this is handy because that way you won't accidentally place another room in the same location. If I were to do that, that generates a warning telling me that I've got a redundant room, and that's generally considered a bad idea. So I'm going to cancel that to not go through with creating that room. Now, what I'd like you to do in this pass is just focus on the enclosed spaces. So this little toilet room here, the small little linen closet beneath it, the toilet rooms here and the closet here. And notice that if you pay attention, you can get the tags to line up. Let's avoid this big space here for now. We'll come back and do that in a moment. Let's do each of the closets over here in the little utility room, and then maybe this closet right here. And then we're going to avoid this patio here for now as well. We'll come back to that momentarily also. So I'm going to click the Modify tool to cancel out. And now let's talk about how to subdivide a large open space. So whenever you have an open plan situation, it's possible that you might want that to be represented by more than one room. So to do that, you're going to use this tool first called Room Separator. And this is simply a model line that you can draw in any shape that you like. Now, for this plan, we just need straight lines. That'll be suitable. So you just start where you want that line to go and just draw it like any other line. So I'm going to close off that little dining room right there. Press Escape one time to break the chain. I'm going to close off this hallway here. Press Escape. I'm going to close off the kitchen here. Press Escape. And then maybe this little hallway right there, and press Escape. So now I've taken that large space and subdivided it into multiple smaller spaces. And then I also want to indicate a patio out here. And because there are no walls defining this patio, that edge you see is actually a floor element. Floor elements are not going to bound the rooms in plan. Only walls would do that, or these room separator lines. I'm going to go ahead and surround that patio as well, just simply by tracing over it. So now I'll click the Modify tool to cancel out of there. And now I'm ready to do the last pass of creating rooms and fill in all of those spaces. So now notice that it will sense each of these separately created spaces that I have just defined here using those room separators. And that includes this little patio on the exterior. So when you're done, you can click the Modify tool there. And of course, now the next thing you'll notice is that all of the rooms just simply say room name. Okay, so the next thing I want you to see is where that information comes from. Now, the information is part of the room, not the tag. So I want to stress that. So I'm going to select one of these rooms here, like maybe the living room. Scroll down on the properties. And notice that the name says room name. You can select that and type in something else. And when you apply that, notice that that will fill in the tag for you. Now, if I deselect the living room and select its tag instead, tags are just hosted elements that are reporting the information that they find in their host. So if we look over here on the properties palette, notice that we don't see room name or room number because that information is coming from the room that it's hosted to. Now, another way that I can tell that it's hosted is it highlighted the room that it's connected to. Up here on the ribbon, we've got these hosting buttons. So there's lots of clues that I've got a hosted element. Now, having said all of that, it is possible to actually select a tag, click right on the label and modify that. And the result of that modification is it looks as though you're editing the tag, but in reality, what you were doing is simply changing the name of the host element room that tag belongs to. So it's really just a shortcut. And it's actually not that much different than what we've been doing with temporary dimensions all this time. So when we want to move the door, one of the options that we can do is select the door and then edit the dimensions. We're not really changing the dimensions. We're using the dimension to move the door, and that has the result of changing the dimension. So perhaps that sounds like semantics, but if you think of it that way, I think it's easier to understand what you're actually doing. So when I click on this label and change it, I'm not actually changing the tag. I'm changing the name of the underlying host room. So using either of those two methods, select the object and edit its properties or do it directly in the tag. Go ahead and change all the remaining room names. And when you're done, it should look something like this. In this video, I'm going to add room elements to this commercial plan, and the emphasis is going to be on controlling the numbering or the sequence of the rooms. Now, when you do this in a residential project, you're probably not as concerned about what sequence the rooms are numbered in. In fact, you might not even bother showing the numbers at all. But in a commercial plan, it's very common for each room to have a number. And in those cases, it's probably more important that the sequence follow some logical pattern. Now, in Revit, the only way that you're going to get it to number in a logical sequence is if you are strategic about the placement of your rooms. There are plenty of third-party tools that allow you to renumber rooms later, but I want to stress that there's nothing built into Revit that will easily allow you to renumber rooms based on any kind of pattern. You would literally just have to do them one at a time. So this is why I'm going to emphasize on strategy here rather than just taking advantage of some tool. Okay. So let's go to the architecture tab and we're going to click the room button. And if you watched the previous video, then we've already gone through the basic mechanics of placing rooms. Now, right here on the ribbon, there's this place rooms automatically button. Now, we could have actually used that in the previous video for that residential layout, and it would have been perfectly fine there. But I wanted to show it to you here and show you why it's probably not a good idea in a plan like this. If I click this, it creates 15 rooms automatically, at which point you're probably like, well, that seems pretty good. Why wouldn't I just do that? But if you kind of zoom in here and you look around, the numbering doesn't make any sense at all. The chances that I would want the toilet rooms to be rooms 1 and 2 and then jump over to wherever room 103 is, I'm not even sure. There's the stairwell, it's 102. 103 is up here in this corner, and then we jump to 104. It's just totally random, okay? So it doesn't really make any sense at all. Now, if we had some sort of an automated way to quickly renumber the rooms, then maybe that would be perfectly fine. But in this case, I'm going to undo to remove all of those rooms and start again. So it will take a little bit more effort to place them one at a time, but I think it's worth it when you consider the benefit. So I'm going to go to my room tool and I'm going to click where I want my first room to go. So to me, that makes sense to be here in this lobby. Now, in this template that we started with, that starts at room number 100. Assuming that you're satisfied with that number, you could continue. But let's say that I wanted to start at a different number, like maybe 101. You need to stop the command at that point, because the only way you can come back and renumber this room is if you're out of the room tool in the first place. So I'm going to come over here and I'm going to click right on the room number label and type in 101. Now, if I go back to the room tool, you will see that I'm able to click the next room and it will sequence to 102. So if you remember the way that Revit numbers things, we saw this with grid elements and some other elements as well, it always numbers in sequence. So that's why it's important to stop, change the number, and then continue from there. So now I'm going to make room 103 over here in this corridor. Maybe 104 is this stairwell here. Then I will do the toilet rooms next, 105 and 106. And then I'll just keep going across here. And then I'm going to pick up over in the conference room next. And then finally, the remaining offices. So then I'll click the Modify tool to cancel out. So now I've controlled the sequencing of all of those numbers. Now, what about the names? Well, we've talked about that in an earlier video. There's two ways to do it. You can do it right on the label by typing into the tag, or you can select the room itself. And in some cases, this might require the tab key, and then you can modify it here on the properties palette. So I'm going to rename all of the uniquely named rooms first, and then I've got a couple rooms that have the same name, such as this corridor here and this corridor here. You can do those together, but you can't do that with the room label. Where you do it is on the properties palette instead. So if you select both of those corridors, you can then type in that name and both tags will get that name. You can also make other kinds of selections. So I'm going to select all of those offices, go to filter, check none, and then pick just the rooms. Notice I have 6 of them. And then when I scroll down here, the number will vary, of course, but I can type in office and it will update all of those rooms accordingly. So now that I've named and numbered all of the rooms to my liking on the first floor, I want to reuse as much of this as possible on the second floor. So I'm going to go up to the L2 architectural floor plan, and I want to show you the next little interesting behavior about the way things number in Revit. So if I go to the room tool and I kind of click right here in the corridor, which is what I want to be room number 201, notice that it's not 201, it's room 115. So this is really important to understand, is that not only is it just picking up where it left off, it's not considering the level at all. So you might be assuming that it would do a 1 series rooms for the first floor and a 2 series room for the second floor, but it doesn't do that. Revit doesn't have any sophisticated rules about the numbering. It's just simply starting at a number and picking up from there. So just like we did on the first floor, when you move to the next floor, it's real important that you place the first room renumber it. While I'm here, I'll go ahead and change the name. And then you can pick up from there. The next room I make will be 202 and then 203 and so on. But it also turns out that now I could select all of these rooms that I want to reuse, go to filter, check none. This time I'm going to choose rooms and room tags and click OK. So if you look at my properties palette, I have 10 elements selected. I'm going to copy those to the clipboard, go back to level 2, click the drop down for paste and choose paste aligned to the current view. And notice that the numbers have now sequenced correctly. This is 202, 203, 204. So they're in the same order, but they picked up where we left off at 201. And now you can see why it's so important that you create the first room on each floor and number it properly before you continue. So this does take a little bit more work to do it this way, but if you've got a plan where you want to control the sequencing of the numbering, I think that is the best way to do it. Now, as I said, there are third-party programs which would assist you in renumbering. You can go to the little shopping cart icon here to the Autodesk App Store and search for Renumber, and you'll come up with a number of plugins to Revit that are available for that purpose. Some of my favorites are by CTC Software and ID8 Software, so you can try out some of those, or there's several others as well. In this video, we're going to dig a little bit deeper into the room bounding feature of rooms to show you a few scenarios that you are likely to run into when working with rooms. So the way that rooms determine their shape is because of a feature called room bounding. So when I select a room like this bedroom here and the fact that it shapes around the surrounding geometry, that is the room bounding feature at work there. And most of your major geometric elements have a room bounding setting. So if I select walls, for example, all the walls will have a room bounding feature, and by default, it is turned on. We also have these room separator lines, which we added manually in an earlier video, and that's what allowed us to shape the living room, as an example, to a custom shape, even though there weren't walls in those locations. So that's another example of room bounding. Well, there are times when an element that is room bounding by default, you would prefer not to be room bounding. So for example, there's this little low height wall that's right here that's maybe dividing this space into two. And maybe I don't want that wall to influence the shape or the size of the room. So if that's the case, you can actually select that wall element and come over here to the properties palette and uncheck room bounding. Now, when you do, notice that the living room now flows right over that wall as if it wasn't even there. So that's a really simple example of customizing room bounding. But let's look at another one that's maybe a touch more practical. Suppose I zoom in on this lower bedroom down here in the corner. And as you can see, I selected it a moment ago. It's got this shape that goes around the closet. And then consequently, that means that we have a second room here that fills in the closet area. Now, that's perfectly fine, but maybe you decided that you don't need a separate closet room, and what you'd rather do is just let the area of the closet be considered part of the bedroom. If that's the case, then what you would want to do is select these two walls here, and I'll just do that with my control key, and then come over here to the properties palette and do what I just did a moment ago and turn off the room bounding for those two walls. When I apply that, it will generate a warning. And it's telling me that I now have multiple rooms in the same enclosed region. Well, what does it mean by that? Well, the bedroom and the closet are now both in the same enclosed space. So it's telling me that one of them is going to be considered redundant, and I could optionally delete that redundant room right here. The trouble is, I don't know which one it considers redundant. Is it the bedroom or the closet? So I want to make sure that I keep the bedroom and lose the closet. So I'm going to ignore this warning by clicking OK. And then that completes the modification. If I deselect the walls and come back and select the bedroom, you can see that it did consider the bedroom to be the dominant room, which is good. That's what I wanted. And notice that it now flows right over the closet and includes that area. If we move nearby where the closet was, notice that it shows a little differently now. So the redundant room is going to have this little dashed box indicator. And if you look over on the properties palette under dimensions, you will see that several of the entries there say redundant room now. Okay, so our closet is now redundant. What do we do about it? Well, let's just delete it. However, when you do, that will generate yet another warning. So this is where it can get a little frustrating. You're just trying to do something simple with your rooms and you're getting all these warnings, and that can be a little bit disruptive, which is why I wanted to go through this process with you. So it says a room was deleted from the model, but it still remains in the project, and you can use a schedule to deal with the problem. So what do they mean by that? Well, let me just click anywhere to dismiss that warning. And we're going to talk about schedule views in detail in a future video. But for now, let's just open up a schedule that already exists here in this project. So if you come over here to the project browser, scroll down, there's a schedules and quantities branch. And there's one right here called room finish schedule. So you just double click that like any other view to open it up. And a schedule is just a list of elements in the model. So as you can see here, we've got a list of all of the rooms. Now, I'd like to put that list side by side with the floor plan. So click back over to the floor plan view, come up here to the view tab and choose tile views. And then that puts those side by side. And then you can even change the width here between the two. So I don't need the schedule to be quite as wide as the floor plan. So I'm going to readjust the screen so I can see the whole floor plan over here. And then here's the schedule over here. Now, the way a schedule works is, as I said, it's a list of all the elements in the model, in this case, the rooms. And if you select an element, it will highlight the corresponding element in the model. So notice that I can select the bedroom and it highlights on screen there. Now, here's that closet that we just removed. And the clue in the schedule that it is a redundant room, or in this case now a non-placed room, is that it says not placed. Now, if I were to click over here and do undo so that the closet comes back again, notice that it will say redundant room there. So the reason it said not placed was because I had deleted it, and that made it a non-placed room. But now the schedule is giving us the feedback we need to understand that, right? So that's why it can be nice to have the schedule open. Now, before I remove this permanently, let me show you how you could add it back to the model if you needed to. Okay, so suppose I wanted to place that closet somewhere else in the model. What you would do is click over to the floor plan, go to architecture, click the room tool, and then by default, when you create rooms, you're creating a new room right here. However, notice that any non-placed rooms, and we only have one in this case, the closet, will be listed on here as well. So I could choose the closet from the list, and now I'm placing closet 110 in my model, and I could click somewhere to place it. Now, I don't actually want to place it, so I'm just going to click the modify tool to cancel without doing that. But that's how you could place something that is non-placed back into the model. So you may be wondering why Revit bothers going through all of this. Why not just delete the room? Why is it giving me all this redundant room and non-placed room and everything? Well, if you consider the fact that rooms are invisible elements to begin with, it might be too easy for you to accidentally delete them. So by kind of adding this extra layer of steps here, it's sort of a fail-safe to prevent you from accidentally making mistakes that otherwise would be too easy to make. So whether you like this mechanism or not, I think it actually is in your best interest. And this is why they designed it this way, so that you don't end up deleting rooms that have a lot of data associated with them accidentally. So I do want to get rid of this closet after all. So what I'm going to do is click into the room schedule first, select the closet right here, and then on the ribbon that appears, there's a delete rows button here. You can click that to delete. It will warn you and say, are you sure? Yes, I am. I'll click OK. And now you'll see that closet has been removed from the list. Okay, so now we have actually deleted that room. Now, I've got one similar scenario up here for the master bath. Maybe I don't want the master bath and the linen closet to be two separate rooms. I want the master bath to include the linen closet. Well, now that we know that we're going to have all those messages and warnings and everything, you could approach it a little differently. What you could do is select the linen closet here in the schedule first, delete it. That will warn you, just like it did a moment ago. Click OK. It removes from the model and the schedule. And now that means when I change the bounding elements for the master bath, it won't generate a warning. So we can easily come over here and select this wall, scroll down, turn off room bounding. Now the master bath flows into the linen closet space. But notice it's also flowing into this little shaft area here. So assuming that you don't want that, then there's one more step. We'll go to modify. We'll use our split element tool. We're going to split that wall right at that location, then come back and select this portion and turn the room bounding back on again. And now we've got the master bath shaped the way that we want, and including the area of the linen closet. So those are some examples of manipulating room bounding and also just making you aware of some of the room bounding characteristics. So hopefully now you have a better understanding of how room bounding functions. And when you see some of these errors occur in your own projects, you won't be surprised by them and you'll know how to deal with them.
In this video, we're going to consider tags. I'm going to add some tags to this floor plan. Now, tags are just simply symbols that are hosted to model elements and report information that is contained within those elements. And we have tags for all sorts of things. In fact, we can tag just about any kind of model element in Revit, and we do so with the same tag command regardless of the category of element. So that command can be found in a few places. It's up here on the quick access toolbar called Tag by Category. You will also find it here on the Annotate tab right there, or you can simply use the keyboard shortcut TG. Now, when you run that command, you will get a little prompt that says, click to place a tag. And what it's really meaning is to click on some element that you want to tag. So what I'm going to do is zoom in the upper corner of my floor plan here. And I want to just show you the behavior of the tags without clicking just yet. So don't click yet. I want you to just sort of move next to an element. And notice that the default behavior is for the tag to appear with a leader line attaching it to its host element. So there's a square symbol for walls. Here's a little pillbox symbol for doors. Here's a diamond symbol for windows. We've got a little hexagon type symbol here for furniture, but all of those are using a leader to point back to the object. Now, sometimes the leaders are nice to have, like in the case of walls. So let me go ahead and tag a couple of these walls here. Now, this time I am clicking to place those tags. But I think in the case of things like doors and windows, we probably don't want the leader. So you have control over the leader here on the properties palette. So all you need to do is uncheck this little box right here to turn off the leader. And now when I touch one or more doors, you can see that the tag will simply appear next to the door or next to the window, depending on which element you select. Okay, now let me just do a couple more here. I'm going to do a few pieces of furniture like so, and then I'm going to click the modify tool to cancel out. So the next thing that I want to consider is the information that is being displayed in the tag. So you can see that the walls, the doors, and the windows all displayed some information. The furniture did not. Okay, so I want to discuss all of those issues. So the first thing that you might find a little surprising if we consider the doors is the numbering of the doors seems a little bit sporadic, right? Well, let me dispel one of the first misconceptions about tagging that new users to Revit often have. The assumption is that the act of tagging is what is creating the numbering, and that is not the case. The door number already existed by the time we got around to placing the tag. In other words, when you place a new door in Revit, it immediately numbers that door. All the tag is doing is asking the door element what number it is and then reporting that in the tag. So the act of tagging is not doing the numbering. It's not even required for the numbering. It is simply reacting to the number that's already there. So I can show you that by selecting this door and scrolling down here on Properties palette. And what you're looking for is this property called Mark. And there you'll notice that this door is Mark number 102. If I select this door, it is Mark 112. This one is 111. If I come over here to this door, which we haven't yet tagged, it is Mark 104. So if I return to the tag by category command or type TG and I click on that door, notice that it comes in as door number 104. So again, hopefully that shows you that the number is already there. All the tag is doing is reporting that value. Okay. Now, if I select this window and I scroll down and look for its mark, you can see it's mark 105. And this one is mark 106. So what's going on here? Why are these reporting 42 instead? Well, the other thing you need to know about tags is they're not required to ask just the one question, what's your mark? A tag can ask any question. In fact, that's the way that I like to think of tags. Think of a tag as a symbol that is asking the elements in your model one or more questions. Okay. So in the case of the door, the symbol is saying, hey, door, what is your mark value? In the case of this room element right here, it's saying, hey, room, what is your name and your room number? And it reports both values. In the case of this wall and this window, they're both asking the same question, but what is that question? Well, instead of telling us what unique item it is, which door it is, it's telling us what kind of window it is, what kind of wall it is. Okay. So that is a type property, and you can access it by going to edit type. And I'm going to scroll down, and instead of mark, it is the type mark. So notice that those two windows are mark number 42. If I change this to something else, I'm going to put in A here and I click OK. Notice that even though I only selected that one window, this one becomes a type A window as well. In fact, if I go back to the tag by category command and I tag a few more windows that are the same type, they are all now type A windows. So that change only needs to happen once, and it's going to apply globally throughout the model. Now, this is a type P04 wall. This is a type P05 wall. And you can see that they're different because with this wall selected, it says that's an interior 5-inch partition here in the Imperial file. This one is an interior 4 7/8 partition. So what happens if I take this wall and I change it to the same type as the one that we had over to the right? Notice that the tag immediately updates to reflect that change. So it's not just that you change the type value and it updates lots of walls. It also works the other way. If you change an object to some other element, it will be reflected there as well. So now directing our attention then to the furniture, what's going on there? Why isn't the furniture showing anything at all? Well, what we need to do is simply investigate what the tag is asking, what property it's looking for, and then make sure that we fill in a value for each piece of furniture. If there's no value input for the question that's being asked, then it just displays blank like you're seeing here. Now, one way that you could do it is to just try and take an educated guess. So I could select this table and I could look over here and say, well, what's the type mark? Let's put something in, right? So I'm going to put in T1 here. And you're going to see that nothing happens in the tag. So clearly it wasn't the mark value that tag was asking for. But here's another way that we could do it. What I could do is actually select the tag itself and notice that a little question mark appears. So a shortcut way to edit the values is to actually edit it directly in the tag. And this is not that dissimilar to what we've done in previous videos with temporary dimensions. When you wanted to move a wall, you were able to select the wall and the dimension activated. You could type in a new value and that wall would move to a new position. You weren't really editing the dimension, but you were using the dimension to move the wall. So here we're not really editing the tag. We're using the tag to edit the value in the chair. So I'm going to put in CH1 here. And when I press enter, it's now going to give me a clue as to what value this is because it says you are changing a type parameter. And it's also telling us this could affect many elements. Is that okay? I'm going to answer yes. And in fact, it did affect many elements because notice that this one also became CH1. In fact, if I go back to tag by category and I pick this chair, you can see that one is also a CH1 because all three of them are the same type. So now if I select this chair, I go to edit type, scroll down, and we look at the type mark, you can see in fact that it's CH1 right there. And of course, if you change it, it will reflect that change in all three of those tags. It's not possible for those things to get out of sync because you're editing the same value in both cases. So use whichever method is convenient for you, but keep in mind that it's not the tag that's important. It's the value within the object that's important. Now, this floor plan is starting to get a little bit crowded, and that is very common in a typical set of construction documents. And so there's a technique that we can use to kind of help us save a little space here. And I want to go to a different part of the plan to show you, like maybe down here. It turns out that you can have a tag that is hosted to more than one element. So I'm going to go back to tag by category. I'm going to turn on the leader line with the checkbox right there on properties, and I'm going to tag this wall right here. I'll cancel the command, and then I'm going to use this little grip control here, and I'm just going to drag it a little closer to the wall. Now, I could add another tag to this wall right here, but it turns out that this wall is the same type of wall. So what I can do instead is with this tag selected, I can choose this Add Remove Host button right here, and that's going to allow me to pick a second host, but it will allow me to pick a third or a fourth or as many hosts as I like. And as long as each host is using the same value, then it will report it in the tag. If you, in fact, choose a host that is a different value, then it's going to say varies. So I would encourage you to avoid doing that. So I'm going to remove that exterior host and keep those two. And so now I have a single symbol that's pointing to two objects, and that just allows me to eliminate some of the clutter in my floor plan. Now, another thing that I like to do, which is graphical, is with the tag selected, I like to go to Edit Type, and it's possible to include an arrowhead on these leaders. So I'm going to open up the list here, and you could choose anything you like. I'm going to choose this heavy end. I'm going to click OK, and you're going to see that it adds that nice little termination on each of the leader lines. And of course, that applies up here as well. Now, another thing I want to point out to you is that when you're tagging, sometimes you will highlight an element and it will be an element that you don't intend to tag. Like, for example, right now my cursor is over the concrete floor slab, and it's actually trying to tag that slab. Now, I don't think that's typically something we'd want to tag, but notice the tag right here. Now, if you click and you place that tag accidentally, you can always just delete it later, or you can just simply move away and it will not place that tag. If you highlight something like, say, this column down here, and click it, and there isn't a tag loaded for that category, then Revit will display this message and allow you to load a tag. I could answer yes if in fact I really did want to tag that item, and if I clicked it by accident, I could say no. Okay, so just something to keep in mind there, that each category has its own symbol that you can load in, and you can even make your own custom ones. So the final thing I'd like to show you here in this video is, what if you want to tag the rest of the elements in a particular category? Like maybe I want to tag the rest of the doors and the rest of the windows. You could touch each one, but there's a faster way. We've got this command right here called tag all, and it's actually tag all not tagged. And so this is going to allow me to select one or more categories. So I'm going to pick door tags and scroll down, and window tags. And then I'm going to click OK. And notice that I get a set of tags for all the doors and all the windows. It will not double up the objects that were already tagged. So it's tag all, not tags. So that can be a really nice way to quickly add a set of tags to the entire floor plan. So at this point, I would encourage you to experiment further, perhaps go up to the second floor and add some tags up there just to get some additional practice.
In this video, we're going to create our own schedule view. Now, what exactly is a schedule view? Well, in a lot of ways, it's not that dissimilar than floor plans, elevations, or sections. Now, let me explain. If we consider what a floor plan is, a floor plan will take a look at your model, slice through it at a certain height, gather up the elements that it sees there, and then draw them in a floor plan rendition using the symbology that we recognize as being appropriate for floor plans. What about a section? Well, a section does kind of the same thing. We slice the model in some location. We look into the model from that location, gather up the elements that are there, and then draw them as a section view. So based on that way of thinking, what about a schedule? It also looks at the model, but now instead of slicing the model, it gathers up all of the elements of a particular category and then just simply lists them out in a table. So when you think of it that way, what we're going to see in floor plans, in sections, in schedules is not that dissimilar from one another. And the most important takeaway is everything always comes from the model. So let's do a simple example here in Revit so that we can get a better understanding of this. So I want to make a furniture schedule in this project here. So I'm going to gather up a list of all the furniture elements, and then we'll be able to start analyzing that in a variety of ways. So to create a schedule, you have two options. You can do it directly from the project browser by right-clicking the Schedules and Quantities branch and choosing New Schedule and Quantities. Or if you prefer, you can go to the View tab here, and there is a Schedule dropdown, and that first item, Schedules and Quantities, would get you to the same place. The first thing that Revit wants to know in this dialog is what category do you want to schedule? So I'm going to scroll down and locate the furniture category. It will suggest a name here. I'm going to accept that name and click OK. So next we have to choose one or more fields that we want to add to this schedule. Now, in my case, I have 35 items available. Think of these as the questions that your schedule can ask. So there are up to 35 separate questions that I could ask the furniture items in my model. And you need to add at least one, but you can add as many as you need. So the first one that I'm going to add is the type mark. So most of the time on furniture schedules, we identify each piece of furniture by a type mark of some kind. Now there's a little green arrow here. You just click that to add that to the schedule. Now next, I'm going to add the family and type, and that'll place that below that. You can also double click a field to add it. So I'm going to double click the count field and then finally the comments. So I'm going to start with just these 4 fields for now, but you could certainly add more if you wanted to. And then I will click OK, and that will generate a list of all of the furniture items in my project. Now, we can make some adjustments directly here in the schedule. So column A is the type mark, and it doesn't need to be quite this wide. So if you put your mouse between columns A and B, you'll get a little resize cursor, and I'm going to stretch that over to make it a little narrower. The count also doesn't need to be quite so wide, so I'm going to make that a little narrower. But by contrast, I think it would be nice if family and type were wider than it is so that I can read the full information that's available there. If you don't like the size of the schedule, it is possible to zoom it. So you can do that either by doing Control and the plus sign or Control and roll the wheel. If you want to zoom back out, it's Control minus or roll the wheel the other way with the Control key held down. So go ahead and zoom this to a level that's comfortable for you. And then I want to tile this schedule next to my floor plan. Now, when you're in a schedule view, don't use the keyboard shortcut of WT. If you do, Revit will think you're editing the schedule and it will try and put the letters WT into the schedule. So what you need to do instead is click the button on the ribbon. Okay. And notice now that gives me a tile off to the side with my floor plan. Now I can resize these tiles with this bar in the middle here. So I'm going to make this floor plan a little bit larger, and then I'll click over in the floor plan and adjust the zoom so I can see the entire plan. Now, it's not required that you work this way with the side-by-side view, but I like to do that because notice if I select an element in the schedule, it will highlight the corresponding element in the floor plan, and I think that can be kind of handy. Okay, so now what? Well, let's say that we're looking for a particular item. Now, in this case, I was able to zoom my entire floor plan on screen, and it's very easy for me to just sort of click through the schedule and locate the item graphically. But let's say it was a much larger floor plan, and the level of zoom you're at doesn't allow you to see everything. So I'm here in the master bedroom at the moment, but I come down here on the schedule and I click this double bed that's listed here. There's a highlight in model button here on the ribbon, and that will zoom you right to the location of that element. So even on a very large floor plan with lots of elements, this can be a really easy way to locate a particular item. Should it have a hard time finding it in this view, you can use the show button here to open up additional views that might show that element. In this case, I'm simply going to close that. Now, in addition to being able to use the schedule to locate objects, you can also edit objects directly in the schedule. So if I keep this bed selected here, and maybe I want to try a different size bed in this bedroom, notice that I can open the drop down there and choose one of the other items. Now, I'm going to try the king bed first and see if that will fit. And it's probably a little too large for this room. But if I switch instead to the queen bed, that's perhaps a touch better than the double that was there before and fits the space a little bit better. Now I'm going to click over here into the floor plan, and I'll just use my arrow key to nudge that down just a little bit so that it's not touching the wall there. But I think that works a little bit better. Now, another way you can select elements in the schedule is it's actually possible to select more than one item in the schedule as long as they're next to one another. So what I mean by that is, notice that there are these nightstands here. We can select all 4 of these nightstands at once by simply clicking and dragging through all 4 items. Now, I'm only seeing 2 of them at the moment in the plan, so I'm going to zoom the plan back out again and pan so that we can see all 4. And now you can see I've got all 4 of those highlighted. Now, unfortunately, if you click the drop down and try to change the type, that will drop the selection. So you can use the schedule to make a multiple selection, but you really need to use the floor plan to edit it. So let me show you that again. I'm going to click and drag through all the nightstands. Before I try and change anything, I will click over here to the floor plan. Now, I usually do it by clicking on the tab so that I don't accidentally deselect anything. Notice over on the properties palette, it still says furniture 4. So that's telling me I still have those 4 tables selected. And now I can simply open up the type selector here and choose a different size from the list. So I'll go from the small to the large, and it will change all 4 of those. And notice here on the schedule that they're all changed here as well. So this is what I was talking about the schedule being just another view of the model. It is not possible for information in the schedule to get out of sync with the floor plans or the sections or the elevations because you are looking at the same model. The right-hand side of my screen is showing a graphical view of the model. The left-hand side of my screen is showing a tabular view of the model, but it's still the same model either way. Let's make 1 or 2 more edits here. In addition to being able to select elements and change the type over here, I'm also able to edit many of the other fields. So I'm going to click in the type mark field here next to the Corbu chair and type in a designation for that, such as CH1. When I enter that, it will say this change is going to apply to all elements of that type. And I'm going to answer OK. And notice that that fills in 2 fields in the schedule because both of these were the same Corbu chair. They must share the same type mark designation. And in fact, you could repeat that by filling in additional items, and notice that the Breuer chair is used in many locations throughout the model. So that filled in several spots. Now, if you prefer, there are other ways you can modify that same information. So if I come back into my floor plan and maybe select this sofa right here, I could go to edit type. I could go down to the type mark property. I could put in a designation. When I click OK, it will fill that in over here in the schedule as well. So just another example of this being the same model showing the same information in both places. So using either of those methods, go ahead and fill in the type marks for the remaining furniture elements. And when you're done, it should look like this. In this video, I want to share with you a few common techniques that you can use to modify existing schedules. And the aim is to make them convey the information maybe in a clearer way, make the information that they're trying to convey a little bit more evident to the recipients. So we're going to look at things like sorting and grouping and things of that nature. So this exercise file actually opens up with 2 views. So you'll see here that I've got a floor plan and the schedule open. Now, I just want to remind you that if the schedule view is active and you want to tile 2 views, you want to avoid using keyboard shortcuts, because if you type a keyboard shortcut in a schedule view, it's going to start trying to type the keyboard shortcut that you're typing into the schedule. It's going to think you're editing the schedule. So what I'm going to do instead is go over here to the View tab and click the Tile Views button instead of typing WT. Then I'm going to resize the column here between these 2 tiles just to make the floor plan a little bit larger so that I can see the entire floor plan. The first thing I want to talk about is where this schedule view sits in Project Browser. So if you look at your Project Browser here and you scroll down, there is the Schedules and Quantities branch. If I scroll down a little bit further, you're going to see that there's a few sub-branches like Schedule Typical and Schedule Working. Now, the name of this branch here says it's by type. If you select right on that, you can see that there's more than one option to group the views in that branch of the browser. We can either do all, which just does a flat list, or in this case, by type, where it's sorting by these subgroupings. In the case where you haven't assigned a type yet, which is the case with our furniture schedule, it will just go in this none branch here. So if I want to move it out of none into one of these other two branches, it's as simple as selecting the schedule and then looking up here on the properties, and the type in this case is actually the view template that's assigned to the schedule. So you may recall view templates from an earlier video. If I click the none button here, you'll see that there are two view templates that I can choose from that apply to schedules. So I want to choose schedule typical. And unlike the view templates that we use to apply to graphical views like plans and elevations, these only have a few parameters in question. But what the result of this is going to be is twofold. When I click OK, the none branch will disappear and furniture schedule will jump up to the schedule typical branching instead. And notice that the title on the schedule has changed to become this large, bold text. So the view template is assigning those properties as well. So it's just an easy way to assign those graphical standards to the schedule and to get it grouped into the desired location on the project browser. So the next thing that I want to consider is in the schedule itself. If you look at column A, the type mark column, you'll see that there really doesn't appear to be any rhyme or reason to the way that this schedule is organized, the order that the items are in. You can see that it appears kind of random. And in fact, it isn't completely random, but the order that they're in isn't necessarily useful either. Items and schedules just appear in the order they were created unless you tell them otherwise. So the order that the furniture was created in doesn't really give me any useful benefit. So why don't we resort this schedule based on something that seems a little bit more logical? Now, to do that, you want to make sure that the schedule view is active, and then scroll down here on the properties palette, and you'll see several edit buttons down here. I want to click the one next to sorting and grouping. And in this dialog, you will see drop-down lists that will contain any of the fields that you can use as sort from this schedule. So I'm going to choose type mark. I think that's the most logical choice. And then I'll click OK. And notice that that rearranges the items in the schedule based on their type marks. Now, if you go right back to that edit button, you can make that ascending or descending, depending on your preference. I think ascending makes the most amount of sense here. Now, in addition to being able to sort by the fields, you can also group by them. So the way grouping works is you add the header checkbox here, and when you click OK, you'll now see these little separations where it's grouping the elements that are in common, in this case based on the type mark. And you can see that that makes a lot of sense or works really well for things like the chairs, where I've got this little group now of CH2. For individual items like the beds or the dressers, it's maybe not as useful since there's only one in each of those groups, but nonetheless, it's still adding a little bit of separation between each different type of furniture element. Now, if you want to add a little bit more space to make it even perhaps a little bit more legible, you can introduce a blank line, and that just adds some white space between each group. Now, once you've done that, the schedule might be starting to exceed the length of your screen here. So notice that as I scroll, the header in my case is going off screen. Now yours might not be. It really just depends because there's a setting on the ribbon that controls this. So on the modify schedule quantities ribbon, there is a freeze header button. If you click that, it will stay persistent. So once you turn that on, it should remain on until you turned it off. But now the way that works is any schedule will keep its header at the top of the screen as you scroll through the data. And I think that's usually a nicer experience. So I'm going to recommend that we turn that on. Okay, so those are some of the sorting and grouping options and other sort of graphical things that we can do to the schedule. Let's consider column C next. Column C is a numerical column. That's our count. And numerical data is usually justified to the right. But notice that in this case, it's justified to the left. That's just the default for schedules. So If we go back and consider all those edit buttons again, there's one next to formatting. I'm going to click that, select the count column, and then there's an alignment option right here. I'll change that to right alignment. I'll click OK. Center is also an option. And now I think that looks a little bit better for numerical data. And since I'm focused on the count, now it occurs to me that maybe instead of the sorting and grouping that I've done, what might make this schedule even more legible and useful is if instead of listing out 10 separate broiler chairs with a quantity of 1 each, it might be nicer to have a single line item that says that CH2 contains 10 items in the model. So the way that you do that is actually very simple. Go back to sorting and grouping, and we're going to uncheck itemize every instance. And when we do, you're going to see that now all those groups collapse down to individual line items, and then total is what we see here in the count column. And notice that clicking on that is now selecting all 10 broiler chairs or all 4 of the nightstands. So that single line item represents multiple objects. Now, once I've done that, I think I could go back to sorting and grouping and remove the header and the blank line because I don't think that's serving very much purpose anymore. And when I click OK here, you can see I get a much tidier list that just lists out each item and what its count is in the count column. And I think that's a lot easier for us to visually grasp and to understand. Now, I'm going to go back to sorting and grouping one more time and add a grand total at the bottom. And it can be nice to have that as well so that you don't have to manually total up the items. And you can see that this model now contains 26 elements. Now, it's not that I don't trust that 26 elements, but I do want to quickly verify. So I'm going to come over here to the floor plan, and I'm going to show you a really quick, easy way that we can just do a gut check and make sure that that number matches. Make a selection around the entire model, and then go to the filter command. Now, you may recall that in the filter command, each category of element that you have selected gets listed, and then there's a count column over here. Now, this is where you might look at this and say, something seems wrong here. The grand total in the schedule is 26, but here it says I only have 16 furniture items. Well, I kind of did this on purpose because I wanted to point out that one of the families that we're using here, specifically the round table family, is something called a nested family. So that round table family contains within it the chair family. And the schedule is able to see right into that family and report both items. So it's reporting the table family as a piece of furniture, and then the 6 chairs around it as 6 additional pieces of furniture. And then the same is true for this one here. So there are 6 chairs here and 4 here for a total of 10. And so now if we compare those numbers again, hopefully it's going to check out and make more sense. Here it says we have 16 items. That's the top level selection, but the schedule is going into the nested items as well and adding the 10 additional chairs. So it all checks out. And by the way, if we had just looked at the category right below furniture, we would have seen that there are 26 furniture tags, and that matches as well. So it also checks out that way. So anyway, just a couple ways you can quick do a verification and just make sure that you're seeing the data that you want to see. Okay, so it's always a good idea to just do those little gut checks every so often. All right, so now that we've kind of changed the way the schedule is sorting and grouping, and we've kind of gotten a better handle on the data that we have in our model, it's really easy for us to understand now not only how many pieces of furniture we have in the project, but how they're distributed. But that's not where the schedule needs to stop. Okay, so what I would like you to start thinking about is schedules aren't just for those reports that you create once and throw on a sheet somewhere and forget about. Really what a schedule is, in my opinion, is a window into the eye in your BIM. This is where all the information in your building information model lives. And so if you start thinking of the schedule that way, then you can look for opportunities to create alternative versions of the same schedule that expose different kinds of information and give you different insights. So what I'm going to do is a quick example here. I'm going to click over into the Furniture Schedule tab, right-click the Furniture Schedule, duplicate it, and then I will just change the name right here and just add by manufacturer to the end of the name. So what I want to do instead here is I want to, instead of focusing necessarily on type mark like we're doing here, I want to focus on manufacturer. And to do that, I need to add a field to this schedule. So I'm going to scroll down, go to fields, locate the manufacturer field, and I'll add that in. Now, I don't really care where it goes because I'm immediately going to go to sorting and grouping, and we're going to sort by manufacturer, make it a header with a blank line. Then we're going to sort by the type mark. Okay, so we're basically moving type mark down one. Then I'm going to come over here finally to formatting, select manufacturer, and make it a hidden field. And now let's click OK. And what you see now is I've previously assigned some manufacturer information to the furniture items in this schedule. And because that information exists, I'm now grouping the schedule by the manufacturer. So it becomes very easy for me to see each manufacturer and what they're going to be responsible for in the project. And that's just a simple example of how you can vary the schedule. I challenge you now to think of other ways that you can reorganize the schedule or create an entirely different schedule to start surfacing other kinds of useful information in the project. And I think once you get the hang of doing that, you're going to find that the schedule is one of the most powerful tools in the Revit software. In this video, we're going to discuss some techniques for data input in schedules, and I'm specifically going to focus on a tool called a key schedule. Now, key schedule is a great tool to help you speed up the input of lots of similar data, and it allows us to do so not only more quickly, but with a great deal of consistency. So let me start off by framing the problem here. I've got this room finish schedule. If I scroll down to the bottom here, you can see the grand total at the bottom is 153. So this project contains 153 rooms. And I have a total of 4 finishes that I want to fill in for each room: floor, base, wall, and ceiling. Therefore, that's going to be a lot of data input. So, for example, if the entry was using hardwood floor and I put that in, and then maybe this living room is using carpet, and I put that in, and the kitchen is using ceramic tile, right? Do you see how I would have to spend an enormous amount of time now because I'm typing in these values in each of these fields, 4 per room times 153 rooms? It's going to take quite a bit of time. So what I'm trying to do here is speed this up in logical ways. So the key schedule is going to help me assign groups of finishes that I can group together under a key, and then I can assign them to the rooms in more of a batch kind of way. So let's take a look at that. But one thing I want to point out before I start building the key schedule is one little thing that will help speed input is Revit will remember what else you've typed into these fields. So if I start typing the letter C, for example, it will start to suggest other values in this field that use that same keystroke. So then I can just simply choose it from the list. Of course, you can also just open the list and choose it as well. So those two techniques will speed things up, but not enough to really make a huge difference. So let's move on to the key schedule. So to create a key schedule, it starts off the same as creating any other schedule. I'm going to right-click the Schedules and Quantities branch and choose New Schedule and Quantities. Scroll down and locate the category that I want, rooms in this case. And then over here on the right-hand side, I will choose Schedule Keys. Now, it suggests some names here, and I'm going to adjust those names slightly by slipping the word finish in before style in both locations. And then I will click OK. So this displays the schedule properties window, and we're on the fields tab, and there are only 11 items listed here because a key schedule is limited to instance properties. So each of these values is eligible because they are instance properties. Now, what I want to include in this schedule are the 4 finishes that we see here in the background in the order that they appear. So I'm going to start with floor finish, then I'm going to go to base finish, wall finish, and finally ceiling finish. And then let me move this back up and click OK. And that creates an empty schedule. So next thing that I want to do is use this Insert Data Row button here to create my first entry. Now, it suggests the key name 1, but we can use descriptive names. And so the name that I want for this first item is unit service. Then I will click Insert Data Row again, and I'll do unit public again and unit private. And finally, one more time, building public. Now, that should be enough for our purposes here, but you could certainly create more of these if you wish. Now, the first thing that you'll notice here is that the drop-down menu works here as well. So any previous values that you typed in will show here, and so I could simply choose them off the list. So for the unit public spaces, I'm going to use hardwood floor, and I'm going to combine that with wood base, and I'm pressing the tab key to jump to the next field, paint for the walls, and gypsum wallboard for the ceiling. For the service areas in the units, I'm going to do ceramic tile on the floors. I'm going to do vinyl base for the base. I'll do PT2 this time, and I'll stick with drywall ceiling. And in fact, I'm going to use the drywall ceiling here as well, but in the private spaces, I'll go with carpet, wood base again, a different paint, and finally, for our public areas in the building, we'll do our ceramic tile. Maybe we'll do a different vinyl base, a different paint, and let's do a different ceiling this time, acoustical ceiling tile. So it's not important that you put in exactly the same values as me, but it is important for the example if you fill everything in so that you can see the full benefit of using the key schedule. So now I'm going to click back to the room finish schedule and show you how we can apply that key schedule to this overall schedule. So come over here to properties, locate the fields area, click the edit button, select the field where you want it to go. So whatever you have selected here, when you add the field, it'll go after that. So I'm going to select the name field, locate my room finish style, click the little green arrow, and it will put room finish style after name. And when I click OK, you will now see that we have a new column in our schedule. And currently all the entries say none. Okay. So that is simply because we haven't filled anything in yet. Well, now watch the way this works. For the entry spaces, those are unit public. So I will simply select unit public from the list, and it will fill in all of the other entries. The living room is also unit public. The kitchen is unit service. The bedrooms are unit private. And as I start to fill this in, you can see that this is going to speed things up considerably over doing them manually. More importantly, it's also going to do it consistently. So I won't have to worry about typos because when I choose one of those entries, it does all the typing for me. Now, as we've already said, there's quite a few rooms in this model, so I still have an awful lot of work to do. So can we improve this even more? And the answer is yes. If you think back to the earlier video where we talked about modifying a schedule, I mentioned to you the importance of remembering that you could have more than one schedule for the same items to use for different purposes. Well, in this version of the file, I have a working version of the room schedule right here, which I'm going to double click and open up. And this one is set up a little bit differently. The limiting factor back in this schedule is the room number. So that makes each entry unique. But what I really want to do is assign the finishes more by room type. So in this working version of the schedule, I've removed room number and sorted and grouped based on room name. So now this single entry here called bathroom accounts for 10 rooms in my model. So if we repeat the steps that we did a moment ago and go to fields, select the name here, select the room finish style, add that as a field and click OK. Now we get the room finish style available here. And if I say that the bathrooms are a unit service space, it fills that in not just for one room, but for 10. The bedrooms are a unit private space. The dining room is a unit public space, And if we come back to our original schedule here, and as you scroll through, you can see that it's now filling in that information across the entire building, which is a lot nicer than what we had a moment ago. Now, we get to an item like this garage, and we realize that we don't have an entry for that. So you have two options. You can go back to the finish schedule, the style schedule, and add a new style. Or you can just simply type these values in and leave this set to none. So if it's not none, you can't edit them. But if it is none, you can just type in whatever you want. So it's easy enough to do one that's a one-off without having to create an entirely new key. So either method is fine. It's just a matter of how you want to handle it in the specific situation. So let me take a moment to fill in the rest of these entries here and take you back to the original schedule when I'm done here. And you can see that we've now made short work of this very long schedule. But there's one last thing I want you to see here. One of the really powerful benefits of using a key schedule is that if you decide you want to make a change, let's say that we want to use a different ceramic tile in the units, we can go back to the room finish style schedule. And I'm going to take the ceramic tile that's assigned to units service, and I'm going to change that to ceramic tile 2. And now if I go back to the room finish schedule, that has filled in everywhere that we were using that key in just a single step. So it's not just a one-time modification to speed up the input in the schedule. It remains an ongoing and persistent setting, which means that the key schedule will help ensure a great deal of consistency moving forward. So very powerful tool for use in any project that has a lot of data input.